Hi folks, welcome back to the channel. For those of you that are new here, I'm Johnny Chivers. I am an AWS Solutions Architect with over 10 years experience working in the field with customers across numerous industries. In today's video, over the next 5 or so hours, we're going to take a look at the information that is required by you in order to sit the AWS Data Engineering Certification Associate exam. This isn't a comprehensive course, but it should help you through the process of identifying skill gaps, learning AWS services, and taking a look at AWS from a data engineering perspective. What I aim with this course is to get you hands-on as much as possible, but we will be doing a series of theory as well. Everything is rolled up into a GitHub, including a README that takes you through each section and the code and data required. On top of this, I've made the slides available inside that GitHub as well. Then, outside of the GitHub, I also have a revision aid, over 100 pages in a PDF that goes into more depth on each services and different things that you might need to know for the AWS certification as well. It's not mandatory to have this to sit through in this course. It's just something extra if you really want to dive deep that's available for you to download. I have also created a practice test for this certification as well. That's available on Udemy. We will take a look at one of the questions during this course, but if you want to practice on exam conditions, if you want more exam-like type questions, then the link's in the description and you can go and work through Udemy on those questions as well. Again, not required for this course on YouTube, but something that you may want to look at as you go towards the exam itself. So with that being said, let's take a look at what we need to do first. The first thing we're going to do is a little bit of setup work with our AWS accounts. Yes, you will need an AWS account to do the hands-on portion of this video. Don't worry if you don't have an AWS account or you don't want to go outside the free tier. You can just watch me do the hands-on labs when it comes to that. But if you do have an AWS account and if you're willing to go outside of the free tier, then feel free to follow along. Alongside that, we'll be using the GitHub as we go with the slides for the theory. Again, there's a lot of information there, more than I will cover when I'm speaking, so make sure you read through that thoroughly. Apart from that, just be cautious that you will go outside the free tier. I will mention when we're leaving the free tier, I have tried to minimize these costs the best I can, and I will give you a description where plausible of how much it actually cost me to run that part of this course. So with that all being said, I would really appreciate a like and subscribe to this YouTube channel. Helps me make the content. Let's jump onto the AWS console. Well, actually, let's jump onto the GitHub first, get a download, and take a look of what we're going to do and a little bit of setup work as well. Okay, folks, the first thing we're going to do is a little bit of setup work. This is for resources that we'll use throughout the tutorial, so we'll be reusing these constantly throughout the next few hours. As you can see by the introduction setup section on the README that is available on the GitHub. Again, please have downloaded the GitHub so you have a copy locally as well, because we will be using those resources to upload to AWS. You can see that we'll create a VPC, public subnets, security groups, routing tables, and an S3 bucket. This S3 bucket we will use throughout the tutorial and will act as a place to hold data. Once it's all created, which will take a couple of minutes probably using AWS CloudFormation, we will then create a folder structure or a directory structure inside the S3 bucket. This will include things such as raw data, process data, and script location. Don't worry if you're not that familiar with AWS CloudFormation. This is a service from AWS that helps us create resources via code. I have wrote the code that we will need to actually create these resources. The idea being that it's just quicker for all of us to get on to the actual hands-on bit of this tutorial in reference to data engineering. If you navigate to the setup code folder, you'll see a setupcode.yaml. This creates all the resources that we'll need for the introduction start, and then we'll have to manually add the folders and the data to the S3 bucket once everything is created. So next step, make sure you are logged into the AWS console. It should look a bit like this once you're logged in. And we are going to navigate to CloudFormation. So if we type in cloud and we go to CloudFormation, you can see here that you can click and we end up in CloudFormation. Ignore everything on my screen. These are all previously created CloudFormation templates that I've ran before in the past. We're going to create something new from scratch. Over on the right hand side, if you click create stack, then with new resources, we are going to use a existing template. This template will be uploaded locally. So that's an upload a template, and then we're going to go choose file. So again, I will reiterate one last time. Please have a local copy of the GitHub downloaded and unzipped. we're going to go to choose file. We are going to go to setup code, and we're going to go to that setup code.yaml. Open that file and then go next. On the next screen, we're presented with a series of input boxes. We have to do a little bit of work here. So the stack name, you can call this anything you want. So I'm just going to call this Data Eng Johnny Chivers tutorial. That should do the trick. You can call this anything that you want. Environment name, this is just something I add sometimes to know what I'm doing. So I'm going to call this dev. Then we'll have public subnet and public subnet 2. Leave these as the defaults if you don't know what you're doing. I've created these deliberately, so I'm just going to leave them as the defaults. They should all work for you. We do need an S3 bucket for the course, and we need to give this a name. Now, S3 bucket names must be unique within the entirety of AWS for anyone creating a bucket. That means you have to enter something that is unique to the entirety of AWS. This CloudFormation script will fail if this is not unique, and you will get a warning about the bucket name not being available. So please call your bucket something that you will remember and something that you think will be unique. For me, I always like to use my name. So Data Engineering Johnny Chivers Tutorial. If you were to replace this with your own name, it would be getting highly likely that the bucket name will be unique. And you can always add just a few numbers and a few letters on the end as well. And this will guarantee some of its uniqueness. So that's what I do to get around this. Just enter a name and then some random numbers and letters at the end. So then go next. And then all this should be default. I should mention that I have admin permissions on my role that I'm using on the console that I'm signed into. If you're using your own personal account and you're using your root user, you will have this already. You may need additional permissions if you're doing this elsewhere, but for me, I have full admin permissions. So if you're doing this in your own AWS account, you should be able to follow along. Then click next, and then when you go the whole way down the bottom, just go submit, and this will run off and create. You will need to refresh this, and you'll see that things go into progress and configuration will start. Now, because we're spinning up a VPC, it will take a little bit of time. Sometimes this can be 5 minutes, sometimes this can be 20 minutes. What I'm going to do is pause the video and wait until it's successful. If any of this goes red throughout, that means that something has failed. Most likely it will be the S3 bucket name, but you will get a message to tell you what's going on. So I'll pause the video and then we'll pick up once everything is created. Okay, after a few minutes, you should have a green complete over here and a green complete the whole way down here. You can check that by hitting the refresh icon or the refresh icon here. If we quickly look at resources, you'll see all the resources that were created during the execution of the CloudFormation script, and the outputs here have some information that we'll need throughout the tutorial as well, so I have selected them as outputs. If we go back onto the GitHub and we look at the next set of things that we need to do, there is a little bit of manual work to set up the S3 bucket correctly. I'm going to guide you through that now. So back on the AWS console, and we are going to navigate to S3. So type in S3 and select it. Then you need to find the bucket that we have just created. So I called mine Data Engineering Johnny Chivers Tutorial with some random letters. I'm going to click into that. And this is the bucket that we have created during the execution of the CloudFormation script. Next thing we need to do is create folder, and we just have to do this a couple of times. So bear with me, this can take a little minute, but we will get there. We need one called raw data, so we're just going to call that raw data. Please follow the same nomenclature as I'm doing. All this can also be found on the GitHub README, where you can just copy and paste it in. So the next one we need to do is process data. Let's create that folder and call it process data. Then I'm going to cheat again and go back and just grab script location because we're going to need that as well. And we go create folder and we call that script location. Oh, I've spelled that wrong. We'll go script location. Just put a T on that. I'll fix it on the GitHub as well, so you will see it be uploaded correctly. Create folder. Then we're going to need temp directory. And again, we'll just create that folder and we'll call this temp directory and create the folder. And then finally, we're going to need Athena as well. And Athena and create a folder. Inside the raw data folder, let's click on this and we are going to need to upload our raw data. So select upload and then click add folder. Again, add folder. This is my local download. So I'll say this again. This is my local download. You want to go to source data and we just want to take all three of these folders actually in one go. So we'll add the customers one. Then we'll add a folder and we'll add the employees one and upload. And then we'll add a folder and we'll add the orders one and upload. Okay, so we have orders, employees, and customers. You'll see that the folder is there, orders, employees, customer, and you'll see that we're uploading 3 CSVs as well. Again, this is all from the local copy of the GitHub I have downloaded. And then we want to upload. This will take a few seconds, not too long, but once it's uploaded, as you can see, it's succeeded. You can close that, and you can see here we have 3 objects. If we go into customers, we should have a CSV file. If we go into employees, we'll have a CSV file. And just for reference there, I'm clicking up here. If we click back there, then we go to orders, we'll have a orders file. Okay, that's the setup work done. We'll be using this bucket throughout the tutorial alongside those VPCs and subnets plus the other resources we have created. Okay, excellent. Now we've done that setup work, what we're going to do next is work through each section that you can see listed in the README in order of the README. Slides are also available on the GitHub, so you can sit with them on screen, or you can just watch my screen and make notes as you go. Again, reminder, there is a supplementary revision aid that covers this in order as well. If you want even more information when it comes to identifying the knowledge gaps and trying to plug those knowledge gaps. A reminder that this course is not comprehensive of everything that you may need to know for the exam. I have done my best to gather as much information as possible and then make it relevant to data engineering. There's a recommendation that you have at least 2.5 years of experience in AWS before you sit this certification. Having went through it myself, I also see the need for that. If you don't have that experience, then make sure you spend time learning each of these services outside of this course and outside of many other courses. So with that being said, let's jump onto my computer and start the course. Okay folks, that's me on the slide deck. So I'll be using a mixture of slides and practical and theory throughout this course. The deck itself is available to download from the GitHub. However, I will be using supplementary notes which are available on the revision guide. There's a lot more detail there and it goes into a lot more depth and kind of the individual points. It's not required for you to use the revision guide, but if you want to support the channel, it is available to download on Buy Me a Coffee. So the first thing when you look at the AWS Data Engineer Associate exam is that you have to understand the types of data. So the types of data that we have first off is structured data. Structured data is organized in a predefined manner, which is searchable using basic algorithms. It is stored in tabular formats and the fields are discrete and defined. Examples of this would be the likes of MySQL or PostgreSQL. These are types of databases that you may be familiar with in your everyday work as a data engineer. We also have Amazon Redshift. This is a data warehouse. We'll be covering this in its own part of this course, so look out for that. It's something you will need to know in depth for the exam, and that's a type of structured data that you would store in there in the forms of tables. And then we have the enemy of every data engineer, spreadsheet. So again, that kind of structured format with columns and rows and headers. Then away from structured data, we have unstructured data. So unstructured data does lack a predefined manner or organization of structure. It's not easily searchable or analyzable using traditional methods. It can cover a wide variety of data types and also a wide variety of formats. Examples of this would be the likes of text documents where we have endless text. So there's no structure to that. It's just how the writer wrote the text in the document. Multimedia files, for example. So if we think about this audio recording that I'm doing right now, we could take that, transcribe that wave pattern and then analyze that. But there's no structure to the actual wave pattern itself. It's just my voice coming out with random sounds. Social media posts. So how people or individuals type on social media and even between social media. So how someone does Twitter versus Facebook versus Instagram is completely different. And then we have emails as well. We're not talking about the email as a concept. We're talking about the body of an email. How someone actually writes an email. Is it formal? Not formal? How do they structure their sentences? All of that is unstructured data because how they form that email is up to the individual. Then thirdly, the other type of data that you need to know about is semi-structured data. This is kind of a catch-all bucket. So it's got elements of both structured and unstructured data. It doesn't neatly fit into a tabular format, so it doesn't fit into like an Excel sheet if you visualize that in your head, but it does have some organizational properties. These are usually tags or markers. So good examples of this are XML files because you have the tags in it. JSON because it is key value pairs, so you can have your key and then your value is just a string of whatever you want it to be. So you've got the structure from the key, but the value itself is then the unstructured bit. NoSQL databases like DynamoDB, and then you have HTML as well, which is used for coding websites where you have things like your header tag and your body tag, but the actual text maybe would be unstructured itself. So you've got structure and the kind of overall blueprint of what you're doing with HTML, but the actual context or the actual content inside the HTML itself would be unstructured data. The exam or certification also needs us to know a little bit about the properties of data. These are probably things that you've came across in your everyday life as a data engineer, so nothing should be new here, but they're known as the 3 V's of data. That's volume, velocity, and variety. So volume, velocity, and variety. Let's look at each one of these individually now. So the volume of data. The volume of data is defined as the scale or quantity of data being generated, stored, or processed. Obviously, this can range from small amount of data in the megabytes right up to a large amount of data in the terabytes or even petabytes of data. It does require scalable storage, and it does mean that you need to manage this large volume of data effectively and efficiently. And these are things that the data engineering cert will ask you questions around, like about the volume of data you have and whether you can pick the correct AWS service to handle that volume. So some things that you need to know when it comes to the volume of data: there are challenges around storage management. How do we actually store that large amount of data inside AWS or outside of AWS for that matter? But obviously for the purposes of the AWS certification, you should be thinking in terms of AWS. The processing power required to actually process that data and store it because of the volume. So we're talking about the size of the data. And then there's also the data integration challenge. How do we integrate large volumes of data together? What's the governance structure like? What AWS services do we have to help us? So thinking about this in terms of AWS, storage management for large volumes of data, usually you might go to S3, Redshift, something like that. Transactional volumes of data, you might be thinking more along the lines of RDS. Processing power, again, depending on the volume of data. So if you have large quantities of data, you might be looking at something like Amazon EMR, the Elastic MapReduce service, to use something like Spark. If you have lesser volumes of data, you might be looking at something like AWS Lambda, which is a serverless solution for compute. And then data integration, well, that's going to be down to how you catalog the data, possibly using the AWS Glue data catalog. Again, we'll cover this inside this course. Or things like maybe AWS Data Zone that makes the sharing of data between data owners easier, which is a newer service provided by AWS. So these are the things you need to think about as you go along when it comes to volume. After volume, we have the velocity of data. The velocity of data is defined as the speed at which data is generated, transmitted, and processed. So when it comes to the speed of data, you've got to think about 2 things in my head that constantly come up. Is this needed or required for real-time processing? And what is the latency on that data? These are 2 things that you'll have trade-off in terms of cost when it comes to AWS. So again, thinking in terms of the data certification, if you hear real-time processing, then you're probably going down the rooms of some sort of stream or messaging service possibly. And latency, when we hear no latency or near zero latency, we're going to have to think about large compute. But if we can live with latency of like a day, then we've got to think more in terms of batch. So that's how you need to think about velocity when it comes to the AWS certification. And then we have the variety of data. So the final or third V is the variety of data. The variety of data is defined by the diversity of the data types, formats, and sources. Of course, with variety comes challenges. There's the data integration challenge again. Different data types are harder to integrate. What AWS services help you do this? So thinking again in terms of AWS, you might be thinking in terms of AWS Glue, lets you change the data types, store that data. And again, we'll be covering AWS in this tutorial, or AWS Glue rather, in this tutorial. So if you're new to these services, don't worry. I'm just trying to get your brain thinking at this point. We've also got data quality challenges. Is the data we're putting in reliable? Again, we'll cover some services during this course that can help you with that. And then there is the interoperability of the data itself. When we put data inside different AWS services. How does this fit together in terms of the architecture so we can use that data stored in different places that looks slightly different together? Is there a way we can bring things together to make it easier to use based on the data types that we have? So that's the 3 V's. Bear them in mind throughout the course, and when we're doing the AWS certification and looking at some of the exam questions later, these are the types of questions you need to be asking yourself as we go along. Okay, next section, we need to talk a little bit about the fundamentals of data warehouses, data lakes, and data lake houses. So firstly, the data warehouse. So the data warehouse is a centralized repository that stores structured data from multiple sources. It is designed to support business intelligence activities, analytics, reporting, these types of things. One of the primary features of a data warehouse is schema on write. This is where the data itself is transformed, cleaned, and structured before loading into the warehouse. That means that the schema is checked on the write. Typically, it stores structured data like tables, rows, columns, so you should be familiar with this if you've been doing at least data engineering for 2.5 years, as the certification recommends. If you're not, go have a little look at what the structured data is back in the structured section of this course. Typically, it's optimized for fast query performance and data retrieval, and then it ensures data integrity and consistency through rigorous schema enforcement. So the schemas are enforced and therefore the data has integrity. Examples, Amazon Redshift, again this will come up throughout the course and we'll cover it. Snowflake, you may have heard of that, that's another big data warehouse provider, and Google BigQuery would be another one. So there's 3 examples off the bat. A data lake, or a data lake, on the other hand, is a centralized repository that allows you as a user to store all your data, both structured and unstructured. So there's difference, unstructured data this time, as well as structured, at any scale. So this can scale out to petabytes. It's designed to store raw data in its native format, but you can also perform ETL. Difference here is that it's schema on read. So the schema isn't enforced when you write, usually in a data lake. It's only enforced when you read the data. That means you can put anything into a data lake and then try and read. Second, there are various types of data or data structures stored within a lake, so it can actually store all data. Any format that you want can be stored inside a lake, both structured and unstructured and semi-structured and even documents. They're highly scalable, so that means that they can handle vast amounts of data. This is because the storage is separated from the compute, so storing things and computing things are different, and it allows for data exploration and experimentation. Examples of this would be Apache Hadoop, S3, this will come up throughout the course again, where you can use S3 to form a data lake, and Microsoft Azure Data Lake Storage would be another example of a data lake in the cloud, this time from Microsoft. The data lake house. So the data lake house is kind of the newest of these 3. So a data warehouse has been around for years and years and years and years and years and years, 20, 30, 40 years. The data lake is kind of newish in comparison, maybe like 10 years now. I can't believe it's been around for a decade. And then kind of out of the data lake came this thing called the data lake house. And the data lake house combines elements of data lakes and data warehouses, hence Lakehouse. And it provides a unified data platform that provides both structured and unstructured data. Things that kind of make a data lake house is that structured, unstructured data. It lets both happen, schema on read and schema on write. So schema on write is where you check the schema as you write, which would be the traditional data warehouse. Schema on read, on the other hand, is more data lake, so it lets you do both. It allows you to do real-time analytics as well, so you can actually do real-time analytics on the data, and it minimizes the data movement and duplication because you've got the benefits of the warehouse and the lake together. And therefore that means that you don't need to move the data between 2 systems. Of course, a lot of this is all theory, and really you might end up using one over the other or all 3 of these inside your data kind of strategy. There are limitations of each. If you're not familiar with data lake houses, then the big example is Databricks. If you know Databricks, it's a data lake house, and another one would be Google Big Lake. Again, if you're not familiar with the concepts of this, I would advise you to read up on them before the exam. So the key differences, and this table can be your holy grail. I won't go through it all, but some of the stuff that you probably should know is the data types. So when you're thinking in terms of the certification and you hear large amounts of data that is structured and you need to do analytical queries on it and you need to check the schema as it's being wrote, then that's a data warehouse. If you're trying to store structured and semi-structured and unstructured data, then you should be thinking more like the data lake. And if that's allowed for schema on read, and maybe you're in the petabytes kind of size of data, and then you think data lakehouse when you need to achieve both. If you look down here, you can see as well that strong data governance with the data warehouse, less defined with the data lake, and then you kind of get both with the lakehouse. Cost is always going to come in as a factor. The advantages of a data lake is that it's reasonably cheap to store your data versus a lakehouse. So again, thinking in terms of the certification, if you get a cost question around storing unstructured data and you need the lowest cost, then you should be thinking data lake. If it's willing to take a high cost because you need performance in terms of analytics, then you should be thinking lakehouse. Looking at this table, take it in, and then these are the kind of questions that you start to form in your mind. When should I use one over the other for the certification? Next, we're going to briefly cover the data mesh. This is the newest kind of data architecture or data pattern that's taking the world by storm. There's a really good book on this called The Data Mesh. I won't be able to cover everything about a data mesh in these next few slides, but hopefully it gives you enough basic information that you require for the certification. So the first question is, what is a data mesh and what does it try to solve? So before the data mesh, or probably where you are today, or most likely are today, things look a little bit like this. We have data sources A, B, and C. So A could be a flat file, B could be our Postgres database, and C could be a third-party API. And we ingest all this data into a centralized repository. This is usually done through ETL. The people who own this ETL procedure typically are like a centralized team of data engineers or ETL developers, and someone comes to them from the business and says, hey, I have data source A here that is a load of files. Can you take these files, ETL them into the central repository? And that's so someone on the end out here can maybe do some BI reporting on them. And that's the way things have generally been for the lifetime of data. The problem with this is that you end up with a siloed data team, or the challenge with this that the data mesh is going to try and solve is the siloed data teams. So all the data teams, so if we go back here, this data team that are performing ETL, they're by themselves. They have the knowledge of how to do ETL within your business. There's data in one place, there's data in another place, and the only team that really knows where all this data is this data team that move it around. There's a slow responsiveness to change. So because you have a centralized team, and if the business value or business definition changes, then that team have to implement the change. This goes onto a backlog, it gets pushed down the backlog, and then something that could, in theory that might take 10 minutes to push to production doesn't get done for 6 weeks because there's just this massive bottleneck around this data team. And then the problem is as well that the data team themselves are great developers. This could be you. You're a fantastic data engineer, but you just don't know the data. You're not a business analyst. You're not a product manager. You're not the CFO. You don't know how the data works. So you're constantly having to go and make sure that you're doing the correct thing. And overall, this reduces the accuracy of what you're building. So the data mesh tries to solve this problem by actually decentralizing the management and the access of data within an organization. And it aims to address then the limitations of the central architecture. So the next diagram I'm going to show you is kind of conceptually how this is done, and then we'll cover the principles. And again, there's lots of good blog posts on this, so this is just a quick run through so you know. So let's look at the bottom. Down the bottom, you have your data infrastructure as a platform. So this is your storage, pipelines, ETL, access control, catalog. And then instead of a centralized team, what you have is product teams. So a product team is a cross-functional domain team. This is a product manager, maybe a couple of data engineers, and anything else you need to make data a product. So this could be let's just say, for example, this is a music streaming platform. This could be the people in charge of artist, and this could be the people in charge of song. And basically, they're two separate teams, and they create the song product of data, and these folks create the song products of data. These people create the artist products of data, and together they combine to create song and artist products, and this is owned by another team. Then at the top, you have global governance. This is where each member of these product teams might elect someone like their product manager to attend a council, and they decide standards that need to be enforced across the teams. So usually this is global naming, where you might have things like, we're always going to call a song in terms of the field. We're always going to call a artist in terms of the field. But then what you want to do is federalize that decision making down into those teams. So you give them a lot of autonomy autonomy on the rest of what they want to do with artists and on the rest of what they want to do with a song. And in this case, they then put the data up into the platform. This is discoverable and searchable. People can request access, they grant access, and then you've productized your data. So the principles of the data mesh is that the data ownership is back with the people who know the most about the data, i.e. the cross-functional product teams. Data is treated as a product, so therefore they're creating data products that other teams can consume off them. It's a self-serve platform, so all the engineering is looked after by a team, but the actual platform for getting the data off the other team is self-serve. You go into the platform and you say, hey, product artist, I want access to your data for this reason. They say yes, you get access to the data. It's completely self-serve. And then there's a federal decision-making model. So this is where each team has enough autonomy that they can actually make data as products, but they get together in a council once in a while to decide global standards that allow for interoperability. That's data meshes in a nutshell. It's the decentralization of data within your organization. Again, lots of good books out there, lots of good blog posts, but that's enough to get you started. So we're moving away from that central architecture into a distributed architecture for data. Next, we're just going to have a little brief word on orchestration. Orchestration in data engineering terms refers to the automated coordination and management of complex data workflows and processes. Orchestration tools help streamline pipelines by scheduling, monitoring, and managing dependencies between tasks involved in data processing. Some examples of orchestration tools would be Apache Airflow, and another one would be AWS Step Functions. We're going to cover these more in depth later in the course. You'll see the links in the description below. I've also went into more depth on orchestration if you're new to this in the revision guide that you can download for Buy Me a Coffee. If orchestration is something new to you in data engineering, I would spend a little bit of time getting to know it. Again, there's more information throughout this course, and I would just do a bit of reading around the outside as well. But for now, that's all you need to know in the kind of fundamentals of data engineering. The certification also expects us to know some common data formats. A definition of that is how data is structured, stored, and exchanged between systems. So if you've been working as a data engineer, you should be pretty familiar with some of these. So like a comma-separated file, that's usually called a CSV for short. You'll notice it because it'll have a file that has values separated by commas. Very common in data engineering to get one of these files and be asked to ingest it into the likes of a warehouse. Another one would be JSON notation, so that's key value pairs, or JavaScript object notation for its full length name. Again, if you've been working as a data engineer for the last 2 years, you should be pretty familiar with these formats. If you're not that familiar, just take about 5 minutes away and go look up some of these. XML, again, extensive markup language, which uses tags in order to give you structure to those files. And another one that I've put in is Apache Parquet. Again, if you're not familiar with that, that's for big data engineering as a column store file format. Particularly used in data lakes. If any of these kind of jump out at you as new, I would take 5 minutes, as I said, away to learn about them more in depth. Again, I do have more information about each one of these file formats in the revision guide, but nothing you can't find on Google. The exam also wants us to know about common data sources. I haven't spent too long on this because we're literally going to go through loads of them during this course because we're using AWS services. But just so you have a definition, data sources are the origins from which data is collected or obtained for analyzation, processing, and storage. So think about it in terms of your databases, your Postgres, your MySQL, your RDS, your data warehouses. We've already talked about Redshift, Mark. We've already talked about Amazon Redshift. We will be using this in the course, as you can see later on the section. So that's a data warehouse. Data lakes, well, that's our S3 where we store the data. We actually will start by setting up a data lake for the Glue tutorial. And then we also have flat files. So that's your CSV files, for example, that we'll upload. Again, we'll be doing this in the tutorial. You'll hit this straight away in the Glue example. But if you have been working as a data engineer for at least the 2.5 years that this course recommends, none of this should be new to you. If it is new to you, I would take some time to look through these data sources, maybe go Google a little bit. Again, I do have more information in the exam guide, but it's not required to understand what these are through the power of Google. The exam also expects us to know a little bit about data modeling. we'll kind of be asked the differences between what is data modeling, or you'll be asked to pick the right system for a data model, possibly. So you got to know that data modeling is the process of creating a visual representation of a complex system's data architecture and organization. This can be a conceptual data model, which is where you're just drawing blocks out, which I do quite a lot, to kind of visualize what the data looks like conceptually. There's the logical data model, where you take the conceptual model and then you start to put data structures around it. So you're starting with just blocks on a board. Then you go to logical, where you start to put in maybe like certain values or table properties. And then you have the actual physical model, which is what you would use day to day when you're actually in a data system. You probably also need to know some types of physical models, such as like the Kimball methodology. If this is new to you, again, I would just spend 5 minutes going and having a quick Google to look at the different types of modeling. If you're kind of familiar with this, if you work with table schemas and models on a daily basis as a data engineer, you're probably good to go in terms of the exam. Questions might come up like, when should I use a NoSQL model? If I have or what service should I use for a NoSQL type workload? So you'll be saying, I have key value pairs and I am building a website. And in that instance, you should be thinking Amazon DynamoDB. Well, if they come in and say, I have relational transactional data, then your mind should automatically go to one of the RDSs, and then based on the next bit of information, that could be RDS Postgres, RDS MySQL, or alternatively, you can maybe even go to Aurora. But the question during the certification is going to try to guide you down what one is the best service. So you might get something like, I have a relational data model. I am thinking about doing this for a website transaction. Should I use A, RDS, B, S3, C, Redshift, D, something else? And then you'll have to think through that and say, well, it's transactional. It's website data, but it's transactional. It's a relational model. I should probably go A, RDS. That's the type of questions that you'll be getting throughout the certification. The exam also expects us to know a little bit about data lineage. Again, if you've been working with data for a while, or you've done the 2.5 years, or you've done IT before, probably in any sort of data domain, you will know this. So involving tracking the flow of data through the organization's systems and processes. And that looks a little bit like this, where you have data source A, you have data source B, you have aggregation, you put that into a new data source, you have deduplication of data source B, and you join the data together. And it's about tracking then these elements through the system. There's different ways of doing this. So for example, AWS are starting to use a open source library called DQ, so it's DEEQUE. This can go into your Glue jobs, and it'll actually track the lineage of the data for you out into Glue. There are other methodologies. Some people use the likes of Calibra, which is a enterprise solution for tracking both data governance, data discoverability, and data lineage. But these are things that you will be asked about, like what's the best path to track data lineage? What is data lineage? What kind of motions do I go through for aggregation of data lineage? These are things that will come up in the certification. Again, none of this should be particularly new to you as a data engineer. It's just covering old ground that may be asked. Then also you'll be expected to know about Schema Evolution. So Schema Evolution is kind of interesting because we do it all the time as data engineers. So it's the process of managing changes to the schema of a database or data structure over time. So in this example, I have a table, and again, we'll be using data like this throughout the course, where we have first name and last name. I want to add a full name column, so my table then comes out first name, last name, and full name. And it's about managing those changes over time. How do you do that through your processes and systems? And then it also expects us to know a little bit about data sampling. This kind of blurs the lines a little bit between data engineering and data science. But what you should be aware of is the different types of data sampling, or at least know what it is so you can have a conversation around it. So a statistical technique used to select a subset of data from a larger data set. You have the likes of population and sample, where you just take like the whole population if it's population, or sample is a subset of the data. So this is what you should be knowing to talk to your data engineers about. Am I getting the population, i.e. is my data set the full data set? Or am I getting a sample, which is a selection of the data set? What is the sample framing? So this is actually a representation of the elements of the population. So if you're getting a sample, what does that sample actually contain? So population is everything. The sample is a subset. The sample frame is actually what do we actually have in here? What are the elements of that population? Then we have sampling error. And this is where you actually want to minimize the amount of sampling error that you have if you're taking a sample in order to get accurate results. And then the other thing we should always be aware of to have a conversation around is sample size. How big was the actual sample size of the population? What did that look like in terms, is this a fair representation? Again, blurring the lines between data engineer and data science slightly. What I've tried to do here is give you the terminology to have the conversation and hopefully the information required for the certification. If you're kind of new to statistical techniques for sampling, a bit more reading wouldn't go amiss. It wouldn't be something that I emphasize over the rest of this course. I would go there first, fill in the gaps around the services, and then come back to something like this. And then again, we need to know about data skewness to have that conversation. So data skewness refers to the asymmetry in the distribution of data values around the mean. This is a pretty good graph to explain it. So negative skew looks like this, where you have a long left tail. And positive skew is where you have a long right tail. And it's to do with where the median and the mean values land. I've left a wiki link that you can go and have a read. What you will need to know for the exam is able to point the two of these out. So you'll be able to know that when you have a long left tail like this, it's negative skew. And when you have a long right tail like this, it's positive skew. You may need to know how to fix that as well, which is to do with actually bringing the mean values closer to the median. So again, wouldn't spend a lot of time on this for the certification, would be able to identify these two things, do a little bit more reading around it, and then go plug in some gaps in that knowledge base. Also need to know about data validation and profiling. So data validation is to ensure that the data is accurate, consistent, and meets predefined criteria or rules. And profiling is where you analyze and understand the characteristic, structure, and quantity of the data within a data set. We'll be talking a little bit about validation and profiling as we go throughout the course. So validation is making sure that the data is correct, it's the data that you expect, and profiling is then understanding what that data looks like. And then just to finish up this section on the fundamentals, a word on SQL or SQL. So the certification will expect you to know SQL. If you're new to SQL or haven't covered it in a while, you're probably best going and doing a little refresher course somewhere on the likes of YouTube or Udemy. I will take you through some SQL syntax, particularly through the Athena section, where we'll cover most of the functions that you need to know. I am not going to explain the likes of what a join is, how a join works though. So if this is new to you, again, I'd highly advise you to go off, do a bit of SQL at some point during the course, not necessarily now, refresh that memory, and then you'll be ready to go for the certification itself. Okay, AWS Glue. What is AWS Glue? So it is a fully managed ETL service from AWS. And by fully managed, it means that there are no servers or infrastructure for you as a user to provision. It uses a Spark ETL engine, and we'll talk about more around that as this goes on through the AWS section of this tutorial. It consists of a central metadata repository known as the Glue Data Catalog. We'll spend quite a bit of time talking about the Glue Data Catalog. And there's also a flexible scheduler that comes along with AWS Glue. Those are the core components. It's not everything. The service keeps growing day by day, but these are the key concepts that you will have to know in order to pass the certification for the data engineer. If we look over to this diagram, you can see, and quite deliberately, when you look at the AWS documentation, the Glue Data Catalog is in the center. This is a store of metadata that is required for AWS Glue to operate. That includes tables, connections, and even things like the actual databases that you create later on in this tutorial. Using this information, you can create an AWS Glue job, which consists of an ETL script. And this ETL script can take data from point A, transform it, and load it in to point B. You can also put this job on a schedule, or you can trigger it by an event, and that's what this arrow is doing here. And if we go up here, you can access this as we will be doing throughout this tutorial through the AWS Management Console. Of course, you can also access this through code like using the AWS CLI. So why do we use AWS Glue? So you need to think about this when it comes to the certification, when you're given options to pick different AWS services. When should I use AWS Glue. So because it offers a fully managed serverless ETL tool, if we hear the word serverless and ETL tool, we should automatically start thinking AWS Glue in our heads when it comes to the certification. This removes the overhead and barriers to entry when there's a requirement for an ETL service in AWS. So that means you can perform ETL, extract, transform and load on data in AWS from other AWS services, S3 or even on-premise, to something else, be again that loading AWS services, data repositories, S3, or even back to on-premise. But the whole selling point of AWS is that it is serverless and it is fully managed. Bit of setup work for this part of the tutorial for the certification. We will be using the S3 bucket and the data that we uploaded in the general setup work for this whole tutorial. So if you haven't done that, go back to that part in the video, complete that, and then we'll do the setup work for AWS Glue. Okay folks, for this part of the video, we do need to do a little bit of setup work. We will be using the glue.yaml file located in this folder here of the Glue code. This will create a IAM role that we'll use throughout for the Glue tutorial. I've put everything you need in here, so don't worry about that. I'll show you how to set that up in a second. The next thing that we have to do, although we've uploaded the data already to S3, is that if we want to use the data for the Glue crawler, we do have to load up 2 other data sets that I've put in. These data sets are different than the other ones that we had because I've put the header in. So when we look at these data sets, there will actually be a header in them. This is so the Glue crawler can pick these up when we get there. If you don't want to do the Glue crawler section, don't worry about doing this, but I would advise you to follow along just to learn how to do this for now anyway. So with that being said, the first thing we need to do is log into the AWS console. Okay, once logged into the AWS console, navigate to CloudFormation, same way we did before, so just in CloudFormation if you need to type it in, or you should have a hyperlink as well on that main page. Then we're going to create that stack. So with new resources, choose an existing template, upload a template file. As I said at the start of the video, you will need to download the GitHub and then unzip that file. We'll use it throughout. So right now, then we need to go and get the Glue section of that file. Okay, then choose file, and we need to navigate to that file that we downloaded. It's in my downloads. I have it unzipped already. Go to the Glue code, and then we are looking for that YAML file, that glue.yaml file that's going to create a few resources for us. Hit next. Perfect. Give the stack a name. This can literally be anything you want, as long as you haven't used the name before. So I'm just going to call this Glue DE for Data Engineering Stack, so I know. And then we're asked from the code to enter the S3 ARN. This is needed for the policy to be created correctly and for your Glue to have the correct permissions. So quite simply, go find the data engineering bucket that we set up, or the S3 bucket that the code set up when we're doing the initial setup for the entire tutorial or for this entire video, and you'll find the ARN that we need inside properties, and you literally can just copy it by hitting that copy icon back into here and then paste it. I find it best to have a couple of tabs open at the same time to do this, but the preference is yours. Everything else should be the same. Same as the main tutorial setup code when we ran this. I have root permissions here. I have admin permissions to run this CloudFormation template. You'll need the same. If you're using your own AWS account, then you'll have them already if it's the default account that you signed in by. Scroll down to the bottom, accept everything. There's nothing else that needs changed, and submit. This will only take a few minutes to spin up. It won't be as long as the first CloudFormation template that we ran. Just naturally because we're creating a Glue IAM role here, so it's a pretty quick process. I'll pause the video and pick it up once it's done. Should be less than 1 or 2 minutes. Okay, that took about 30 seconds in total. Okay, the last thing we need to do for this part of the setup is actually upload a couple of data sets. Although we uploaded some data in the beginning, that raw data, we will need something with the headers, as I said at the start of this, just to make sure that the Glue crawler works correctly. If you're not doing the Glue section, you don't need to worry about this. But again, I'll show you how to get there from the start. So you want to go to Amazon S3, you want to go to buckets, you want to find that data engineering bucket or whatever you called it from the first setup code. Then we're looking to go into our raw data folder, and we should have the 3 folders here from when we first set up everything. Next thing we want to do is I'm just going to minimize that window or make it smaller, and you want to hit the upload. You want to go to add folder, And then what we're going to do is add the folders in actually that we need, but I'm going to do something slightly different this time. So to add folders, and you go into the glue code, you can actually just drag them on, and I find this a lot quicker than actually going through and doing it the other way that I showed you. So I'm just dragging them on from my downloads that I've unzipped. Again, you can do the add folder and find them that way, whatever works best for you. We're looking for those headers files as I called out in this place. You're looking for the employees underscore headers and the orders underscore headers. Put up the folder and the file. So that's important, folder and the file together, and then hit upload. This will take a few seconds. There's not that much data there. Once processed, we just want to check that they've uploaded it correctly. So if you click onto the employee's CSV raw, actually go back up in the raw data, it'll make more sense. This way, open it up, browse open the names. Let's check that everything is there. That looks good to me. Go to the orders header. We can actually then select the orders header file like this. You can say select query with S3, leave everything as it is. Run the query, scroll down and we'll have results. You can go to formatted and then you can see that it looks nice and laid out for us. If we go back up the raw data and then this time we go to employees headers, we do the same thing. Select by S3, down, everything else can stay as default. Run as an SQL query, scroll down, you'll have the results. And then you can click formatted and you should see the headers there this time. And again, we'll need those headers when we actually set up the crawler. That's why we're adding these 2 extra data sets for the purposes of the Glue demo. We won't use them for the other demos like Redshift or Athena, but they're good to have up just for the purposes of running Glue. Okay, with that being said, let's have a little look at some more theory. Okay, so the AWS Glue Data Catalog, as I said, this is a central component to the AWS Glue service. It's something that you really need to nail on in your head. If you have been working for 2.5 years with AWS, you've encountered this most likely before when using AWS Glue or Athena. If you are new to this portion and this is what you're trying to learn for the certification, I'll take you through all the fundamentals of what the Glue Data Catalog is, and then we'll build up that knowledge throughout this section of the tutorial, and then we'll actually use it in action. So the AWS Glue Data Catalog is a persistent meta store. This is kind of the key bit. This is the bit that people struggle to understand. So it's a persistent metadata store. It is a managed service that lets you store, annotate, and share metadata. There's that word again, metadata, which can be used to query and transform data. So the question is then, what is metadata? So if we look on the right hand side, the metadata information is the location of the data itself, the schema, the data types, and data classification. The key bit is that the AWS Glue Data Catalog is just a representation of this data. So when we put in something like a table schema, it doesn't actually move the data from its original location. It actually infers the schema from where it lies, and we'll get into depth about this as we go along throughout this part of the tutorial. There is one AWS Glue catalog per region in AWS. This is a question that does come up sometimes in certifications, like how many catalogs are there in an AWS region? How do I cross access a catalog in another AWS region or another AWS account? So you need to bear in mind that there's only one AWS Glue Data Catalog per AWS region. Access to the AWS Glue catalog is controlled by IAM policies. We set up one when we were using the CloudFormation template during the setup work, and it can also be used for data governance. So we can store things like tags or information about that data to say, hey, this data is sensitive or this data contains PII information using the Glue Data Catalog. The AWS Glue databases, so this is a component of the AWS Glue Data Catalog. It is a set of associated data catalog table definitions organized into a logical group. And we look at this little diagram that I've drawn on the right hand side. This is a database and this is some tables sitting into it. Again, it's essential to understand that this is just a conceptual model in your head. We give the database a name and then we can assign tables to the database. That's all it is. It's just a naming convention to let us group tables together logically. It's not a physical representation either. It can be, but it's not in the instance that I'm talking about. So let's go take a look on how to set up a AWS Glue database on the AWS console. So the first thing we need to do before we create a database is navigate to Glue itself. So I already have it down here where I've been using it. But again, type it into the search bar if you get lost and you can click onto it. Creating the database through the console is fairly easy. We'll just do a quick little tour here. So down the left hand side, as usual, you have actions or items that you can access very quickly. You can see that we have a Glue Data Catalog section and a Data Integration and ETL section. And then we have some legacy pages that we'll not talk about for the purposes of this tutorial. Up here on the Data Catalog, we're going to do databases first, then we will do some tables. We'll look at connections and crawlers as well throughout the purposes of this tutorial. Clicking on databases, we already have a default database that was created for me. I'm going to add a new database. If we quickly go back to the database section here of the Glue Data Catalog, you can see that we're going to create two. One's called raw data, one's called process data. So let's create the raw data database. A lot of words there, raw data database. You paste it in and you can give a description. So I'll just say this is the database for raw data. There is an option to put the location in of the database. For the purposes of this and completeness, I will. So navigate to S3. Again, I'm on a slightly different tab here just so I keep everything nice and clean. Go find your bucket. So I called mine Data Engineering Johnny Chivers. You can see here we have the raw data. So that's copy or hit the checkbox rather, then copy the S3 URI, then go down and paste it in here. This will be the location of our data catalog for our database. You do not have to give this, it is optional, but I find best practices and working with other services in AWS using the Glue Data Catalog, doing this just makes things a lot easier. So after that, I'm going to create the database. You can see that we have the first one, and let's add a second database. So again, looking back onto the README, we're going to create one called process data this time, and we're going to call this then the database, which contains tables for process data. That'll do something like that, whatever you want to call it, for process data. And again, let's take the process data location, copy that URI, back onto databases, click the wrong tab there, and then create that database. So those are your two databases which have been created. AWS Glue Tables. So now we're really getting into the nitty gritty of the AWS Glue Data Catalog. So it is, again, there's that word, metadata, definition that represents your data. The data resides in its original store. So that's key. I'm going to emphasize this again. The data resides in its original store. This is just a representation of the schema. This is where people often struggle with the AWS Glue Data Catalog. The catalog itself and the tables in the catalog are not physically your data. Your data is always stored wherever it originated. So in our case, our data is going to be in S3. When we register this location and schema inside the Glue Data Catalog, it stays in S3. It does not move anywhere. If, for example, we were using another data store, like let's say a Postgres, and we registered that Postgres table in the AWS Glue Data Catalog, the AWS Glue Data Catalog contains the information on how to reach out to Postgres. So it contains information about what the table looks like. It contains the connection string. It may even contain the password and username used to log in if you set it up and configure it that way. The data in that Postgres table is still in Postgres. It is still in the database wherever that database is created and stored. It does not move to the AWS Glue Data Catalog. The AWS Glue Data Catalog and the table is just a representation of that data. So that, for example, we will be doing this in a little second where we create a customers table. My customers data will never move from this S3 location when I create the table over the top of it. The table is just going to be a representation of the data for customers stored in S3. Okay, back on the AWS service for Glue. I've got this page loaded already, so if you don't know how to navigate here, then look at the database pages, but this is the AWS Glue service. And now we're going to take a look at how to add tables to databases. So let's go into tables, and the first way that you can do it is obviously manually through adding a table on this console. So let's go to add table. You can give the table a unique name. So this one we're going to add is the customer table. So let's just call this customers. And we need to select a database. So we have raw data. And I should say again, we're going to get the data from S3 that we uploaded at the start of this tutorial. And then we are going to select the type of data from S3. We're going to say that it's in my account. That's correct. find that bucket again that we've been using and was created for the purposes of this tutorial. Raw data, customers, and select that CSV. You can select one higher as well. Actually, you can select customers if you wish. I'm actually going to do it this time, so I'm going to select customers folder. Okay, sometimes you get a little error there. Just hit enter or just move off it and you should be okay. Classification, we are CSV. We are comma delimited, and then we want to hit next. In terms of the schema, we actually have to define or upload our schema or choose it from the schema registry. This is how we manually define our schema. So a couple ways to do this. Let's do it as an add function. So we can do column 1 name string comment. Now, if we go back onto this, you can see that I have provided what we need to do this. So column 1 is customer ID. We have an int type, so we should be able to find a int type. And a comment is optional. We don't need that. Is this a partition key? The answer is no. We haven't done partition keys yet with our raw data. We'll hit that later when we do ETL. Then we need to add a second column. So we know that that is first name. And we know that that is a string. Then we need to do the next one, which is last name. And then we need to add last name, a string. And then we need full name, add full name as string. And then we hit next and we hit create. And that has created our first table inside the Glue data catalog. So you can see then, looking at the table page, we get some information. You can see the name of the table. You can see that it's CSV. You can see where it's located, and actually if you open the link, it'll take you to that place. There's our file. It then has advanced properties, which we haven't put anything in really apart from the classification and that we're separated by comma. And if we scroll down, you can see that we have customer ID, first name, last name, and full name. This is what the schema that we'll use in the Glue data catalog when we start to use ETL. AWS Glue Crawlers. You'll encounter these quite a lot in the documentation, and I know a lot of people use them successfully in production when they have large amounts of data or tables that they don't want to go through the manual configuration process for. A crawler is essentially a program that connects data to a data store, progresses through a prioritized list of classifiers to determine the schema of your data, and then creates metadata tables in the AWS Glue data catalog. What this really is a program that AWS have created. You point it at a location of your data, be that in S3 or a database of some description like MySQL. This program runs and it collects the information about the tables or the schemas that it sees stored in your data repository, and then it populates the Glue data catalog with these. Depending on how your data looks, be that on a table or be that on S3, you get varying results. So there are certain things that you need to do to a crawler in order for it to define the schema correctly. In our case, what we're going to do next in this tutorial is actually infer the schema from S3. So we're going to use the data in S3 to infer the schema using a crawler and see it in action. Okay, we can also add schemas through crawlers. Crawlers are automatic programs, as I explained in the theory, that will read over the data and then classify it for you. That's why it was really important that we added the data with headers for the purposes of this side of the demo. If we use the raw data that we uploaded initially at the very start of the tutorial, then we don't have any headers in that data because we need that in other places as we go through this tutorial. But without those headers, then we wouldn't have header names, so we wouldn't have column names. So with this data as it's set up, we'll actually get inference about the data, including the column names. Don't worry if that doesn't make too much sense. It will in a little minute. So the first thing we need to do is create a crawler. Crawler for this name we will call orders because we'll do the orders first. We don't need a description and we can go next. Is your data already mapped to Glue tables? No, it is not, and we need to add a data source for it. So S3 data source, our connection we will leave as optional. We don't need anything. It's in this account and we will browse. Our bucket we call data engineering. We need to click in. We need to click in the raw data, and this is the orders headers. We're going to do orders headers this time. Choose that. You'll get a little warning there until you click off. We want to crawl all subfolders, and then we want to add this as an S3 source. Then we can go next, and then we will need to choose an I am role. I created one, or that script created one for us, so it should be called the Glue Data Engineering Cert role. This is one that was created when we ran the CloudFormation template to set up the section of this tutorial. Ignore everything else and hit next. Our target database will be the raw database. We shall prefix the name just so we know that it was the crawler. Normally you wouldn't do this, but it's good to see it. So we'll just prefix the crawler. We'll run it on demand. That means that we can hit go. We'll create the crawler and then we will run the crawler by clicking run crawler up in the top right. This will take a few seconds to run. Actually, it'll take a few minutes to run. So I'm going to pause the video here and then we'll pick it up once we're ready. That completed, as you can see, in 58 seconds. You can see that one table was added. You can click here, or alternatively, you can go back up to databases, click on databases, go to raw data, and you can see that we have the crawler orders header table. We can have a little look to make sure that it inferred the names correctly. So you can see that it was able to pick up the column names by the name that was in the header file. So that's why we had to upload those header files. I know I sound like a broken record, but we had to upload those so we can infer the names of the headers to the column name, which are now there. And then it's done the data types as well for us completely. Let's do another Glue crawler so we can actually infer the employee data as well. And it's also good practice to have. So again, go down to crawlers. Then we want to create a crawler. Interesting that it hasn't showed. There it is, stopping. So that refresh needs to be hit. Create a crawler, and we will call this one the employees crawler because we did orders before. Employees crawler. Don't need to select anything there. We haven't got a data source. Again, in this account, browse, find the bucket like we did last time. So mine's is data engineering Johnny Chivers. Raw data, employee headers, next. May come up red for some reason, just click off and you'll be okay. Add the data source, recrawl all, choose the I am role. So we created one through the CloudFormation script called Glue Data Engineering Cert role. Then click next. We'll run it on demand, but the database again will be that raw database. Prefix the table name. Sure, we'll do the same thing again. So we have it, crawl, on demand next. That should all be okay. Create the crawler, then run the crawler. And again, I'll pause the video and wait until this has completed. Okay, that took 57 seconds. Again, you could go up this way, databases and tables to get to the Glue Data Catalog, or you can click down here and you can see as well that you had one table change. So let's go databases, let's go to raw data, and then let's refresh this. And we can see that we got the employees headers. We can click into there. And then you can see that we were able to infer everything about the employees from those files that we had. So that's how you create tables using the Glue crawler. Just a quick word about partitions in AWS. Partitions are a concept that we use for storing data in object storage quite a lot. And it can also actually be in databases, depending on how big a table is. If you're not familiar with partitions and general data concepts, take 5 minutes to go read about it. But essentially, when I talk about partitions throughout this tutorial, I'm really referring, in my case, to S3. You can, as I said, do it with databases, but in my case, it's S3. And this is where there are physical entities are mapped to partitions. So if we look on the right-hand side here, I have a little diagram, and let's just look at this URL. So here what we're saying is we have a partition called sale, we have a partition called year, we have a partition called month, and we have a partition called day. And at the end of these partitions, we will store our data. And what partitions are useful for in big data terms is when we do computing on top of that by a big data engine, and we say we want the data from the partition that is year 2019, month January, day 2. The query engine does a optimization process and planning where it knows to only go down the tree and look at the data that sits here. So it excludes this data, it excludes this data automatically, and it does that by the folder structure. So it's saying because the query wants 2019, because the query wants January, and because the query wants day 2, I only need to look at the data in here and then I can do whatever I need. And this is a way to speed up our querying when it comes to big data processing. This may come up on the AWS certification again, so just spend 5 minutes looking at partitions inside AWS. Next, we have AWS Glue Connections. The connections are an object inside the data catalog that contains the properties that are required to connect to a particular data store. So think of this like if I have a MySQL database sitting somewhere in AWS, and I'm going to write something in AWS Glue that needs to reach that table. So for example, if we were creating a crawler, I can actually store the connection string, the JDBC, the password, and the username in the Glue data catalog. Then when I'm writing the crawler, I can just say, hey, use this connection to reach out there. And alternatively, when we start to write ETL scripts, you can do the same thing. You just reference the connection. You don't need to write like the connection string and the password and the username all into your script. It's stored elsewhere, and then you can just call the object in. This makes it safe and secure and easy to update connections as well as you move through environments, or you change the likes of a username or password later down the line for security reasons. Okay, briefly now back on the AWS console, let's have a little word about connections. So clicking into connections, this is where you can store connections to AWS. So I'll give you a little idea of what you can do. So I can create a connection by hitting this. You have options on what you want to create a connection to. So depending on your AWS setup, you may have different things, but let's just say I had an Amazon Aurora database that I wanted to set a connection to. I call it Amazon Aurora. I would hit next. Then you would have the ability to go and select the JDBC URL that's related to your database instances, give it a name. Then you could use secret managers or AWS to store the secret for you and then connect in. Also with connections, if we go back to connectors and then create a custom connector, you can actually upload your own connector as well. So it doesn't have to be one of the pre-configured connectors that you see. But if you did decide to do your own connector, as you can see, there are lots and lots of different options out of the box. Everything from Snowflake, Teradata, Salesforce, Postgres, Oracle, Apache Kafka, for example. So there is a wide range that you're able to use for this, including just plain old JDBC. So if you needed to store a connection to a database for Glue to use, then this is how you would do it. AWS Glue ETL, now for the fun bit. So AWS Glue ETL supports the extracting of data from various data sources, transforming it to meet your business needs and loading into a destination of your choice. So if you're a data engineer, you should be well familiar with Glue ETL or just general ETL by now. So this is extract, transform, and load. This one lets us write a script either visually or you can type the script. We can create an AWS Glue job, and then using that Glue job, we can actually move data from point A to point B. We will get hands-on with this as well in the console in just a little second, and we'll start creating an AWS ETL job so we can see this in action. Just a quick word about the AWS ETL engine. There is a Python version, but I focus mainly on the Spark version, as does a lot of the data engineers that I know. The exam may ask us about Python, it may ask us about Spark, but I tend to think about it in Spark quite a lot. So I've put here that the Apache Spark engine is a distributed big data workloads that lets you actually perform ETL. So you should know that it's Apache Spark or Python when it comes to the Glue ETL engine. And then the other thing you probably need to know for the exam is that you set up your ETL jobs or your Glue processing in terms of DPUs. This stands for Data Processing Unit. Sorry, I'll say that again. Data Processing Unit. One DPU is equivalent to 4 CPUs and 16 gig of memory. So if I was to use 2 DPUs, then it's double this. It would be 8 vCPUs and 32 gigabits of memory, and so on and so forth. You might need to know this for the exam if it asks you how many DPUs do I need to process something that needs 32 gigabits of memory. Because 16 gigabits of memory is 1 DPU, then you need two DPUs to do 32 gig. That type of question may come up, so that is good to know. Another good to know that we won't touch in the tutorial before we jump on to the ETL script, but may come up in the exam, is AWS Glue Bookmarks. So this tracks data that has already been processed. So if we have large jobs and we're only looking at processing the new bit of the data that as it arrives overnight or as it arrives by the hour, depending on any sort of use case that you have, then using bookmarks lets you only process new data. It won't reprocess the old data that the job has already done. Particularly useful for the batch jobs that you might be running hourly and then you only want to run the most recent hour. It does this by a folder location or a directory location. It will not reprocess the data. And that's why partitions are important. So if we have data arriving by the hour and we only want to process the latest hour, then we can use the bookmark to say only process the file only process the files that are in the folder for the latest hour. Alright, back on the console here, the next thing we're going to have a little look at is how to create an ETL job. So this is the fun bit of Glue. We need to make sure you have your data registered in the Glue data catalog. That we do, and we have a table set up as well. So let's go to ETL jobs down the left hand side there. I always go to say right hand side, but it's left hand side, and we'll use visual ETL. So this is the Glue Studio where you can enter a job. Let's give it a name, and we'll call this ETL data tutorial. Spelled that wrong, tutorial. IL. And then for the purposes, we're going to use this little node thing. So the first thing we can do is add a source. So we have everything in the Glue Data catalog. We add a source and we click onto it. We need to choose a database. So we're going to go to our raw data, and then we need to choose a table. So let's work with the customers table. And then if you want to do preview, you need to choose a glue role. So, I mean, we can do that, but I won't show you everything here. Again, the role that I set up at the start should have everything that you need. This is going to look at the data, but for the purposes of this, we'll just carry on for now. Okay, once we have that node up and running like so, we want to add a transform. And what we're going to do is add in the load time. So add current timestamp. Then we will be asked what timestamp column do we want to call it. So we will call this load time. In fact, we'll just keep it like this, load time. We'll just leave it as is. So you can actually do whatever you want, but it's optional. We'll just leave it like that. Once we have a transform, we need to add a target. So go to target and go to S3. We will convert this into Parquet format. We'll leave it as snappy, and then we have to find a location in S3. So again, go to your data engineering bucket. And this is into our process data because we're going to process the data. So you want to select the process data and hit choose. Then we need a name for this. So this is going to be customers underscore Parquet and then /. And then we want to create a table in the Glue Data catalog, and on subsequent runs, update the schema and add new partitions. Database, we're going to have process data. Table name, we're going to call the same thing as we call the folder location. So that will be customers underscore Parquet, just so we know. Then we want to add a partition key, and our partition key will be load time. So this is where we'll get to see the partition key in action. We then need to save the job, and that should be good. Then we want to look at the script, and you can see that this has created a PySpark code in behind for us, or in behind the scenes for us. You can go to jobs details, and you can see that we've already selected the I am role that we created. If this is blank, go find that Glue Data Engineering role right here. Leave everything else as default. Change this to 2 if it's not already changed. It may be a 10, so if it's a 10, change it to 2. Then scrolling down, you want to go to advanced properties. And then we're going to be asked places to save the file. What you want to do is then browse S3, and you want to find our data engineering bucket. Data engineering Johnny Chivers. There is a script location directory. It's called script location. That's why it's there. So we're going to save that. The UI logs path for the Spark history server. I would personally copy this, browse to our S3 location, which is called, in my case, Johnny's Data Engineering Tutorial. We do have a location for temp directory, so I'd probably put it in here, and then we will want to select that temp directory, just by doing this, and then we'll probably put then / Spark history logs there, so we know the temporary path that it's looking for. I select that temporary path like this, go to view, browse, then look for that S3 bucket again, you guessed it, then into the temp directory. Oh, no, then we want to select the temp directory. I do that every time on the new Glue console, and then just put in / temporary there as well. You want to use the Hive Metastore. Everything else should be left as default, and then save, and then you want to click run. This will start running. You can see we successfully started the job, and you can go to the runs tab, and that will show us what we're looking at. And you can see here that we have 2 DPUs. We're using a worker type of G1X. We've started the task and it's running. And this will take a few minutes to process because it just has to spin up a few things in behind the scenes. Glue is managing everything for us, so there's nothing else for us to do except sit back and enjoy the ride. Okay, after 1 minute and 30 seconds, that ran successfully. We can actually look at the output of this in 2 ways. So the first way is if we go to the left-hand side there, then go to databases, then go to process data. You can see that we actually created a table. We scroll down, you can see the table was successfully created with that partition column. But actually, let's go have a little look at what it looks like in S3. So again, let's go to that data engineering bucket that we've been using. Then let's go to process data, and you can see now we have a new folder. So this is the table level. This is a partition, so we've created this partition of load time. It's not exactly how you would normally do it. You might only use like year, day, month, but I thought for the simplicity, let's just leave it as everything. Then we can scroll down and you can see that actually there is a Parquet file there. You can look at this here if you want, query with S3 select on Apache Parquet format. I'm going to have the output as CSV. Just leave a comma and then run the query. And then you can see you get this. If you hit formatted, then we're able to see what it looks like. So yep, make sure you just select those output settings and then you can use it. So that's what it looks like on file. Congratulations, you've created your first ETL script. You will be expected to know maybe some of the transformations that are available inside the Glue ETL engine. I would advise you just to read over the documentation or click through the console to have a little look. Again, to get there, just AWS Glue and the console like this. Down that left-hand side, Visual ETL, your job will be sitting there so you can click back into it. And then if you want to look through the transforms, they're right here. So you can actually play around with some of the data, including some of the other source data that we've put into the catalog. So you can add more than one source if you're interested. So you can add another source like that. In this case, we'll just choose the raw data again. Choose a table. We know we have orders. And then you can start maybe by adding in a join and joining these two data sets together if you so wish. But that's just a few ideas. If you want to play around, feel free. You will be expected to know some of this for the exam and the certification. AWS Glue Scheduling. We'll look at this and then we'll do a bit of scheduling ourselves through some of the ETL jobs that we have just created. So the big one in AWS to get your head around for Glue is triggers. This initiates an ETL job. Triggers can be defined based on a schedule or time event. So what that really means is with our ETL jobs or crawlers, we can initiate them by a time, say run every hour, run every minute, run every day, run every week, depending on the job. Or we can do it on an event. So we can say when the data arrives in S3, run the job. So you have the event or you have the schedule. This is where then workflows come into play. This is a visualization where you can actually build complex workflows where you can do a combination of crawlers, jobs, and triggers. So you can say crawl the data, and then once the data is crawled, use a trigger to run the job. And once the job is processed, use this trigger to move the data between S3. That's just an example, but the AWS Glue workflow helps you create these in a visual tool on the AWS console. Other things that you should be aware of for the exam before we jump into the console to do scheduling using Glue. Apache Airflow, which is open source. There's also a managed version from AWS called Managed Workflows for Apache Airflow. Is used very commonly to schedule ETL jobs inside AWS. This could come up in the exam, so it's something I would know. You can also use AWS Step Functions, and Amazon Event Bridge is called out by the documentation as well. These are other options to schedule outside of Glue, but they do let you knit things together, like if you had more than just AWS Glue for your actual workflow or your actual workflow for moving the data. So for example, if I wanted to use Glue for a little bit, and then I wanted to use EMR, and then I wanted to use Lambda, and then I wanted to use Kinesis, you could use these tools to help you orchestrate that outside of the available options in the AWS Glue workflows. So bear these in mind. We will cover step functions in depth when we get to EMR as well. We'll do a little bit around that. Okay, so I'm back on the Glue console. The first thing you should know about scheduling jobs, if you just want to schedule ETL, then the simplest thing to do is go back into your Visual ETL, click on it. We have a schedule tab, funny enough, and you can create a schedule. Let's call this one a daily or an hourly schedule. Let's create an hourly schedule, and then SCHEDULE, and then you can choose the frequency. I want this to happen every hour, and I want this to happen 5 minutes past the hour. I'm going to give it a description. This is an hourly schedule to run our ETL code, and then create schedule. And that's it done. It's going to run at 5 minutes past the hour. Simple as that. I don't want this to run, so I'm actually just going to delete the schedule. The other way you can do this, if you want, if you're more kind of running like event-based code, is to create a trigger. You can see that everything that we do create is a trigger. So this was me playing around earlier. That's the one we're just deleting. So if I hit add trigger and I say I want to call this Glue Crawler. Run for employees. Let's call this employees. And we want to do this on a schedule, on demand, or when a job or crawler event happens. So job or crawler event. And we want this to do any watch job or crawler event. Any watch job crawler event will fire the trigger. So we'll do any watched one. So this is the employees one. So we want it to watch a crawler. Select the crawler name. We'll go with orders. Choose the status. It has to have succeeded. And we want to add that. We hit next. Then the target resource that we want to run is a crawler. Then select a crawler and we'll have it run the employees crawler. So what we're saying here is when the orders crawler run, then run the employees crawler as a trigger. And then we hit next. So you can see here, trigger details, run Glue crawler for employees. The crawler we're watching is the orders. Once the orders completes, the step 2 will run the employees. We can hit create. The other thing that you can do with these types of triggers is run a workflow. So if I go back out to triggers and I say add a trigger, let's say we call this one run ETL run an ETL job. We can do this again as a job, crawler, or event. We want to do it for all watch crawlers in the event are checked before firing. Yep, we do. Once we run the crawler called employees and it was succeeded, we want to run the ETL job. So we say add target resource. This time it's a job. This time it's our ETL job and we add it and then we hit next. So what this is saying is basically when the crawler for employees runs, run our ETL job. So in theory, we've just created a chain of crawlers where if we run the orders crawler and it completes, it'll run the employees. If the employees complete successfully, it will run the ETL job. And you can actually do that yourself if you were to run the crawler, but instead I'm just going to look at one last thing with you, and that is the workflows orchestration tool. Okay, inside workflows, let's just add a really quick workflow. Let's just call this workflow test. Create the workflow, click into the workflow, and then you can add a trigger, you can add a new trigger. Let's just say this runs on demand, and we'll just call this trigger 1. Then hit add. Then we want to run the ETL tutorial. And that's pretty simple workflow. You can add more nodes if you want. Once you're ready to go, you can just hit run workflow and it'll start to run the workflow for you. This will go through different stages once it starts up as well. Obviously, I've just added 2 things to this workflow, but you can add more crawlers, more ETL jobs, and start building very complex workflows start to finish. But that's really the main ways that we schedule. You either do a trigger, on demand, or scheduling. And like the workflow thing that we see in front of us is really for kind of stitching those component parts together. This may come up in the exam. Commonly though, out in the wild, in the real world, I do see orchestration tools being used more commonly with Glue, such as Apache Airflow, just because you might be orchestrating more than Glue itself. So I mean, we might be bringing in data from different data sources, we might be using other AWS services, and the likes of Apache Airflow makes it easier to pull all those things together. The exam also, for the certification, expects us to know about AWS Glue Data Quality. This is kind of new on the console. So AWS Glue Data Quality monitors the quality of your data by data quality definition language, which is DQDL, and it uses an open source project called DQ. If it's the first time that you've used this, you can actually just navigate to the AWS Glue console. You can go pick one of the tables that we have created. So I'm just going to go into tables. I'm going to go to customer, and you'll see that there's a tab called data quality new. In here, because this is new, you can actually create data quality rules, like by clicking this button, and you give it the IAM rule that we created for this tutorial, Glue data engineering cert rule, and then you can go recommended rules, and it will go off and start to create rule sets for you. So you can see it's scanning here, and it will create some of those rules in that data quality definition language. You can then alter these rules, and then you can apply them to your data set. So if you were ingesting data daily, you can apply these rules, and then you can set up alerts if one of the rules was broken, like a field wasn't present on the data that you expected to come in that day. It alerts you as a data engineer. You can go in, take a look and say, oh, look, I'm missing a field from my down-source data for some reason. Sort that out, then bring it back in, run the data quality, check that the field is now present using that automated through your pipeline, and then kick off the rest of your ETL procedure. Aside from Glue Data Quality, they also expect us to know about AWS Glue Database. It's not a tool that I personally use a lot, but I do know it helps a lot of data analysts that I've worked with in the past. It's essentially, and this is not politically correct to say this, Excel in Glue. So it lets you use a visual preparation tool that makes it easier for data analysts and data scientists to clean and normalize data. I'm not personally a big fan of it because I don't really like Excel myself, but again, that's a personal opinion. There are a lot of people using this quite well. So Glue Data Brew, you click on here and it brings you up and you can create a project like so. Then using the project name, we can just call this test. It doesn't really matter. You get asked what data sets do you want to bring in. Do you want to import a new data set depending on what you have? So I'm just going to go import new data set. We're going to call this test data. You then get asked about where is this in S3. So for me, it's going to be in that data engineering bucket. Data engineering Johnny tutorial. Don't want to select the entire bucket. We'll just select the raw data. That'll do. We know it's in it's in CSV. First row has a header. Sure, we'll just keep that for now. And then you select the role that you want to use. You can create one or enter one, and then that's you off and running. Again, I don't really use this a lot, but I know a lot of data analysts like to look through their data in an Excel type environment. That's really all you need to know for AWS Glue Data Brew when it comes to the certification itself. Bearing in mind, it's a visual tool for data preparation, usually used by data analysts and data scientists to clean data and normalize it as well. Okay, we just have a couple of little bits of cleanup to do after that Glue tutorial. First thing you'll want to do is get rid of those extra data sets that we've added into S3. This is just so you don't confuse them when we go on with the rest of the tutorial. You want to find that data engineering bucket, and then you want to go into your raw data, and then we want to delete the two headers, so the employees headers and the order headers folder. Select both of them, and then I'll ask you, do you want to permanently delete? One of my favorite hacks is just to copy and paste this in. It does put a little space sometimes, and then delete the objects. That's the two of them deleted. That just means that this raw folder now looks like it does for the rest of the tutorial. And then the next thing you might want to do is delete the stack itself, so we're not keeping around IAM permissions and things like that we're not using. So we'll just refresh that. That'll only take a couple of seconds and it will go successful probably in about 10 seconds. And that's everything back to the way it is for the rest of the tutorial that you require. Okay, next up we have Amazon Athena that we'll need to know for the data engineering cert. So what is Athena? You probably have encountered this if you've watched some of my videos before. I talk about Athena a lot. It's an interactive query service that makes it easy to analyze data in S3 using standard SQL. So all that's very important information. It makes analyzing data easy because it's standard SQL, and particularly when using S3. It does connect to other data sources now, including Redshift, and this may come up in the exam, so you will need to know that there is a way to connect Redshift and Athena together to do federated queries. I cover this in the Redshift section as well, but for now, it's making that life easier when it comes to querying data in S3. The big advantage is that it's serverless, so you do not have to manage any underlying infrastructure. You just pay for the queries that you run, and that's a benefit because keeping these distributed computing systems up and running is quite complex. So with Athena, you have nothing to manage. It uses Presto or Trino to run SQL queries. So on V2, as in version 2 of the engine on Athena, it is Presto. And on V3, which is the latest one as I currently make this video in August 2024, it's Trino. You should know that the different versions have different engines associated with them. So again, V2 is Presto, V3 is Trino. At the moment of recording, both are available. You get to select it, and we'll see that when we go into the AWS console to actually work through the example. And then it is integrated with the AWS Glue Data Catalog out of the box. So thinking back to the Glue section of the video, if you went through that, then this makes life easy because if you've got everything registered in the Glue Data Catalog, regardless of the data source, obviously we did S3, but you could have Presto, you could have Redshift or anything else, for example, that can go into the Glue Data Catalog. This will then populate for your Athena queries when you're on the console. Again, we'll get to see this in action during the actual tutorial, and you can get hands-on with it as well, because I'll guide you through everything you need to know to use Athena. And then what is Presto and Trino? Just briefly, that this is good for your understanding. It was developed by Facebook, then the founders of the Presto engine, so it was Presto developed first, pulled away from Facebook and started the Presto Foundation. They created a distributed system that runs on Hadoop, and that includes one coordinator node working in sync with multiple worker nodes that lets you run SQL queries. I don't think you'll need to know this level in the exam, but just so you're aware, Presto then forked off to become Trino. Trino is being currently, as we speak, developed 3 times faster than Presto, and that's where a lot of engineering effort is focused in the open source community, and that's why V3 of Athena is Presto. And just for your knowledge, this is how it works. So this is us on the AWS console with our little query editor. We'll see this in action during the hands-on tutorial. We submit a query in SQL syntax. Presto engine, and this is all serverless, so we're not managing any of this in behind, takes that query, understands the query, looks it up to the Glue data catalog, works out where the data sits on S3, gets that data, tells us that it's processing back on the console, moves that data then into its compute engines. Again, this is serverless, so we don't see it being moved into the compute of the node. We don't know any of this. It computes, and then it returns that information or result set to our screen. So really, as the analysts or data scientists, or in our case, data engineers, we only really see this bit. All this bit when it comes to running those Athena queries is looked after by AWS, and that is the major selling point of Amazon Athena. Completely serverless, and the workload or the heavy lifting is looked after by AWS. Okay, with that being said, let's jump onto the console and look at this in action. We'll also take this time to do some SQL work, because there's a lot of SQL type questions that can come up in this exam. This should really be a refresh for you. I will not be explaining every query as we go along in terms of what it's doing. If there's any of the query syntax that you're not quite familiar with, take 2 minutes out, Google it, and then come back, because this will help you in the long run when it comes to preparing for that engineering cert. So, with that all being said, join me on the AWS console. In this tutorial for Athena, what we'll do is use the 3 datasets that we have set up as CSV files at the very beginning of this tutorial in the setup section. We have customers, orders, and employees. These should be already on the S3 bucket that we created. If you're not familiar with what I'm talking about, or you've jumped this far ahead in the video, you need to go back and run that setup section when we initially did the introduction for this entire course. Here you can see we are then going to set up a S3 location for our results in the Athena folder, again created during that initial setup. This is all contained in an athena.yaml file, which you can find in this folder here, the 3.athena code folder. And then that actual YAML file itself will create the things we need for Athena. Then once that's created, we will then create a database in Athena to start using and creating tables. This was pretty straightforward in terms of setup, so let's log into the AWS console and make a start. Okay, once on the AWS console, the first thing we need to do is CloudFormation again. Next, once we're in CloudFormation, we want to create a stack with new resources. We want to choose an existing template. We want to upload a file. Go to that local location where you downloaded the zip folder from GitHub initially. Go to the Athena folder and then go to the athena.yaml. Then hit next once ready. You need to give the stack a name, so I'm just going to call this Athena DE course, that DE standing for data engineering. Then we need to enter the string of our location for the results. So if I go to S3 and I open like this, then we find that bucket again that we created during the initial setup where our folder will be sitting called Athena. We want to click that, and you want to copy the S3 URI. Then want to go back and you want to paste it into parameters. And that's the results location for our Athena bucket. So that's where our results will be stored in Athena. This CloudFormation template will look after everything for us. Keep everything as default. Again, I'm running this with admin permissions. As advised, you should have the same to follow along. This won't be an issue if you're inside your your newly created AWS account or your own AWS account. You can see that that will only take a few seconds to run, and that was successfully completed. Once there, let's check everything's okay. You need to go to Athena by typing Athena. And then once here, you may be greeted by all these messages. Don't worry. you need to go to the top right here under Workgroup and select the Data Engineering course. Everything else should be ready to go and should be set up for you as well. You can see this thing here. I'm just going to minimize so we're on the same thing. And the first thing we want to do then is to create a database. So this is actually using the Glue Data Catalog as I explained during the theory. And in the Glue Data Catalog, we're going to create a database. I have put all the code so you can copy and paste if you want on the GitHub. You should be able to find that and see it easily. So we're just going to follow along these bits here, same as always. But it probably makes more sense to type this out for a while because the exam does expect you to know some basic SQL. So through this, we will cover quite a lot of basic SQL if it's new to you, or if you want to know how the syntax is wrote for Athena and how that looks like for the underlying Presto engine as well, then just type it along with me. So first thing we're going to do is create that database demo data. So back on the console, and you just want to put create statement first. Then the next thing we want to do is write database. Then you need a name. So I said I would just call this demo data. And then don't forget that all important semicolon. Then you want to run it and it will create the database successfully. You can see that we have the demo data. You want to select it there from the right hand side so it appears as the database name. Congratulations, that's the first bit done. Next thing we need to do is create a table, and to create this table for customers inside the demo data database. Once back here, we just want to follow along exactly what we've put in. So create external, and this is because it's going into the data catalog, table, if not exists. So if the table does not exist, exists, make sure we spell that correctly. Yes, perfect. Customers, we want this to be small, so just customers. Then we're going to have 4 columns, the first of which is called customer ID. And that's a big N type. The next one we have will be first name, and that will be a string type, string. The next one will be last name, and that will also be a string type. The next one will be full name, and that will also be a string type. Don't need a comma there. Perfect. Next then we'll have row format. Oh, can't do that. Format. Delimited. And then we'll put in fields terminated by, and then inside quotes we'll have comma. Then we need it stored as a text file, not a, just stored as text file. Just make sure that's correct. Text file, and then location will be in quotes. And if we go to our location, if we go to the top level of our bucket, you go to raw data, then you select the customer one and you copy the URI, and then you just want to put that in between the 2 quotes and then semicolon, and then you want to run this. And that successfully created the customers table, as you can see there. Next, let's get rid of that and make sure that there's actually data in that. So to do that, we just go select star from customers, and then semicolon and run. And you can see we got the rows back. So we successfully created the customers table. Again, if you're struggling with the syntax or following along, you can just copy and paste from here. In order to select a single column in SQL, you just give the name of the column. So our first column that I might want to get is first name. So I'm just selecting that first name from customers, and you run that. And you guessed it, if you want to get full name, then you would just type in full name and run that, and it gives you the customer's full name. Again, selecting an individual column. Important to know that can be done inside Athena and just some basic SQL. So I want to take that back to first name. The next thing you can do is aliases. So that's where you give the column a different name. So this is as f underscore name, and then you run that, and you can see as f underscore name, then I get all the first names. Next important thing maybe to know about Athena is that there are some functions. These functions may or may not come up in the exam, but always good to know. We have the concat function that joins 2 things or 2 strings together. So if we put that there and we go for the first name, and then we go for the last name, and we kick this from the customers tables. Customers tables, and we'll just do it for all customers. And we'll say that this as full name, and we shall, as full name, and we shall run that. Then, first name is probably spelled wrong. Yep, F-I-R. We all make mistakes, so better just to change it and run along as you go. You can see we've got the full name, but actually they're joined in the middle, but still good to know. There is filtering with the where clause, as you would expect. So again, if we go select star from, I'll make the capitals, from customers, which is the table, where first name equals, and again, put it in quotes, so we can actually get it, and then this all-important semicolon. This will return where anyone equals John. So you can see here we have a lot of Johns in that table. Perfect. Then we need to use maybe the and or clauses just to look at the difference between the two. So again, I'm going to leave this as the query is with the first name, and then we'll just say where and last name equals, in this case, Arthur. I think there should be someone called John Arthur in this data. So what we're saying here is the first name must be John and their second name must also be Arthur. So you need both. So only return me where John and Arthur are true. And then in this case, if we change it then from and to or, I'm saying give me everything that says where the first name is John, or give me everything where there's Arthur. So basically give me anywhere where you see John and anywhere where you see Arthur. So there's John, Arthur, but then there's a load of Johns with no Arthur, and that's because we can have John without Arthur. I don't think there's any Arthurs without Johns, no. So that's fine, that's what we would expect to see there. Next thing is you can also use an in clause to filter some data. So again, an in clause is where you write, say, select star from customers, where customer ID in this case, in, and then we'll pick an ID I've saw before, 317, and that all-important comma. And that will return where the customer ID is 317. You can have multiple data points that the predicate has to match here. So if I was to do and 377, it will look for both those numbers, and you can see that we get both there where we have two rows. You may also need to know for the exam wildcards. So this is where we're looking at pattern matching. You have to use the clause like, and in this case, I am putting the wildcard J star, or J percentage sign. So in this case, I'm saying, give me everywhere where, and we'll change this actually to first name because it would make more sense. Give me everywhere where the first name starts with a J. That's what that's saying. Give me everything where the first name starts with a J, and I don't care about the rest. This is a wildcard where it's saying whatever the rest of the string is, bring it back for me. And you can see again, then we get everything that there is a J at the start of the name for. Perfect. The next thing that you may need to know or may not need to know for the exam, but it's always good to cover these things, is a union clause. So we can say select first name from customers, where customer ID in, let's go for 371, we know it's there. And then we might want to union, and then we might want to select first name from customers, where customer ID in 371, and we also probably want to put 377. Now, let's run this. So it only brought me back John, but we know that there's two rows here, and what's happening is because the first names are the same and it says union, we are deduping the data. Now, if we use union all and run, we get three rows back. You can see that we've got one, then two, and that's because this query is returning two rows, and this query is returning one row, and the all function means we would keep everything, so we get all three. But if I take it out and then we allow some deduplication, we should get two. Yep, we get the two rows back that way. To insert a row, we can also do that. So there are write privileges through Athena. So you just write insert into customers, which is your table. You then list the fields. So in this case, we have customer ID, first name, we have last name, we have full name. And then we want the values that we want to insert. So I'm just making this up as a dummy value. So this is a big int. So we'll just put in something random. Then his first name can be John. Second name can be Joe. And then, oh, sorry, I need to do this. And then the last name or the full name is John Doe. And then we want to close that bracket and put a colon. We run that in, and we should be inserting the row. And that's proved that that was then successfully inserted. So if I take the customer ID, so I'm just copying that 1221, and we go select star from customers where customer ID equals this, and put a comma, or a colon rather, we should get that one row returned that we just entered. So we have write privileges as well. Also, we have distinct. So distinct exists to write within this Athena engine. So if I go select, if I write select distinct first name, let's just get all the distinct first names from customers where first name like, and then we just want to have a wildcard and a J. So give me everything, the distinct first names that would start with J. Ooh, there is nothing. That's interesting. Oh, we've done that wrong. So it's J wildcard. Everything that starts with J. Apologies. And there you can see we've got John, Josh, Jacob, John, spelled differently, and so on and so forth. So there's all our customers' names that start with J. We can also get a count of those if we want. So we can put that like that and then enter count. So this will count all the distinct first names for us. And let's see what we get. There are 49 distinct first names that begin with J. We can use a group by function as well within this. So we could do something like select star from customers where customer ID, where first name, let's do first name, it makes more sense. Where first name, like, we'll just go with the J again. So anything that starts with J, and then we could go group by first name. Plenty of information on the internet about the syntax. I'm just trying to give you the feel of what we're looking at. And again, that won't work because that'll need to be first name. And if we run it now, that'll execute and it'll give us the same as we had before. And then we can also do nested queries inside Athena. So you could do something like, if you're familiar with SQL, select star from customers or customer ID in, and then you can do another select customer ID from customers, and this will just return everything because we're basically saying give us all the customer IDs that exist within the table. Oh, table not found. That's interesting. From customers, and then run it, and that's us there. Common table expressions also work. We'll just do CTE, so common table expressions with CTE as, then write out your common table or your select statement for your common table expression. So we'll just do select star, don't do star, first name, then we'll do last name, then we'll do a concat of first name, last name, and we'll call that as F_name from customers, like that. And then we just want to select a star from CTE, like that, and we'll run that. And we successfully got back the FNAME column. So common table expressions, really useful concept inside SQL, in all versions of SQL that I'm aware of. If you don't know what they are, go have a read on the internet, but just to let you know, Athena can do them. Athena can also do joins. So the next thing we need to do is a join. To do this, we are going to need to create another table. I'm not going to write this one out because it'll just take too long. So if we scroll down inside the GitHub, after the common table expression bit, you can see here that we can just copy this in. We do need to change the location for the employees table. So that's easy. Back into here, get the employees, copy that URI, back into here, and then just get rid of that. We don't need that any longer. And we're just taking the easy way out here by running that. And that's created our employees table, as you can see here. That just means the join that we're about to do easier. So we just create that table by using the DDL. Again, you probably will need to know this for the exam. And then we're going to create that last table, which is orders. So we'll just copy that again. I've already deleted that out. Back into here. This time select the orders one. Copy the URI. Then come down to here. And let's paste that in. Run that and that'll create the orders table for us. And then down the left hand side we have 3 tables. Yep. And we have all 3 sitting there ready to go and be used. So just to check then that the joins actually work, you can do a select star from customers, which is my table, and I have spelled select wrong. Getting late, folks, for me. And then select star from, not customer ID, from customers. Let's do an inner join on the orders table, and then we will do our customers dot customer ID equals orders dot order ID, or no, dot customer ID, sorry, customer ID. Again, I'm not going to explain the concept of an inner join. This is something you probably should know if you're taking this course, but more of an example that you can do it inside Athena itself. I forgot my on clause there. If you just put on, that'll be you, and then you can start joining that data together. Again, you need to be aware that you can do a left join as well, so you can just change this very quickly to a left join. So left and right and outer are also there. But again, the purpose of this is just to make you aware. If you are new to SQL, then run through this booklet. Look at all the different things that you can do with Amazon Athena. Learn what these mean if you don't, and then you'll be in a good place for the exam. Again, takeaways that it's just serverless. Once you're done, you can delete this stack that we ran in CloudFormation to get rid of the working group. It will not cost you anything to leave it there, so I think for now I'm just going to leave it there. But for this part of the Athena tutorial, that's us. Let's move on to the next section. Okay, Amazon Redshift, folks, let's get into this. Amazon Redshift is a fast, fully managed, petabit scale, so again, petabyte scale, data warehouse service that makes it simple and cost effective to efficiently analyze all your data. It's designed for online analytical processing, that's OLTP, so bear that in mind for the exam. That may be a question that comes up. And it does this using structured query language, or SQL. You should be fairly familiar of SQL as a data engineer by now. If not, we'll cover some of it in this lesson, and we did a lot of it in the Athena lesson, but you really should be familiar with this to sit the certification. I know I keep saying it, but you really need to get some practice with SQL if you don't have any before you sit the certification. That SQL can be entered into a web UI, which is actually what we'll do for the hands-on part of the section of the video on Redshift. That'll come later after we do the theory. But also you can use any client locally off your machine, including CLI. Again, I use the editor day-to-day provided by AWS in the AWS console, but the choice is yours. If you have a preferred client, then no problem using that. So common use cases, and again, really useful when it comes to the certification, analytical workloads. Kind of goes without saying, but analytical workloads, and that's what Redshift's purpose is for. I would be thinking in terms of the exam when you see we need a column store, we have analytical workloads, or we need somewhere to store our data for BI, then be thinking Redshift. Unifying data warehouses is quite a common use case as well. So particularly companies that have existed for a long period of time, they might have different data warehouses set throughout their business, and they want to use Amazon Redshift to bring it all together. Stock analysis, that comes up in the AWS documentation, so watch out for that on the exam in case that appears. And then finally, social media trends is another use case that comes up quite a lot. It may be referenced on the exam. A little bit about the architecture, again, kind of blurring the lines here between data engineer and kind of infrastructure or DevOps engineer, but good to know this stuff. A cluster consists of a leader node that does exactly what it says on the tin. It is the leader node, and it coordinates or is used as the main Redshift node for your connections and also query processing. Then we have our compute nodes that sit below. That's represented by these kind of turquoise boxes, C1 standing for compute node 1 and CN standing for compute node 4, these are where the actual data processing occurs and data storage to a certain intent. Each compute node is composed of slices, which are units of parallel computation. Data is then distributed over these slices, allowing parallel processing, and that's how Redshift gets its ability to process petabytes of data. Then you can connect in through clients, so JDBC or ODBC is supported up here. Again, this can be through the AWS console, like we'll do later in our hands-on section of this as a tutorial, or if you prefer, you can do it locally off your CLI as well. And then if you are using the RA node version of instance types available for compute nodes, there is managed storage below, which is actually S3, where data can be offloaded and compressed from these compute nodes on the S3. This lets you store more data without taking up space on the compute nodes, and this means then that you're separating compute out from your storage, and your Redshift cluster can grow in scale in terms of storage without having to increase compute. And again, that's on the RA node type. So again, if the exam comes up and it says, hey, I need managed storage, I have a lot of data, but actually my compute requirements aren't that high, is there a way I can offload this data out of the compute nodes and then let me pick it back up when queries actually need it? That is when you need to use the RA version of the node types available for Redshift. Amazon Redshift durability and scalability, again, good to know for the exam. Data is replicated within the cluster, so it's not just one copy. You can back up to S3 with automated snapshots. That's kind of important because they may ask you during the exam how you plan for DR. So for disaster recovery, you would actually then do snapshots of your database or your Redshift database to S3, and then that's automated. And if something goes wrong with an ingest or your cluster goes down or becomes corrupted, then you have those snapshots available. You can also then do snapshots of S3 asynchronously, and I've kind of put that there asynchronously into another AWS region. That's something I have saw come up in the exam as well. Can you actually do asynchronous replication of Redshift for DR into another region? The answer is yes. And now, more recently on these RA node types, again, there's that RA node type again. You do have multi-AZ, so you can actually spread your Redshift cluster across AZs. Scalability, this may come up in the exam, so you may need to know this. There's kind of 3 ways to scale your Redshift cluster. You have elastic resizing. This quickly adds or removes nodes of the same instance type, again, of the same instance type. It does bring down the Redshift cluster for a few minutes during the resizing operation, but Amazon Redshift attempts to maintain the open connections. So that's important. It does try and keep those open connections so you don't drop anything, but it may go down for a few minutes. The classic resize is different because this allows for an actual change in instance type. This is called vertical scaling, and a change in overall node count, which is horizontal scaling. This process can take several hours or days. During this time, the cluster is available in read-only mode. So classic resize, you need to be careful because you basically bring down your cluster for a period of hours or days. And then snapshot and restore can be used in order to keep your cluster available. A user can take a snapshot of the cluster, then restore this to a new cluster, which is configured the same as the existing cluster. All traffic then sent to the new cluster. Everyone's using that new cluster. Everyone's happy. In the meanwhile, you classic resize the old cluster. Once everything's back up and running, then you shift the traffic across back to your old cluster, which has now been resized, and then you spin down the cluster that you took up. It's kind of a green-blue deployment if you're familiar with that, but that's kind of 3 ways that you can scale your AWS or your Amazon Redshift cluster in AWS. I've spent some time looking at these. There is more information on this in the revision guide available from Buy Me a Coffee, or a quick Google will also tell you more about the different ways to scale the cluster. Amazon Redshift distribution, or row distribution as it's known. This is important as well to know because you may get questions on the exam. How do you distribute the rows of Redshift and when should you use each one? So the first one is auto distribution. This is when you let Redshift decide what to do to the rows as you ingest them. Uses some AI algorithms to try and work it out. I would usually set it to this unless I know any better. And the next 3 that we're going to cover then are the 3 that you need to know and the 3 that auto distribution picks from. So we have even distribution. Let's take a look at this. So this is where all the rows are evenly distributed across the slices in a round robin fashion, regardless of the values in the column. So basically you just take the rows, and if we have 100 rows and 2 nodes, it'll put 50 on each. And if you have 4 slices, then it'll put 25 rows on each slice. So I'll say that again. If we had 100 rows and we evenly distributed them, it would be 50 and 50 onto each node, and then each slice would have 25. So 25 in slice 1, 25 in slice 2, 25 in slice 3, 25 in slice 4. Easy. Don't know much about the data, even distribution may be the way to go. Then we have key distribution, so that's exactly what it says on the tin. I've made this example nice and easy, but let's just say I had 4 keys, key A, key B, key C, and key D. Then it will actually then slice up the keys, so it will put them on the node. So all of key A will go on to the node first node, and in this use case, it would all go on to slice 1. Key B would then all go on to the first node, compute node 1, and all on slice 2. Key C would go on to slice 3, and key D would go on to 4. So that's how it works. I use this when I know that the keys need to be distributed because I'm joining on them all the time and the table is not small. So if you're going to do joins on the keys and the table is not small, this is when you should use this type of distribution. And then finally we have the all distribution. This is basically where the whole table or the whole bucket of information is just copied in full to every node. So everything goes to compute node 1 and then that is repeated and everything goes to compute node 2. Usually doing this when you have kind of like a small table and you're using it all the time. Something that's like a lookup. Maybe you're converting country codes into full country names and you have a list of like 230 countries. That's perfectly cool. You can use it then. Just be careful with it because if you do not do it with a large table. Again, this will be asked on the exam, so I'd spend some time looking at this between even distribution, key distribution, and the all distribution. Rewind the video if you need more of the explanation again. Import and exports when it comes to Redshift, and we'll see some of this in action during the hands-on section of this bit of the video. The copy command is kind of the bread and butter one that you will need to know for the exam. So the copy command loads data into a Redshift table from data files or from an Amazon DynamoDB. The files can be located on S3 or EMR or even on a remote host like an EC2 instance or something in your local data center, and then you just run a copy command to copy the data from that location, obviously with all the networking and security in place. The copy command has the ability to decrypt the data and unzip files. That's really important if you're using compressed data that's been encrypted. The parallelization functionality means that it will ingest parts of the file in parallel. That will give you some speed. And then also there is now an auto copy feature from S3 where if data lands in an S3 bucket, you can write or turn on a feature and it will automatically copy that data for you into Redshift. Again, we'll see the copy command in action during the hands-on section. This is becoming more common as well with Zero ETL. So from Aurora RDS to Amazon Redshift, you can actually automatically ingest the data from an Aurora table into Redshift. There's no infrastructure to manage. It's completely serverless and it's an ongoing replication of that data. It's becoming more and more useful in AWS where you don't want to manage that infrastructure as a data engineer. Look out for it on the exam. It probably will come up and you should be aware that it is a viable solution. Streaming is also possible in the Amazon Redshift. You can use Amazon Kinesis or Amazon MSK. The choice is yours. We will touch these services in a bit more depth later. Don't worry if they're new to you, particularly Kinesis, where we will do a hands-on lab. Copying the data between Amazon clusters in different regions. Learn this process for the certification. It comes up quite a bit and you should be prepared to pick it out when you're asked the question of how do you copy data between Redshift clusters in different regions. This is the steps, so memorize them, write them down, learn them. Create an MSK key in the destination region. Specify a unique name for your snapshot copy grant in the destination region. Specify the KMS key ID for which you are creating for the copy grant in your destination region. And then, in your source region, enable the copying of the snapshots to the copy grant you just created. So, learn that again. Create the KMS key in your destination region. Specify a unique name for your snapshot copy grant in the destination region. Specify the KMS key ID for which you're creating for the copy grant in your destination region. And then in your source region where your primary Redshift cluster is, enable copying of snapshots to the copy grant you just created. Learn those steps. You probably or most likely will have to pick them out during the AWS certification. Then, just as you can ingest data, you can actually get data out using the unload command. So data can be exported from Amazon Redshift using the unloaded command or the unload command. Unloads the results of a query to S3. It can be in text, like a .text file, .json file, or Apache Parquet. And there is server-side encryption supported in S3 as well. So the data is encrypted. You can pick one of these file formats and it will go to S3. Again, important to know this for the certification. Integrations, just a brief word about integrations. We've already touched upon Aurora, but you can integrate with S3, DynamoDB, EMR, and EC2. They're all locations where you can copy data from into Redshift. You should know these in case it comes up in the exam and you have to pick out an architecture where you're using the likes of EMR and Redshift. How do you get the data in? Well, they integrate together by running the copy command. Again, learn them, know them, have them at the back of your head. Redshift vacuum command. So this is important to know in case you need to vacuum Redshift. So the vacuum command itself recovers space from deleted rows. There are 4 different ways to run the vacuum command. The first is vacuum full. This command recovers space from deleted rows and it resorts the rows themselves. So it recovers all the rows or all the space when you've deleted the rows, and then it actually orders the rows for you as well. Vacuum delete only, well, this only recovers space from rows which have been deleted, i.e. the ordering of the rows is left as it is. Sort only does the opposite, where actually it just resorts the rows into the order that they should be. And then vacuum reindex sorts the key columns of an index. Again, you should learn these 4 and know these 4 for the certification. Amazon Redshift workload management. So Amazon Redshift workload management enables users to run flexible managed priorities within workloads, so short, fast running queries won't get stuck behind long running queries. When a user runs a query in Amazon Redshift, the queries are routed to query queues. Each query queue contains a number of query slots. Each query is allocated a portion of the cluster's available memory. A queue's memory is divided among the queue's query slots. You can enable Amazon Redshift to manage query concurrency with automatic workload management, or you can manually configure it. Automatic workload management determines the amount of resources that a query needs and adjusts the concurrency based on the workload. So you're leaving this up to AWS to decide. When queries requiring large amounts of resources are in the system, the concurrency is lower. When lighter queries are submitted, concurrency is higher. So if you're using a lot of resources, concurrency is low. If you're using less resources, concurrency is higher, i.e. you can run more queries. Up to 8 queues can be created for each query priority concurrency scaling model. User groups, user query groups, and query monitoring rules can be configured. Automatic workload management is the recommended approach over manual. So again, for the exam, learn that you've got automated workload management. Workload management lets you prioritize queries based on queues and the query slots. It's all to do with the amount of memory in the cluster, and you should really go for the automated version of workload management. There is a manual version, and I've wrote a slide on it here, which starts with 1 default queue and a concurrency level of 5. There's a super user queue with a concurrency level of 1, and you can create 8 queues within manually yourself with workload management with a concurrency of 50. This is not the recommended practice and should only be used when as a last resort, basically. But for the exam, you should always favor automated. If this isn't working, then you should go to manual. There is also short query acceleration. You can reduce workload management queues that are dedicated to running short queries. In addition, long-running queries don't need to contend with the short queries for slots in a queue. You can also configure your workload management queues to use fewer query slots. When you use lower concurrency, query throughput is increased and overall systems performance is improved. SQA for short, or short query acceleration, works with create tables, read-only queries, and it uses machine learning to predict the query execution time and then configure what it needs in the background. So basically it's going to take short running queries, run them in a dedicated space away from your normal queries, and this will accelerate those short queries where the long queries are happening in the background. Concurrency scaling feature. So again, this is a feature that you can use to support thousands of concurrent users and concurrent queries with fast query performance. When you turn this on, Concurrency scaling, Amazon Redshift automatically adds additional cluster capacity to process both an increase in read and write queries. Users will see the most current data where the queries are ran on the main cluster or on the concurrency scaling cluster. So basically this spins up another cluster alongside your main cluster, and then it will actually support read and write queries outside of your main cluster, and it ensures data consistency for you. This is quite useful because you can manage what queries are sent to the concurrency scaling cluster by configuring your workload management queues. So it's another way that will let you scale your Redshift cluster for queries. Other things that you will need to know for the exam before we jump into the hands-on tutorial. RA3 nodes are the newest kind of node type within Amazon Redshift. It allows for compute to be independently scaled from storage. So if you remember back to the architecture diagram, you have that managed storage layer in S3, where these nodes will offload data into S3 but act as a tier 1 cache. That means you only pay for the managed storage that you use. So again, bear this in mind for the exam, the RA3 nodes. You need to be aware of this, although it's blurring the lines again between data engineer and data scientist. You can run machine learning models using SQL commands from inside Redshift. You actually create the models using SQL commands and then send the data at it. I don't personally really know any customers using this, but it's a feature that may come up in the exam, so be aware. We also have Amazon Redshift Spectrum. So this is where data held in S3 can be queried by Redshift, and that's completely independent of the cluster itself. So if you have a data lake and you have data sitting in S3, you can actually put those tables as external tables in the Redshift, and then from Redshift query those tables in S3, but also query your Redshift data at the same time. You should also be aware that you can create data shares within Redshift. This allows you to give live access across Redshift clusters, accounts in AWS regions. So you actually create a data share in your normal cluster, and another cluster in a different account can then access that data share, run queries from their cluster and hit your cluster. That means you don't have to move data around. You should also know that you can write user-defined functions in Lambda. So this is where you can send information or data to be processed by Lambda from inside Redshift. You need to have permissions to invoke that, and then you write the Lambda function in Lambda. You should also know about Redshift federated queries. This allows Redshift clusters to access data from your RDS instances. So Redshift Spectrum lets you access data from S3 or data you've stored in the data lake in S3. Federated queries let you access data that you have in Amazon RDS instances without leaving your Redshift cluster. This creates an external schema, again, external table inside Amazon Redshift, and then you write your query. It cannot be done the other way around, i.e. from RDS to Redshift. It has to be done from Redshift to RDS. Redshift serverless, you need to be aware of as well. This is where you don't have to provision servers. You don't have to provision servers. Automatically scales to your workloads based on a thing called RPUs, which stands for Redshift Processing Units, and there are no workload management or public endpoints, so there is some limitations to the serverless version, but you need to be aware of it for the exam. That's kind of the theory side of Redshift. Let's dive into a short hands-on demo that you can follow along with and then get more familiar with the services. Things I would learn for this: workload management queues, the vacuum queries that you'll need to be aware of, the row distribution for ingest, and the copy command I would focus my time on primarily. Okay, for the Redshift tutorial, everything we need again is in the GitHub, so please make sure you have a local copy, and then I'll use this copy to show you things as we go along. I have laid out the data that we're going to use. This is the data contained in S3 that we uploaded during the setup part of the tutorial. If you skipped ahead or you're just looking at the red section, go back in the video to the part that has the setup, complete that first, and then you can carry on with the Redshift tutorial itself. We're going to end up with 3 tables called customers, orders, and employees. As you can see here, they're laid out like so. The customers table contains customer information, the orders table contains order information, and the employees table contains employee information as well. We've picked these 3 tables because we can do certain things with them together. They are related in terms of the tables. For the setup itself, I have provided everything we need as a CloudFormation template. That's found in the Redshift folder on the GitHub repo. Again, have the local copy so we can upload it later. But for now, you should know that we're going to spin up a single node Redshift instance of the DC2 large type. This is approximately 30 cents per hour. Depending on your account with AWS and what that looks like, it may or may not be in the free tier. Let's make sure that we spin this all down at the end of the tutorial to keep costs to a minimum or zero if possible, depending on what your account looks like. With that being said, once we have ran that piece of code, that CloudFormation script, we do have to do a little bit of manual configuration with the S3 bucket as well. I will take you through that. So for now, let's go back on to the AWS console. Once on that, let's navigate to home by clicking the AWS button on the top corner. Then once we're here, we can go into CloudFormation via clicking that CloudFormation link, or the same again, you can type it in at the top. Just type in CloudFormation. Once here, we're going to create a new stack, and we need to have that original stack created because we will be using resources out of it. You can't delete the other stacks as we go. With the new resources, let's click, you choose a existing template. Let's upload a new template file. Let's go choose. Let's go back out into the Redshift folder and upload that Redshift cluster.yaml. There are a few things that we will have to fill in here. So what I'm going to do is right hand click that stack and open it in a new link. We will come back here in a little second. We need to give this stack a name. So I'm just going to call this Redshift tutorial stack. Tutorial stack. You can call this anything you want. Okay, so you can see there are a few things we have to fill in here, so please be very careful as we go down this list. First thing we need is the ARN of our S3 bucket. So we can actually get that from S3. If we navigate the S3, and again, I'll open this in a new tab, we need to find that bucket that we created during the intro stage. So go find the bucket, click into it. Go to your Properties tab, that's your Properties tab, and click the ARN with a copy. There's actually a copy function on the UI. Bring it back and enter it into the stack parameter. So that is our S3 ARN. Master password. This has to be created with one capital letter and one number. I'll repeat that again. One capital letter and one number at a minimum of 8 characters. So 8 characters, one capital, one number. I'm just going to use something simple here like password 1 with a capital P. You can pick anything you want as long as it follows that name. Again, if you don't enter something that follows the required password format, you will get an error when the CloudFormation template is spinning. Number of nodes is 1. Don't change that. Port number is what it is there. Next thing we need is a public subnet and a VPC. This is the stuff that we set up during the first CloudFormation template code. So let's click into the stack as it sits. Let's click the outputs. And if you remember, I listed some of the outputs for us. So let's grab public subnet number 1 and let's copy that and paste it in. And then the setup VPC, well, that's easy. The VPC is here as well for us. We created that during this CloudFormation stack and enter it there. So that should be everything filled in. Give your stack a name, give it an ARN, give it a password with a capital letter and at least one number with a minimum of 8 digits. Then give it a public subnet, and then a setup VPC. Click next, again, using my root account here with all my admin permissions. If you're in your own AWS account, you should be good to go. Then scroll down the bottom, accept the terms and conditions, and hit submit. This can take between 5 and 10 minutes to spin up. It's going to create the Redshift cluster for us in the background. Again, being the data engineering certification, you won't know how, or you won't be required to know how to spin up the Redshift cluster. You're just required to know things about Redshift that a data engineer would know. Fortunately for us, this CloudFormation template will do the heavy lifting for the things that we don't really need to know. I'll pause the video here, and then once everything has gone green and it has been created completely and successfully, I will start the video again. Okay, after about 3 minutes, everything was created successfully, as you can see. There's one last thing we need to do before we actually take a look at the Redshift cluster. If we jump back onto the GitHub, you can see that we have to do a little bit of work with the S3 bucket. We're essentially going to make it public for a short period of time to allow us to ingest the data. This isn't best practice, however, it's the easiest way for us all to follow along. Once we have ingested the data, my advice is to turn and block public access back on. I will do this in the tutorial for us as well, but please do not leave your bucket open to the internet. Do not leave your bucket open to the internet for an extended period of time. Okay, back on the console itself, let's navigate to S3. I actually have it open up here as well, but let's do the navigation for completeness. S3, let's find that bucket, Johnny Chivers, with the tutorial. Next thing we need to do is go to this permissions tab right here. You can see right now that the bucket settings that we have blocked everything. The first thing we're going to do is turn this off, so just uncheck it and save. Again, not best practice, but for the purpose of this tutorial and to do it really quickly, let's turn it off and then we'll turn it back on. We also need to go to the bucket policy here and click edit. I have provided you the bucket policy here that we'll have to adjust. So if we paste it in, and I just went copy and paste there, you can see that there's two places we have to replace with our bucket S3 name. S3 bucket name is right here at the top. If you want to be lazy, you can just copy and paste it down. So if we take away that and paste it in, just be careful if you drop down a line there to pull it all back up. And again, let's get rid of everything from there and paste it back in. So that's all we need to do. And then we need to save everything. And that will be us able to ingest the data from our folder. Now again, we're just going to ingest the data from this raw data folder into Redshift. So with that being said, the next thing we need to do is go to Redshift. So if I click in Redshift and I open Redshift over here, you can see that I have one node and one on-demand node. This was created by the CloudFormation template. My cluster itself is down here under cluster overview. So if I just click on the cluster, you'll see that it brings me up information about what's going on. You can see that this cluster is relatively new. We've just created it and there has been barely any storage used in it so far. Okay, the next thing we want to do is actually query some of the data or log into the cluster itself. That's done by going on the right hand side here and hitting query editor and then query editor in V2. You can see that we get a little editing screen that looks a little bit like this. Then over here, we want to click on that and it will bring up how you want to connect to the cluster itself. We're going to use database username and password. Database is dev because we didn't change this during the CloudFormation script. To get the username, it is available in the actual YAML itself. If you scroll down, you'll see that there was a default username called here, default user. So this is what we called it unless you changed it, but for me it's default user. So if I just go back in here and paste in default user, the password is what you chose. Now remember, it probably had one capital letter and at least one number. I'm going to then say that is my password and then create the connection. Provided you've got the username and the password correct, it will all go green. I have set up everything else you need in the background through that CloudFormation script. Fantastic. That's part one done. We're now successfully loaded into the Redshift cluster. This here is our query window where we can enter queries. Down the left hand side, you can see in the side panel, we have the cluster. We have the dev database we asked it to create through the script. We have a public schema. And again, you'll need to know what a schema is for the purposes probably of the exam. And then inside the schema, we have tables and views. We'll be just using this features or this functionality that you see in front of you for the rest of the Redshift tutorial. Now we actually have this open, we need to get some data in. If we jump back onto the Redshift GitHub or the place for the Redshift GitHub, you can see that we have to create a series of tables. This is DDL. Again, you may be expected to know this for the exam. This is SQL DDL. So this is going to create the customers table, the employees table, and the orders table. And just to reiterate, we are using the same data as we used throughout the other tutorials, the customers, the orders, and the employees. This data should be in your raw data folder on S3. If you haven't got this far, I'll say again, go back and run the intro section that will help set up all this other resources that are required, and then you'll want to run the command. You can see then we successfully created the table customers. To check that, you just go right hand side over the schema or over the tables, hit the refresh, one table, customer. If you click on that and then I'll expand it out here, you can see the types of column that we created. And this references or is related to then how the data looks, customer ID, first name, last name, and full name. Back down then we have two more to create. Next one is the employees table. Easiest thing to do, just copy that in, delete everything that's there, paste it in, and then hit the run on the top right. Make sure you only hit it once on the UI or else you will get an error. So just hit it once, give it a little second, it will actually create that employees table. Click on employees, you can see that everything was successfully created. Again, delete that out, go back over here, grab the orders DDL, and then paste it in. And that is our orders table created. To check that, just hit the refresh and you'll see that orders is there. And then delete this out so we don't run it again. Okay, with that done, we need to get some data in. So if you remember back to the theory, there's the copy command. We can write the copy command, or we can actually use a UI or a wizard that helps us create that as well. So up here on the load data, if you click load data, we're going to load data from the S3 bucket. We're going to browse the buckets. We need to find the one that we're using for the tutorial, which was called Johnny Chivers Data Engineering. Then we need to go into that raw data location, and we're going to do the customers one first. Select the customer CXV and hit choose. Take off this ignore headers because there's only data in this. So file format CSV, we're comma delimited, and we have no headers. Then click next. Then you want to load an existing table. You want to go to public, and then you want to select the customers table. Choose an IAM role to use. This was created during the CloudFormation script for us. We should only have one there. It's called the Redshift Data Engineering Cert role. And then leave the column mappings as they are and click load data. You can see then that this actually creates the copy statement for us. So let's take a little closer look at what's going on up here for a second. I'm just going to pull this across so we have more room, and I'm going to take a new line here. You can see that this ran the copy command as we know from the theory. It's loading the customers table, which we just created. It's running it from this S3 location, which is where our customer data is. It's using this IAM role from here. And you can also see from here that we're going for CSV, comma delimited. There's a quote, and we're in EU West 1. I'm running everything in the Irish region. So that should be our customer table loaded. We'll check it in a little second. We want to load the employees table, and we want to load the orders table as well. Same way, so just go load data. Let's go browse. Oh, no, sorry, that's the wrong thing. From S3 bucket, let's browse S3. Let's go down to the bucket that we created for the purposes of this tutorial. Then go into the raw data. So we created the customers. Let's do the employees next because we'll do them in order as they appear to keep our place. Ignore the header role and go next. Once here, we want to load that existing table. We're in the dev database. We're looking for public, and then we're looking for employees. Again, select that IAM role as we have it because that's the one I've associated with the cluster during the CloudFormation process. Hit load data, and you'll see again it creates a load command for us. That's everything loaded. Absolutely brilliant. And let's do it one more time where we load from S3 bucket, browse the bucket, find the bucket that we created for this project, go into the raw data folder, go to orders, highlight the orders file, make sure you're on the file itself, choose that, ignore the headers, needs to come off, click next, find the orders table which is in the public schema, find the IAM role again, and then load data, creates the copy statement for us, loads the data. Okay, that's then successfully loaded the data. I'm just going to minimize or get rid of that tab. And you know what? I'm going to get rid of this tab as well. And then just create a brand new one in the editor space. So back on to what we are actually going to do. We've done the load and copy command. You saw how that's created, and there's an example of it as well. We now need to check that there's some data in these tables. You will again be expected to know some SQL. We've covered it with Athena. I've covered it here. I have some videos on the channel doing it as well inside AWS. I highly advise you to get comfortable using this for the data engineering exam. So we just want to do a select star, which is where we select all the data from the public schema. And again, we need to make sure that we are going to be accurate. So the public schema, and we are looking for the customers table, and then you need that semicolon. And if we run that, you can see then there are all our customers. If we get rid of customers and we try employees, and we run the same, we should get back the employee data. Again, notice how this marries up with our data as we would expect from our schema. And then last of all, let's just check that the orders have been loaded correctly. Run the orders command, and you will see that the orders, hopefully, will appear. There we go. Orders will appear as they sit. Back on to the GitHub tutorial. We've done all this bit. Next thing we're going to look at is joins. This is just to make sure that our data loaded correctly. You can just copy it from here, or you can type it in. I might type it in just to show you how it's done. So if you do select, oh, I need to put cap locks on. This came off. Select. And then what we're looking to do is get from the customers table. And again, I need to take cap locks off for that. The customers table dot customer ID. And we want from the next table, we are looking for the orders sale order ID. So we're going to go orders dot sale order ID. From, and again, if you're not familiar with the syntax, you probably need to know some of it for the exam. From customers, or from public.customers to give it its full path. Public.customers, and then we want to inner join the public.orders table on. We want customers customer ID equals orders dot order. What do we call it over here? Orders dot customer ID as well. Dot customer ID, and then a little semicolon, and then we should be able to run that statement. Sales order ID does not exist. What do we call it? Sales order ID. Apologies. Put in that S there and then run it. And you can see this is the customer IDs and then their corresponding sales order IDs. Again, you will be expected to know some of the SQL for the exam, so feel free to copy and paste, play around with it to your heart's content. Bear in mind that that cluster is being charged at 30 cents per hour as it currently stands on the AWS pricing model as of the 21st of January, or 21st of July rather, 2024. Once you're comfortable with the actual statement that we've just wrote, we need to create a materialized view. Now to do that, I'm just going to take a few new lines, and a view, if you remember back to the theory before this, is where we are creating a view, which is a way the data looks that isn't actually in a table. So we just go create view, actually create materialized view. And you can actually see how to write it here. So we're looking for materialized, and then we're looking for view like this. Then we give it a name. So I'm just going to call this same thing that I did here, customer order, customer order, and then an as. So this is going to create a materialized view called customer order. Then we want to run this query. So I hit run. And you can see it successfully ran. If we go down to views now and refresh it, we should have one view. There it is. Double click it and it will actually run the select statement for us, or bring it up to be ran. So I'm just going to run it like that. And you can see now we have a view of the sales orders placed by the customers. This is persisted on disk for us because it is a materialized view. Next thing you want to look at is a couple of the systems table. We covered this again in the theory, but it's good to know how to get there. So this is an example of the query summary. This is a table that contains all the queries that we've ran against the Redshift database so far, or since its existence in my case. This will take a little minute to bounce back, but there's all the information. You should be aware of what some of these systems tables do, so it's good to know. And then this one here contains information about the user we're using to run the query currently, so that's me. So this pulls back my default user. That's the name that we use to sign in. You can see that I'm a super user as well, and you can see that pretty much everything is unrestricted for me. Again, covered the system tables and views in the theory lesson, but that's how you get to them. And then finally, just for completeness, we did cover the vacuum command again in the theory, but if you wanted to run a vacuum, bearing in mind that vacuum is always running in the background of Redshift, but if you wanted to run a vacuum command, you just run it by writing vacuum full. That's the one that will do both the cleanup of the deleted rows and also the reordering and re-indexing of the data. We covered the different types of vacuum command during the theory. Go back there if you want to know more. few other things that you probably should know about Redshift just while we're here. We do have on the actual cluster page on the Redshift service on the console, you can see the actual queries that are going on. So here's a query history, and here's the history of the queries that I have ran. You can see here, there's when I actually ran the select statement to get the information from the system tables. You can see here, this is actually something going on with the delete partitions when we ran the vacuum command, and so on and so forth when you scroll through. Other things to know, you can look at and connect databases, your data shares that we covered again in the theory. This is your zero ETL integrations, which we'll cover in the RDS bit as well. And then you can see we have resource policies if we need them. This is also the schedules where you can actually schedule up and down the size of your cluster and the properties and maintenance. Again, good to know how this query editor works. Feel free to play around with some of the SQL queries that you may find online to query that data, but make sure you do this next step once you're done. Once done, we need to go back here. We need to go back to our S3 bucket. We need to go to those properties of the bucket. So we go back onto the bucket itself, go back into the bucket, go to the permissions, go to edit. Actually, first of all, we need to delete this bucket policy. So click delete, type in delete, like so. Once it's deleted, go back up to these bucket permissions, block all public access and save the changes. Go to confirm, and that is us back nice and safe and secure in our bucket. Once you're done playing around with the Redshift cluster itself and you're ready to shut it down, because bear in mind, this may be outside of the free tier, go back onto CloudFormation, access it by typing in CloudFormation. Select the stack that you've called Redshift tutorial stack in my instance, but whatever name you gave it. Go to the delete functionality at the top and then hit delete. This will take 5 maybe minutes to delete, but once successfully deleted, it will no longer exist in your stack, and that instance will be shut down and you will no longer be charged for using Redshift. Very important to avoid those cost charges or extortionate ones. As I said again, it's being costed at about $30 or 30 cents per hour, but this will depend on your exact pricing plan and it could even come within the free tier, but use it quickly, get rid of it within the hour, and it's going to be approximately 30 cents. Okay, Amazon EMR. So what is EMR? EMR is a managed cluster platform that simplifies running big data frameworks such as Apache Hadoop and Apache Spark, as well as Presto, Trino, Flink, HBase, and many more. EMR integrates with other AWS services. That's important for the certification, that you know that it integrates with other services. Primarily, the Glue Data Catalog comes to mind, which can act as your metastore. This is the architecture of what EMR looks like. As you can see on the right hand side, there's a diagram, but this consists of master nodes, which is a node that manages the cluster by running software components to coordinate the distributed data and the tasks of other nodes, i.e. it is your leader node. You then have core nodes, which is a node with software components that run tasks and store data in a Hadoop distributed file system, or HDFS for short. In multi-node clusters have at least one core node. So usually you have a master node that's leading things, then you have your core nodes that do the processing itself, and you have the option of task nodes, which are additional nodes that you can add that only run tasks that can help process through the big data frameworks, but it does not store data. They are for processing only. Task nodes are optional. Other things you might need to know is the big data framework. So the big data processing frameworks are the engines used to process and analyze data in EMR. Different frameworks are available for different processing needs. So Spark would be one that we use quite commonly. The likes of Presto or Trino would be another one that I see come up a lot. The main processing frameworks are available for Amazon are EMR, Hadoop, MapReduce, and Spark. And I would add Trino or Presto into that now as well. Cluster resource management. So the resource management layer is responsible for managing cluster resources, scheduling jobs, and processing data. By default, Amazon EMR uses Yarn. That may come up in the exam that you have Yarn as your scheduler. It may not come up on the exam, but it's good to know. And then storage, Hadoop distributed file system is a distributed scalable file system in Hadoop. Using EMR file system, EMR extends Hadoop availability access data stored in S3. That's kind of the core thing here. That is actually with your EMR cluster, you can have the data reside in S3. Then use EMR to pull the data off S3 when you actually need to process it. That's the most common pattern that I see these days inside AWS when working with data engineering. EMR serverless in the grand scale of things is a reasonably new service within EMR. It's exactly what it says on the tin. It is EMR where you don't have to provision any servers. You have the options of Hive, Spark and Presto. That's why I keep mentioning Presto, because it's becoming more prominent these days. Things you probably should know is that this is a diagram for the different stages when you start an EMR serverless application. You will pay for it until you physically delete the application. Even if it's not running in a service environment, you will pay for it till it's terminated. That could be a question in the exam. My EMR serverless app is charging for me even though it's in a stop state. Well, you have to go to a terminated state for that. EMR and EKS, appreciating we haven't done containers yet. EKS stands for Elastic Kubernetes Service. This is a container service, managed container service from AWS. It's becoming more common, and a quick Google, you could see that there are things called data on EKS. This is where you run big data frameworks on EKS. In this case, we're talking about running EMR on EKS. That's totally doable. In this instance, when you're doing the EKS solution, you obviously have EC2 instances, the OS and Kubernetes down here at the stack, and then it installs the EMR components at the top of the stack. This is different than when you're running EMR and EC2, where actually the whole stack is looked after or is helped ran by AWS like this. So probably learn the two differences. Be aware that you can run EMR and EKS. It may come up on the certification. Then for orchestration, there's many ways to orchestrate EMR, including the orchestration tools that we talked about during the fundamentals section of this video. But step functions is becoming more and more common everywhere I look, so I've included this definition. During the hands-on element of this part of the video as well, we'll use step functions to schedule EMR jobs. Step functions is a low-code visual workflow service that helps developers build distributed applications. Essentially, we can use step functions with state to run our EMR applications and then make decisions based on those outcomes. I've added this in just at the end for a little bit of a reminder of Amazon EMR and data engineering. So really what we see it for is big data processing for ingestion. This used to be the likes of Hadoop, MapReduce, Pig, but now I really see it being used for Spark. Big data processing for analytics. Again, this would be where we use Spark or maybe even Trino or Presto to do processing for analytics, be that dashboards or one-off user queries. And then we also have EMR where users will use it for big data streaming. That can be Spark structured streaming mainly is what I see, or it could just be general streaming through the likes of a Flink app running on EMR. Again, be aware that EMR can use all these use cases for the certification. Okay, with that being said, let's jump onto the console and get hands-on with Amazon EMR. Okay, the first thing we need to do is navigate to that S3 bucket that we've been using throughout this tutorial. Once on the bucket, you can see from the GitHub itself, there are several things that we need to complete in these steps, so I'll do it with you. The first thing is we need to create this folder structure: EMR input, EMR files, EMR output, and EMR logs. I've given you a diagram of what that should look like, and then we have to upload a few things as well. So back on to the S3 console, and we want to hit create folder, and that first folder should be called EMR. Just save it as it is, and then click into it where we have to create 4 more folders. I'm just going to do these in order as they appear on the GitHub. So create folder, and the first one is called input, and create that folder. The second folder is called files with an S because it's plural. Create that folder. The next folder is called EMR output. So I'm just going to go create folder and output. And then the last one is called logs. So create folder and logs. And then create folder. And that should give you the 4 folders that are required and should follow then this bucket structure where we have EMR input files output logs, EMR input files output logs, EMR files input logs output. Yep, that's correct. Okay, next step, if we scroll down, is that we have to upload a data file, and then we have into the input folder, and then we have to upload these files into the files folder. Again, make sure you have that GitHub downloaded locally as a zip, because that's what I'm going to do to upload. So into the input folder, then click upload, then click add files. Then inside add files, I'll actually go back up into my downloads, into this, into the EMR code, into there, and we're looking for the trip.csv data to load up into the input section. So that's correct. Upload. Take a few seconds. Close. Then back up into the EMR directory, then into the files directory. Be very careful as we upload these. So add files. If we look at the first file, it's the nytaxi.hql file. That's located in the Hive folder. So in the Hive folder, there's it sitting there. Upload. Add those files. And then the next one that we're looking for is this .pig folder located in the pig folder. So the pig folder, and open that one. Then add files, and the last one's the Spark folder, and it's looking right at that top directory of the Spark folder. Do not go into the CLI Spark. That's for something we're going to use later. Just this top level. And okay, you should have 3 files then, which we do, and hit upload. Okay, that successfully uploaded those files. Let's close that, and we can see all 3 are now present. Excellent. Next thing we need to do is create a key pair and download the private key. So if you've never done this before, it's fairly straightforward. Just go to EC2 and type in key pair like this. And you should see it comes up as a feature down the bottom. Click onto it. Then we want to go create key pair. Give it a name that you're going to remember. So I'm going to call this the Data Engineering Tutorial Johnny Chivers. Leave everything else as default and create the key pair. One of these will be downloaded. Download it somewhere safe. I'm going to put it into my downloads so I don't lose it, and save it. That's your private side of the key pair. You must save that file or what we're going to do will not work. So make sure you save that file. Next thing we're going to do is create the EMR cluster itself. So navigate to EMR by typing in EMR and hit EMR. You can see all my clusters that I've been playing around with. But next thing we want to do is then hit create cluster. We need to give the cluster a name. So I'm just going to call this DE Johnny Chivers Tutorials so we know what we're doing with it and we can shut it down. Let's just use the latest release. I'm using 7.2. On here, we need to tick the pig box, which is located here, and also tick the Jupyter Hub in case you want to do some stuff with Jupyter. I'm not, but it's always good to have it just in case. You need to select these 2 to use the AWS Glue Data Catalog as we use it. We want to use instance groups. We're going to use M5X large. You can see that there's different build prices, so we're going to be building at about 20 cents an hour. This shouldn't be up for more than half an hour to 60 minutes as long as you shut it down afterwards. So just be very careful with those pricing points. Make sure you terminate this cluster once we're done. Remove the task instances. Leave those as M5 as well for the core instances. Leave everything else the same here. We're going to size the cluster manually, and for core instances, we're going to have 2. We'll need this for auto scaling later. Inside the VPC, we're going to browse, and you need to find the one that we set up at the very start of this tutorial. So mine is called the dev one because that's the tag we gave it. You should have the same name as me, but if you haven't, you need to go find that in the S3 output like we've been doing elsewhere. Then click on AZ1. Okay, so that's the 2 then selected that way. We have no steps. Termination and completement. I'm going to put my idle time up to idle time. I'm going to set this to 1 day. That means after 1 day, the cluster will terminate. I just don't want to terminate it when I'm doing this work through with you. If you want to do any other times like this, you can enter it in, but that's what I'm doing for now. Make sure you close this down after we finish this tutorial. That's the best thing you can do. Cluster logs. Yep, we need to view, browse S3. Then we need to find our bucket. So I called mine Johnny Chivers tutorial. Inside EMR, we'll have a logs location like this. Choose it. Perfect. Security information. We're just going to let it create the security groups for us. But for the key pair right here, we need to find that key pair that we just created. So DE tutorial Johnny Chivers was the name of mine. So let's just leave that here. Choose an existing service role. You'll have one called the EMR default role. Choose that. For the scaling profile, you'll have one called for the instance profile, you'll have EMR EC2 default role. Choose that role. It comes with AWS. And for the scaling profile, just use the default one as well, EMR auto scaling default role. So all these are default roles that come with EMR. You will not have to create them. Just make sure you find them. So looking through this again, let's go through all the steps that we took. We turned on Pig and we turned on Jupyter. We ticked these 2 AWS Glue Data Catalog boxes to make sure that we're using that. We're using instance groups. We're using the M5X large types, both for our primary and then for our core. We've removed the task nodes. We're leaving everything else as default. We set the cluster size manually. We want 2 instances. Networking, we're choosing the VPC that we created during the CloudFormation script at the very start. Make sure you've got the correct one. You can find the output in CloudFormation if you need to go back, but we've been using it everywhere throughout this tutorial so far, so you should be familiar with it now. I'm going to tell the cluster just to terminate after a day. If I forget to close it down, you can manually get rid of the cluster after we're done with this. It shouldn't be up for more than 30 to 60 minutes, but this will make sure that it's gone after a day, just in case. Logs we're setting to the S3 location where we created that log folder just about 2 minutes ago. Make sure key power is your data engineering tutorial one that we have set up. Leave that as default. Choose the service rules that are the default rules and then hit create cluster. Okay, this is going to take maybe 5 to 10 minutes to set up. So I'm just going to pause the video here and then we can pick it up once it's ready to go. Okay, that took about 8 minutes and 21 seconds. So if you just keep refreshing it, eventually it will go to waiting, which means your cluster is ready. So if we look at the GitHub, we need to allow traffic on port 2022 from the EMR security group, and then we can get on with the rest of the tutorial. So to get to your EMR security group, what you need to do is go to properties. You need to go to your EC2 security groups and firewall down here. You're looking for the managed security group, which is here, and click on it. And you want to scroll down and you want to add a rule. You want to add a custom TCP rule. You want to click my IP and you want to put in port 22. So custom TCP rule 22 my IP. This is the IP of your machine that you're currently working from, and you want to save those rules. Okay, perfect. Then just make sure that that's in there so you can see that I can SSH on port 22 from my local IP as it currently stands. Next thing you want to do is load up a terminal. So we're going to go to terminal and I'm going to blow this up this side of my screen and move it down a little bit. And then I'll make this writing bigger for you folks so you can see it at home. So let's just make this super big. We gotta love it. I'll just minimize that a little bit, but leave the writing big. Okay, so I need to find out where I am first. I'm in my documents, so or my home file. So if I ls, I want to cd to my downloads, or what I'm doing is I'm trying to get to the location where we stored this file. So wherever you stored your keeper, your .pem side of the file, go to that location in your terminal, find it. First thing you need to do is actually change the read-write permissions on it. So you want to chmod 400 and then the name of your file, and this then makes the file not writable as it currently stands, locks it down so we can log into the cluster, which is what our next steps are. So if we go back here, you can then see that we're going to SSH into the cluster, and then we're going to do a little bit of work before we run our first bit of code on EMR. So back out on the EMR cluster, which is over here on this tab, you'll find a place like this that says connect to primary node using SSH, and that's just inside the summary box there. So click that. You want to copy this and you want to paste it in. Do not run this. We want to go back to, hit the wrong button there. We want to go back to the place at the very start, which is here. And we want to get rid of this and put a dot. So because we're inside the downloads file, we just want to take it from this directory. And this should then connect in. So when I hit enter, you can see that we're connecting. Hit yes. And we should have the EMR window open in front of us. So that is our EMR window. I'm just going to take a few new lines so we can see what's going on. So this is EMR. We've logged into that cluster via SSH. So congratulations, you're in the cluster. Next thing we need to do then is we're going to create a file called spark.etl. So you can see there, we're going to create the spark.etl.py file by copying the contents from Spark, the Spark folder, and then CLI Spark ETL. So follow along with me. So I'm going to copy this name just to make things easier. And the next thing we write then is nano. We're going to use the nano text editor, and we're going to give it the name of the .py file. This is us inside a text editor on EMR itself. Then we're going to scroll back. We're going to go to the folder. We're going to go to Spark. We're going to go to the CLI Spark, and then you want to go to CLI Spark ETL. You want to copy the raw file as it stands. want to go back to the Nano text editor and you want to paste that in. So we've just created a py file inside EMR. You then want to hit Control X to exit it. You want to hit Y to save, and you want to hit enter. To check that everything's gone okay, type in cat spark etl.py. This will just print out basically the file on our screen, and yep, we can see that it has been saved successfully. Great. Next thing we need to do then before we run this file is a couple of commands. So you can see here we have to run this command, which is just going to export a few things for us. Then we have another export command we have to run, which is the second one here. So again, just run this. It's bringing up libraries that we require to execute this command. Then we have to run this. Now you can see that we do have to make some changes here. So this bucket name, we have to change to our bucket name. So I'm going to copy that. I'm going to paste it in, but I'm not going to run it. I'm going to go get our S3 bucket name, which is always sitting here. Probably should copy this out into like a notepad or something because we use it so much. And then I'm just hitting backspace to make sure I don't get any of this wrong. We want to delete where it says S3 bucket name and paste it in, correct? Make sure you still have those 2 forward slashes that you haven't deleted it right here. That's a common mistake that I make sometimes. I make sure that the forward slash is always in before the EMR directory as well. So I'm just going to get rid of that, and then you want to paste that in. And that should be us. So we're going to do a Spark submit command onto the EMR cluster. The file we've just created is sitting there, and then those are the commands that we need to actually reach the input and the output of Spark. Hit enter, and you can see then that we start to get brought up what it's actually doing. If we pay attention to this, we will see some output. Actually, it may take a few seconds, but it's going to start up for us, and this is us actually running EMR on the cluster. Okay, that ran successfully. I'm just going to blow this up a little bit bigger for us. And if you scroll up through the output, you'll actually see what we did. So this is the table. This is the data frame that we asked it to print as part of the code. If we scroll up a little bit, you'll also see that it printed out the schema. We can see the results of this and how it was transformed to Parquet by going back into our bucket, EMR, output, Spark, and it's sitting right there. There is our output as Parquet. We may, let me check, be able to do this through SC select. We're going to have Parquet. Let's just do output CSV, comma will do, and run. And you can see then that it successfully converted our file to Parquet for us, and that is the results of the output sitting there in S3. Okay, perfect. The next thing we need to do is actually delete that output because we want to overwrite it. So if we go back to output, highlight it, and then just hit delete. And then we're looking to permanently delete everything in this folder. That's correct. And we delete the object. Perfect. So make sure you delete that output. If we go down, then we've actually deleted the output. And the next thing we want to do is see how we can actually do this through a step in EMR. So rather than logging directly into the console or into the EMR terminal via our terminal, we're not going to do that any longer. We're going to do it through the UI on AWS. So back up here. And we want to go to our cluster again. You want to scroll down and go to steps. And this time we want to add a step. It's going to be a customized jar. We give it a name, so I'm just going to call this custom _ jar. The jar location is actually already on the cluster itself. So to do this, what you want to do is enter this here, which is called command -runner.jar. So it's going to call this jar from the cluster. And then we have a little bit of admin work to do here in the arguments. So make sure you paste those arguments in correctly. And then we need to replace the bucket name. So it's going to grab the script from our EMR location that we uploaded at the start of the setup. And then it's going to use these 2 input locations to grab the data and then this output location to write down the data to. And that's why we had to do the delete in the output. So we had the free. Back onto here, so I just copied that bucket name to make things very simple for myself because I'd rather just do this, and then we should have one more, this. Again, just double check that you got all those forward slashes in places, and that looks good to me. Just continue if it fails and add the step. That's it off and running. This will take maybe 3 or 4 minutes just because it has to add the step, then process the step. I'll pause the video here and then pick it up once it's done. Just keep clicking that refresh table button, and eventually we should see this going green. Okay, that's now running after about 30 seconds. My first one failed, and I just want to show you why. Despite me telling you to be careful when copying and pasting, you can see that I put a space in my file location here when pasting in the bucket name. So I've had to restart that, and you can see that I got rid of the space. So if you get that wrong, just add a new step and start again. Fortunately, you just have to be really careful with these things, but this should only take a few more minutes. Oh, there you can see it's actually completed successfully. So if I go back out, then I go to EMR, I go to output, and then you can see that we successfully outputted the parquet file that we were changing from CSV. Here we just want to then delete everything again because we need to clear this location, and we're going to permanently delete. I'm going to cheat by doing that. So with those two steps, although we're running a Spark script, it's just changing a CSV file to parquet. That's all we're doing. It's more about how the EMR works, either by logging into the terminal or running the step functions to do automatic scheduling. Okay, next we're going to look at using step functions to orchestrate our cluster. So to do that, we need to navigate to step functions. You can type step functions in the top bar and then just open up a new tab. We're going to do a state machine. We're going to create a state machine. We're going to do a blank state machine and hit select. What we then want to do is change the name of the state machine, which is up here. I'm just going to call this I'm just going to call this state machine step function EMR. We're going to do some event driven. So then we want to go back onto this little code icon here. If we navigate onto the GitHub and onto the EMR page, and we go back up out of here and we go to here, we'll see that we actually have state files. We're going to use the step function, and we need this fnf.json. So copy that and paste it back into here. Now what we'll see on the right hand side is actually the steps that we're going to take to do something with our machine. So this is an orchestration tool that's going to do multiple steps for us. So you can see then that we're going to add a step to the EMR cluster. We're going to do a Pive execution. We're going to do a pig execution. I'm going to tell it not to terminate the cluster, and then it will do a wrap up at the end. So what we then want to do is create our state machine as it currently sits. That's all fine, just confirm that. And then we want to hit start execution. If we go back onto the GitHub and we go back up a directory and we go into the arguments required to run our state machine are here. We do have to fill a few things in. So then just copy and paste that in. First thing we need to provide is our cluster ID. So our cluster ID is back here and it's sitting on our summary box. So we can just copy and paste that into our state machine. You just want to get rid of that here, and you guessed that we now need to replace our bucket name in several different places. So I'm just going to go get my bucket name the easiest way possible, which is probably like this, I'm guessing. Yep. And then we want to be very careful when we paste this in. Make sure we don't have any spaces or any mistakes. So no spaces. Yep, that's fine. There'll be about 9 places I think in total this needs replaced. Let's just double check. That's 2, 3, that's 4, 5, 6, and then there should be 3 more, 7, 8, and 9. We do not want to delete the cluster, leave that false because we're going to do auto scaling next. We then want to start the execution. And this will start for us. So blue, as you can see, means in progress. Red means failed. The warning icon with that yellow means caught in error, and green means successful. So I'll pause the video and then we'll start to see this go through the steps, turning green, 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 green. Okay, that's been running for about 4 minutes. You can see that the first stage has been completed. And you can see then that we, after a few minutes, will progress to adding the step to the cluster. And you can now see that we've progressed onto the pig job. You can actually check this as well, that they're progressing on the steps box or table on EMR. So you just go back and refresh the table. You can actually track them here as well to make sure they're happening. But yeah, you can also do it visually here. So there's 2 ways to do it. I'll just pause this again and then we'll pick it up once we've gone through this entire step function for scheduling EMR. Perfect. As you can see, that's all went green. So the step function executed those steps in order correctly, where we added the steps, the Spark step to the EMR cluster, added the Hive step, added the pig step, ran those, and then successfully wrapped up. Now you can actually see the outputs of those as well if you want in the output folder. So if we go here, We'll open the S3 bucket. We'll find the one that we've been using for the entirety of this course. Then in EMR, then in outputs, you can see that we have a Pega Hive folder containing the data that we were playing around with, basically to make the step functions orchestrate our EMR tasks. Just highlight everything. And then we need to delete this as well, because we're going to do one last thing with auto scaling. What we're going to look at now is actually how to auto scale the cluster. So to auto scale the cluster, you need to go back onto steps, and we need to go to right here. It says concurrent steps 1. So we need to edit that and change it to 5. So steps, then change it to 5. That means we can run 5 steps at once. Right. Next, we need to go to the hardware tab, which is hardware, like this. And we want to edit the cluster scaling options like that. We want to use a custom scaling policy like that, and then we want to hit the actions here. We want a minimum instances of 2 and a maximum instances of 5. You want to scale out. We want to add a custom rule. You want to open this custom rule. We're going to call this scale out just so I know what's going on. So scale _ out. You want to add 1 instances if apps running is greater than or equal to 2. For a count greater than 1 5-minute period with a cooldown period of 60. Then you want to click the scale in rule. You want to add a custom rule for scale in. You want to scroll down. We'll call this scale in just so we know what's going on. Scale in. You want to terminate 1 instance if apps running, again, apps running is less than 2 for a period of 1 minute and 60 seconds. And then save those changes. So that should be us there. So minimum instance 2, 5, save changes. Perfect. So we now have that auto scaling policy attached, and you can see that it's here. So 2, 1, and it's pending. This will take maybe 10 to 30 seconds to go attached. There you go, it's now attached. Okay, once you have that auto scaling policy in place, if we just take a look back on the GitHub for auto scaling, I have took you through all this down to here, step 15, well 14 actually. We're going to create another state machine, so we're going to use step functions again, but this time we're going to orchestrate it so our cluster scales. So back into the AWS console, I'm going to take a tab and I'm going to navigate to state machines, which are part of step functions. We're going to create another one. We're going to create a blank one. We're going to select. I'm going to edit the name of that. I'm going to call this one again state machine scaling, just so I know what I'm doing. Perfect. We're going to go back into the code tab, which is here, this code icon. And this time, back into the EMR file. I want to go to the step functions. I want to go to state files. I want to go to auto scaling, and we want to take the EMR SNF folder, or file rather, copy that contents, and then back onto here, get rid of that, and paste it in. And you can see here that we have a pretty complicated step function state machine. We're just going to add lots of different tasks basically to our cluster from the files that we've been using all along, and that's going to then force it to auto scale. You don't really need to understand this, but you can actually get a feel for how complex step functions and event-driven architecture can be for EMR. So with that being said, then we just want to create the cluster. That's all fine, that's confirm. Few seconds, then we want to start execution. Then you guessed it, back over onto here. We want to go up into that auto scaling folder, and we want to take the arguments file this time. We want to select it, and as always we have a few things we need to change. So back up the top again, we'll have the cluster ID first. So let's go grab that cluster ID again. Then we're going to have to change the S3 bucket in a few places, well 9 places. Again, you'd think by now I'd know the name of my S3 bucket off by heart, but I don't. So I'm just going to grab it, and it's always easier to copy and paste to avoid spelling errors and mistakes that can creep in. So again, just take the bucket name, copy that, and again, being extremely careful here, let's remove all these S3 bucket names. So that's 1, that's 2, that's 3, that's 4. This one will be 5, then 6, and then we will have more to go. 7. Oh, we're going to have more because 8, 9, because we're going to do multiple steps. 10, 11, 12, 13, 14, 15, 18. Still it goes. Still it goes. Got more. And another couple. And another one. We need to be really careful to make sure that we don't make any mistakes here. Another one. And another one. And another one. Still it goes. Another one. And another one. And another one. And still it goes on. Another one. Another one. Another one. And still it goes. $998. 100. 102. There's 150 lines, so we're almost there. Should maybe have 3 more to do. Yep. Okay. That all looks good, and then start execution. Okay, this is going to start doing things in parallel. So what we expect to see then is, if we go back, and we go back onto here, and we go to steps, you'll start to see a load of pending jobs building up in our EMR cluster. And what this will do then is they start to run. So we have more than 2 running. We're going to force the thing to scale. So we should have 3 running at some point. These will start very shortly. When it starts to scale, if we go down, we'll start to see more nodes being added to here. Okay, and that's everything we're going to cover in this tutorial. So if you just wait a few minutes, then everything will start to auto scale. If it doesn't auto scale for you, then you may have to run the state function a few times in parallel just to give it enough apps on the cluster, and that will start to auto scale. But the principles are the same, where you just add a policy and then you can force it to auto scale by the amount of load that's put on the cluster. Okay, so on to Amazon Kinesis. Amazon Kinesis is a real-time streaming solution. Real-time streaming solution, which allows you or a user to ingest, buffer, and process data. It's fully managed, so there's no need to provision those underlying infrastructure. Amazon Kinesis is scalable and can handle any amount of streaming data, and the processed data from thousands of sources with very low latency. Amazon Kinesis is available in 3 flavors, and we'll cover this throughout this section. We have Amazon Kinesis Data Stream, that's what we'll look at first. We have Amazon Kinesis Firehose, which we'll look at second, and then we'll have Amazon Managed Service for Apache Flink, and then we'll do the hands-on after the theory. So we'll do all 3 in theory first, and then we'll do the hands-on. So looking at data streams first, Kinesis data streams, you'll see this diagram a lot. It's something that I would get familiar with. You can see on the left hand side here we have things called producers. On the right hand side we have consumers, and then we have these downstream repositories that we're sending the data to. So a couple of things that I would look at on this diagram, so you're kind of in the terminology. We have what is known as a Kinesis data stream. This is a set of shards. Each shard, which is represented by these tubes on the diagram, is a sequence of data records. A data record is a unit of data stored on the Kinesis data stream, and data records compose of a sequence number, a partition key, and a data blob. A partition key is used to group data within a stream, and the sequence number is the number that it actually arrives within the partition key of the shard. Producers, which we can see out here on the left hand side, put records onto a Kinesis data stream. For example, you might send some log data, and then the consumers are how we get the data off the Kinesis data stream itself. Don't worry about writing those definitions down. I have put them here in more depth. I would read over these and get to know them, but always reference back to this diagram. So in summary, we have a Kinesis data stream. A data stream is made up of shards. On shards, we have records. Records are put onto the stream via the clients on the producer side here, and they are took off the stream by the consumers. I would also spend some time reading about the size of things. For instance, a data blob can be up to 1 megabyte, and the restrictions around what you can and can't put on a stream itself. Some things that you might need to know for the exam, and again, we won't spend too long on this, you need to read through this and kind of learn it in your own time, is that there is a Kinesis consumer library. This takes care of many of the complex tasks of the distributed processing and allows you to focus on the record logic or the record processing logic. So it connects to a data stream and allows you to actually read off the stream, but it keeps checkpoints of what's going on. When we do the hands-on demo, we will not be using the Kinesis consumer library. We'll actually be doing it through API, and you'll see that it's a bit more involved when you have to do it via API. So the recommendation is to use the Kinesis consumer library where possible. And that means in terms of the exam, when you're presented with a question and it says, what should I use to consume data off Kinesis? That will keep checkpoints for me and make it easier in the long run looking after the complex tasks associated with distributing processing. You should be thinking Kinesis data, the Kinesis consumer library for data streams rather. So you should be thinking the Kinesis consumer library for data streams. You can also consume through an SDK, and that's what we'll actually be doing kind of using the CLI when it comes to the demo that we'll look at further on in this part of the video. But for the SDK, you have put record and put records. You can actually fool around with operations, and you're allowed 1 megabit up to a limit of 5 megabits. The Kinesis producer library, on the other hand, when you're trying to write data to the streams, actually it's easier to do this because everything is there, but it's only available in Java. So these are two ways that you can put data onto a stream itself. Something that does come up on the exam more often than not is Kinesis Data Streams Enhanced Fan Out. So Enhanced Fan Out is a feature from Amazon Kinesis Data Streams that provides dedicated throughputs for customers to read data from a stream. With standard Kinesis consumers, there is 2 megabits of throughput per shard. So per shard, you get 2 megabits of throughput among all the consumers reading this. This can lead to increased latency as more consumers are added. Fan Out provides a dedicated 2 megabits of throughput per shard per consumer. So that's the difference. In this version, you get 2 megabits per shard. In the enhanced fan out version, you get 2 megabits per shard per consumer. So that means consumer X here has 2 megabits for itself, and consumer Y here also has 2 megabits for itself. There is an increase in cost for enhanced fan out, but it's solving problems that customers have in terms of consuming and latency. Kinesis Data Firehose is the easiest way to load streaming data into data storage and analytics. Primarily, I see this being used to write straight to S3. So when you're using data streams that we saw in the previous section, you're in charge of the consumer. So you have to write a consumer in EC2 or in Lambda, and it will consume off the stream. With Firehose, this is automatic, and it'll actually write to things like S3, Redshift, and OpenSearch. We do see this in production quite a lot to simplify the integration between these systems. So as a data engineer, you should be thinking in these terms when you come to the exam for the certification and it says, what is the service I should use for streaming to S3? You should be thinking Kinesis Firehose. We also have a relatively new service called Amazon Managed Service for Apache Flink. This allows you to stream data in real time with Apache Flink. This service handles the underlying infrastructure for your Flink applications. You can also run Flink with EMR, but this simplifies it for you in a more managed service manner. So for the exam, thinking aloud, so for the exam, you should really focus on Kinesis data streams when we're looking at it here and understand that things are in shards, and these shards have 2 megabits of data per shard. You have producers and consumers on the streams themselves, but if you want to automatically write to S3, Redshift, and the likes of OpenSearch, then you should be thinking Firehose. We'll jump onto the AWS console now and take a look at data streams, and we'll take a look at Firehose in action. You should be reasonably familiar with these services if you do have the recommended 2.5 years of experience with AWS before sitting the certification. Okay, folks, the first thing we want to do when we're on the AWS console is go to Kinesis. Then we want to navigate on the left hamburger menu to data streams. And then we want to create a new data stream. The name for the data stream should be customers underscore data stream. Or underscore stream. I have put it here in the GitHub and all the steps here that we'll need alongside the code. So if we just paste that in, we want to do a provision mode. So you have two types of mode when it comes to Kinesis. You have on demand where it will scale up for you with some limits, but that can get quite expensive, or more expensive than the provision mode. Provision mode is where you tell Kinesis what you want. So for this, we're going to start with one shard, which will give us the maximum capacity of 1 megabit per second or 1,000 records per second. We're not going to get anywhere near the limit of this during this tutorial. This will cost a few cents if you spin it down afterwards when we're done. It shouldn't cost too much, but you will be outside of the free tier if you are following along. If you don't want to have any cost associated, then you can just watch me do the tutorial for you. Once that's done, you just want to create the stream. It's as simple as that. This will take 4 or 5 seconds to get up and running usually. So a couple of refreshes and you can see that we have gone active. Down here, you can see we have ways to use producers where you can go to GitHub and look at Kinesis Agent, the SDK, or the Kinesis producer library that we've talked about. Down the bottom here as well, we have consumers where we have the Manage Flink that we've talked about or will talk about, Data Firehose, and the Kinesis client library as well, sitting down there. Now, across the top, we have monitoring, which will show you some of your stream metrics. We don't have anything really going on right now in the stream, so that's fine. On this tab is where we have enhanced fan out, where if we had more consumers or a lot of consumers and we need to give them dedicated methods to actually consume from our stream for an additional cost. Apart from that, that's pretty much what you get with Kinesis. There is a bit more on the API, but we'll not be covering it during this tutorial. What we're going to do now is actually place some data on the streams. So to do that, we're going to use Cloud Shell, which is a command line tool on the AWS console. So if I just pull this up, it will be automatically configured in the region in which we're working, which I am in the Ireland region itself. And once you have the command line prompt up, then you're ready to go. Back onto the GitHub, you can see that we have to do this to put some data onto our stream. So this is the CLI command called put record. It has the name of the stream that we created, customer stream there. Partition key is customer. That's just something that I've set to make it easy for us. You can change this. This is a user inputted key. You will need higher cardinality and partition keys to get higher throughput, but without sending your data everywhere. There's a bit of a nuance when it comes to Kinesis, but for the purposes of this tutorial, we're just going to call it customer. And then we have the data itself. So the data itself is what we saw throughout the rest of this tutorial. It's just customer data. So I'm sending up a customer with a first name, last name, full name, and customer ID. We do have to then serialize this into a base 64 encoding, which is being done by this command here at the end. We're going to put on 3 records. That's why I have 3 of them here. There's 3 different people or 3 different customers. So if we put in the first one and we just copy and paste it in, we should be good just to send that as is. It'll give us a return message that our sequence ID and shard ID. We will need that shard ID later, but not now. Then we'll just copy and paste down the second one. And then we will copy and paste down the third one. They're just returning similar things as we do, apart from the sequence number obviously may be different or will be different for each one. Okay, so that's 3 pieces of data onto the Kinesis stream. Now we want to actually consume from our Kinesis stream. Now, as we're using the CLI, there's a little bit more to this, so just bear with me. So the first thing we want to do is describe the stream. So this is an API call, which is going to describe our Kinesis stream. I'm just going to bring this up a little bit for us as well. Maybe just zoom in a little bit so you can see this clear as well. So if I scroll down and I rerun this for us, you can see that when I ask to describe the stream, we get information about the stream back. So you can see we have a shard ID, we have a hashing range, we have sequence numbers, and we have things like the stream ARN. It's active. We're keeping it up for 24 hours in terms of the data that will be retained. So to get out of this, I'm just going to go colon Q, and that is me out and quitted. We are going to need the shard ID in a little second. So that's why we're describing the stream, is because we wanted to get the shard ID. This will help us consume data off the stream itself. When you're using something like the Kinesis client library, Kinesis or the client library itself will keep track of all this for you. You won't have to know this much detail in order to retrieve records. But because we're using the CLI this time, we do have to know this kind of information. So down here where it says shard ID, right here, we're going to replace this with the shard ID we got above, which is here. And then we just go and delete this. And I'm just going to paste that in, take a space for that argument, and then hit enter. This will return a shard iterator. Again, I'll say that again. Normally, if you're using one of the libraries like the SDK or the KCL, you won't have to do this, but because we're using the CLI, we do. And that's just for the purposes of showing you how things work in Kinesis. So it's better to have this detail and then never have to use it. Then we need to give it the shard iterator. So just get rid of that. And then you want to give it the shard iterator, which is this whole thing here. So if we paste that in, then we'll get back our records. Now you can see there's 3 records. You can see our partition key is customer because that's what we specified. You can see the sequence number. You can see the approximate time of arrival. And then we have the data. But the data just looks like a giant blob. And that's because it's base 64 encoded. So now we need to decode that data. So the easiest thing to do is just type in decoder base 64. I've got cap locks on, but it won't matter. Go to one of the free resources like this, paste in your data, and then hit decode. And you can see down the bottom here, again, I'll just scroll in a little bit, or zoom in a little bit for us. You can see then we get our decoded data as we entered it. And you can do that for the other 2 as well, and you'll see that we've successfully put data onto the record, or produced data as a record onto the Kinesis data stream, and then we have consumed those records off the stream. We've consumed those records using the CLI. Bit more involved, as you can see, having to get the likes of the shard iterator. If you're using one of the libraries, and please always use one of the libraries is my advice, then a lot of this will be looked after in behind the scenes for you, and you can just concentrate on retrieving the data. But it's always good to know this information for the certification that you're taking. Okay, for Firehose, then we're going to use this stream, this customer stream, as a source. So we just click on then Amazon Data Firehose at the left-hand side of the Kinesis menu. We're going to go create a Firehose stream. First thing it asks us to do is pick a source. So for us, the source will be a Kinesis data stream. The destination is going to be an Amazon S3 bucket. So we're going to output things to the S3 bucket. If you click browse, then we only have one stream, so that's easy. You can give it a stream a name or leave it as default. The option is up to you. We're not going to do any of this for the purposes of this demo, but if you wanted to use Lambda to do transformations, or you wanted to convert the record format from JSON to Parquet, this is where you can tick it and have those automated features, obviously apart from the Lambda, where you have to do some work with the Lambda. Next, you need to find the bucket that we've created for the purposes of all these demos. So I'm just going to find that now and select it here. Then we scroll down, and if you want to have an output location, which I do, then you need to give it here. So I'm just going to call this Kinesis output / and that means then that we know that we're going to actually have the data land somewhere in S3 and not get confused with our other data. Apart from that, then you can create the Firehose stream, which is what I'm doing now. This will take a little second. Perfect. Now we've created the stream. Our Firehose stream is new. It will not read the data that's currently, or we already put up onto the Kinesis data stream. So we're just going to have to resend that data. So again, let's go into that Cloud Shell terminal that we can load up. To get rid of this again, just :Q. Inside, make sure you're in there and :Q. I am out of there. Then what I want to do is just resend these 3 bits of data. So 1 bit of data, 2 bits of data, and then we want to send that 3rd bit of data. Okay, now because of the buffer settings that are around with Firehose, and we've only sent 3 bits of data, we will have to wait a few seconds, if not minutes, for this data to come through. So I'm just going to pause this video and then pick it up once it's gone. To check when your data arrives, you can just go on to the S3 console by going to S3. Then you will be looking for your bucket, which we have called Data Engineering Johnny Chivers Tutorial. And then on this directory here, because this is where we put it, we'll see that folder appear for the Kinesis stream, and then we will see the data come maybe in the next minute or so. I didn't change any of the defaults here, so because I've got a 300-second buffer interval and my data cache is a lot smaller than that currently, we'll have to wait 5 minutes for that data to appear on S3. So just wait 5 minutes and the data will arrive into S3. Okay, so after 5 minutes, you can see that that folder has appeared in the S3 bucket by refreshing there. Kinesis output, then it's split up by date as it said and time, and then we have a file. I'm going to actually download this file, so if I hit open, I'll save it in my downloads and we'll go across. We load it up, it's probably going to be quite tiny, but you can see that it has streamed my records off the stream and then put them into a file, stored that in S3 as promised as a managed service. Last thing to do for this tutorial is just clean up those streams because you don't want to be charged for more resources than you're using. So just delete the firehose stream. It'll ask you to enter the name of the firehose stream to confirm that deletion. Enter and delete. And then I'm going to get rid of the firehose window and go to Kinesis itself. Then go to data streams. Highlight the data stream, actions, delete the data stream, and then we want to delete. And that's rid of the data stream, and then we will stop being cost for those resources. As I said, probably a few cents being spent here, but just be careful with those charges and make sure you shut everything down when you're finished. Amazon MSK, just a brief word on MSK. So this is managed Apache Kafka infrastructure and operations. If you've been a data engineer for the last couple of years, you should be aware of Kafka for streaming. The MSK version here provides a control plane for operations, creating, updating, and deleting the cluster. MSK runs the open source versions of Apache Kafka, which means you can use the plugins as well. Just a little bit about MSK in general. We do have replication within a cluster. This is where the data is replicated between brokers. Brokers you can think of as compute instances. Similar to Kinesis, you have producers that put things onto MSK and consumers that take things off. If you need to spend some time looking at MSK or Kafka, you're not familiar with it, a quick Google will start to get you down that road. It's interesting for the exam because it kind of blends. If you really go into the in-depth of Kafka, you're really looking at infrastructure when this is a data engineering certification. So it may come up and you may need to spend some time just looking at Kafka. But let's actually focus on the differences between MSK and Kinesis because this is more likely to come up in the exam situation. It doesn't mean the infrastructure won't come up. It just means that I have the opinion this is more likely. So you can see here that MSK has up to 10 megabits per message, while Kinesis data stream has 1 megabit per message. So again, thinking in that exam context, if you had a 5 megabit payload as a message, then you can't use Kinesis data streams. You have to automatically go to MSK. This is a little bit of an interesting one. Kinesis data streams uses shards, topics have partitions. They're kind of the same thing, but it's worth bearing in mind in case a question comes up that specifically says, I want to manage Kafka topics because my engineers at company ABC are more comfortable with it. Well, the only thing that has topics is Kafka. You can see here that you can split shards and merge shards. You can only add partitions to a topic in MSK. You can't take them away. In terms of encryption, they're both fully encrypted, but security is slightly different. Although there is IAM security on MSK, you also have the likes of TLS and ACLs as well available to you. So depending on what the question asks in the certification, if you needed ACLs, access control lists, or you needed mutual TLS, then you'd have to go for MSK. If you were only interested in IAM and that was called out during the question, then you could use Kinesis data streams. That's the way you should be thinking about these things. Amazon OpenSearch is a service from AWS and it's a fully managed service for deploying, operating, and scaling OpenSearch clusters in the cloud. OpenSearch is an open source distributed search engine for analytics, which is a fork of, and this is important, a fork of the popular Elasticsearch and Kibana software. So you may have came across Elasticsearch and Elasticsearch clusters. OpenSearch is a fork of Elasticsearch and it's used for distributed search, visualization, and analytics engines. Amazon OpenSearch Service is a managed service for deploying, operating, and scaling OpenSearch clusters. So the OpenSearch Service is where OpenSearch, which is an open source engine for distributed search, visualization, and analytics, is then took and helped to be set up for you as a data engineer. Use cases, and again, this is probably more in line with what the certification will be asking, is for log and event data analysis, full text search, which is where I use it quite a lot. So data engineers would load data into OpenSearch or the OpenSearch service and then do full text searching on it. Real-time application monitoring and business analytics as well. Some key concepts you should be aware going into the exam, just so you know. We first have a document in terms of OpenSearch. This is also true for Elasticsearch. So a document is the basic unit of data that can be indexed. So an index, which we'll get onto in a little second, is the logical namespace that stores a collection of documents. So indexes are made up of documents. Documents are represented in JSON, and as you can see here, we'll actually be using this during the hands-on demo. The JSON itself contains information. This gets loaded into an index. In this case, the index is movies. We'll have lots of different JSONs with the movies, and then we'll be able to search that index by going, show me everything that has Director Stewart as the name. Show me everything where title equals Marshall. Show me everything where actor contains Tommy Lee. And we'll be able to do this during our hands-on tutorial. So again, indexes are made up of documents. Documents are JSON. JSON looks like this, and this is what you ingest to search into the OpenSearch service. Indexes, as you can see, are made up of shards. Documents are hashed onto a shard. So what does that mean? So this is actually off the OpenSearch documentation. Full credit to them. You have an index. The index is sharded. Then the index contains documents. Documents are JSON. So in this case, we'd have 4 JSONs. Document 1, document 2, document 3, document 4. They're put onto 2 shards, and then it's these shards and documents that get searched by OpenSearch. You should be aware of this. Again, we're blurring the lines of infrastructure and data engineering, although these lines are getting more blurred every day. Primary shards are the main shards that contain the original data of an index. Replica shards are exact copies of the primary shards. They serve 2 main purposes: providing high availability, i.e. if you lose the primary shard, you can use one of these shards, and load balancing for search operations. This is important because when you search OpenSearch, it means it doesn't always have to go to the primary index to actually perform the search. It can go to the secondary index or the replica shards to perform that search. And when it's performing that search, then it doesn't have the burden on the primary shard. This may come up on the exam, so I always think this is really important to know. Memorize this. To calculate the amount of storage capacity for an index in OpenSearch, you take the size of the source data, so let's say it's 1 gig, times the number that 1 plus the number of replicas, 1 plus the number of replicas, this 1 being your primary instance. So you have 2 replicas, it would be times 3. So if you have 1 gig times 3 times 1.45. This 1.45, this 0.45 is the overhead of converting your data as it sits in JSON into an index. So with this equation, and if it comes up in the exam, you should be able to calculate the storage capacity for an OpenSearch index. Another thing that comes up in the exam, again, that has been asked, or I've heard has been asked, is that the JVM pressure on a cluster is caused when shards are unbalanced. So you'll get a question, or possibly get a question, asking you to relieve JVM pressure on a cluster because users are noticing that the search is getting slow. So to fix this, you need to offload data that's not being used to S3 or other storage services, then delete the indexes which are not being used. So one of the questions will ask you, how do you relieve JVM pressure? And you'll say, well, we actually then get rid of the unused index, and then that means that we have more memory on the cluster. This may come up in the exam. I would take some time to learn this. So the first thing you want to do is navigate to the OpenSearch service. I'm already on the page, but if you're not there, you can just type in OpenSearch in the top and then click on, and you'll be took to the OpenSearch service. You want to go to create a domain, and you want to give your name, or your domain rather, a name. I'm just going to call this cluster DE for data engineering. We want to go to standard create. We're going to do dev and test. We're going to do without standby. We're going to do it in 1AZ because we're just practicing here, so there's no need to pay for more than what we need, which, bear in mind, we will be going outside of the free tier here. We want to go to general purpose, and then we just want a small instance that we're going to use, so that's fine. We'll get a warning about it being suitable for test only. That's also cool. We'll put that down to 1. We will take the storage type down to 10 per node because we don't need it to be that big. Keep scrolling down, scrolling down, scrolling down. Network, make sure we select public access. We'll go IPv4 only. We don't need anything else. We then want to create a master user. We need to give this a name, so I'm just going to call this username because that's kind of easy to remember. And then you need to give it a password with at least 1 capital, 1 letter, and 1 special character. So I'm just going to give mine password 1 with a exclamation mark. Scrolling down, this is all fine. We're going to use fine-grained access control only. I repeat that, we're going to use fine-grained access control. Encryption's cool the way it is, and everything else is grand. We can just hit create then. So 1AZ, T3 small, one data node, 10 gigabytes of data on disk. Again, I am trying to keep the cost down here to a minimum. This will leave the free tier quite likely, but the cost should be in the cents, 10, 20, 30 cents for as long as we have it up rather than several dollars. Again, if you're not comfortable going outside the free tier, don't feel that you have to and just watch me do the demo. So let's hit create. This will take anywhere between 5 and 20 minutes to spin up. Usually can take a little bit longer. You just need to keep refreshing. At the top as well, if you look at view details, it'll give you the steps of where it is. I'm going to pause the video here and then we'll pick it up once this has gone green and my cluster is available. Okay, once it has completed spinning up, you'll get this completed in green and your domain will be active. Now what we're going to do is process a document or put a document onto a new index called movies. Then we'll actually add a whole lot of documents via bulk upload and then we'll get a document back. All this is explained again in the section Amazon OpenSearch tutorial and we'll be using some of these commands. So the first command, I'm just going to paste this into a text editor so we can take a look and actually alter some of the code. You can see that we're going to change this over and this over to our username and password. We'll change the domain endpoint over to our domain endpoint. Don't worry, I'll do that in a second. But let's just take a quick look at the document itself. We're going to put a new index called movies and we're going to put this document that has information about the director, the genre of the movie, the year it was out, and actors. So with that in mind, we need to change this over to our username, which for me was username. And then username, make sure I get that right. Then here you have to change to your password, whatever you entered as your password. So mine was password 1 exclamation mark. And then this domain endpoint has to be changed to your domain endpoint, which will be located here in the console. You can just copy that, get rid of the domain endpoint, but keep in the / movies and then paste. Then I'm going to copy that entire command into a terminal window. So this is my terminal window. I just went and got one before we started by going terminal. Same for command line. Then paste it in and hit enter. And you should, if it were to get back this JSON that it went in, so you can see that we've indexes on movies, it's got the ID, the version, the results, it says it's created. Shards in total we have 2, successful we're good, and we can see that we have 1 primary term. And that's how we know the command was successful. For the next bit, we're going to use the bulk upload API to upload a JSON. So that JSON itself is in part of this GitHub. If you've downloaded it at the start and have it on zip, perfect. We're going to navigate there in a little second. We are going to need to run this command as well in step 9. So we can copy that into a text editor because it's just easier to work with there. I'm going to go down again and then we have to change our username again. So mine is username and then my password is password with a capital P. So password 1 exclamation mark. We have to change the domain endpoint again. So that's simple onto the console and copy across. So just paste that in. And then quickly looking at the actual command, we're going to upload this bulk movies JSON with the content type application JSON. I'm going to copy this, but what we have to do from the terminal is navigate to that JSON. So mine has been stored in my downloads my entire time. It's that unzip file. We're going to go to OpenSearch and we're going to go to bulk movies. And that's where we're going. Being lazy on Mac, I can just do CD, then go to the folder itself, which is this one, put it in like this. Hit my arrow command and that will actually allow me where I need to be like this. Then I paste in the command because I'm in the same directory of where I've stored the bulk movies. I hit enter and you can see that it ran, so it took 39 milliseconds, there was no errors, and these are the items that we put up in total. Perfect. So you can see we've got more documents onto the actual index called movies itself. Next step is actually to retrieve something. So again, on to step 10 this time. If we copy this into our text editor, and again I'm just going to take a few new lines because it's easier to see. We need to update this again to our username. So mine was username. You need to update your password. So mine was password with a capital 1 and an exclamation mark. Then the endpoint itself, well, that's always been on the console, so we just copy that endpoint, get rid of everything from there. And before I actually paste, you can see that we're going to search for something that has Mars in its title. So we're looking for something that has Mars. If you remember back, that's the first document. So that's the Mars attacks document that we're after. Paste it in, Give it a little second, and you can see that it returns the JSON of Mars attacks. So you can see here that it's from the movies index, or director with Tim Burton, but most importantly here, the title says Mars attacks, and if we look at the query itself, we're searching for something that has Mars in the title. Okay, next thing we need to do then is log into the dashboards themselves. So if we go over to the console, you'll see that there's a link to OpenSearch dashboards. You need to hit that link. Username and password is the same as what we've been using. So mine's is username, then password with a capital P and an exclamation mark, and we log in. This will take a little second if it's your first time. Just ignore all this. I'm going for a global tenant, and then anything else I'll just exit out of. Once here, you want to go and open this little hamburger menu. Once here, you want to go to the Discover tab. We won't have any index patterns yet. We want to create an index pattern. You can see that we have one called movies down here, so we're just going to go for movies with a star, then next steps. Then we just want to create that index pattern, and we're creating an index pattern. That's our fields that are present. Perfect. Then we want to go back on to the hamburger menu. We want to go to Discover again. This time we have an index, and this is where you can start to search. So up the top here, let's say we wanted to look for a crime movie. I would just type in crime, hit enter, and you can see we have two. We have Frankenheimer, and we have, that's the director rather, sorry. We have the Manchurian Candidate, and then movies wise we also have US Marshals. Again, if I get rid of that and hit enter, you can see that we have everything back. So this time, let's say I wanted to find something that had Dennis and Dennis in its name, then you can see here that it's able to pull up something with Dennis as Dennis Hopper. So this is actually how you search in the dashboards for OpenSearch. This is a pretty basic demo, but it does show you some of the power of Amazon OpenSearch service. Once you're done playing around, and I do advise you to play around with some different commands, you'll need to shut down the service. So to do that, you'll just go over here, you'll hit delete, and then it'll ask you to enter the name of your cluster. So mine was cluster DE, so I'll just type that in and delete. Make sure you delete there just to save yourself any charges. That'll take a few minutes, and once done, that is Amazon OpenSearch spun down. Amazon QuickSight is another favorite that comes up in the exam quite a bit. So if you haven't used QuickSight before, it's a cloud-based business intelligence service. It enables organizations to easily create and publish interactive dashboards that include insights derived from their data. QuickSight is designed to be fast, scalable, and easy to use, making it accessible to users ranging from data analysts to business executives. So this is where it gets interesting. So this is actually a QuickSight dashboard on the right-hand side I've put up as an example. And use cases would be business reporting, data exploration, operational analytics, and customer insights. So in terms of the exam, again, when you're asked what would you use for business intelligence reporting, or a use case is presented where a user needs to perform business reporting and customer insights, you should be thinking QuickSight. We should be thinking QuickSight for that part of the certification. Key features, as you can see, data visualization and dashboards, machine learning insights, interactive exploration, access control, scalable and serverless, data connectivity. Spice Engine is an inbuilt engine into QuickSight itself. So if you've data in S3, you can load it into the Spice Engine, and that makes it faster to analyze. And there's mobile access as well. So again, thinking in terms of the exam, when you're asked, well, I need a scalable and serverless business intelligence solution for my interactive reporting, thinking QuickSight. You should always be thinking QuickSight. Integration's kind of important because it's just a dashboarding tool, so you need somewhere to actually integrate things. Amazon Redshift, again, that's a favorite question that can come up in the exam. I have my data in Amazon Redshift. What should I use for business intelligence reporting? Or you could be presented with an architecture with Amazon Redshift and QuickSight and asked to pick it for business intelligence reporting. You have Amazon RDS, Amazon Athena also integrates Amazon S3, as I said, alongside the Spice Engine, which is the inbuilt engine inside QuickSight where data can actually be uploaded to be closer to QuickSight. On-premises databases, SaaS applications, cloud databases like Snowflake also integrate with QuickSight, and flat file uploads where you can just upload a file directly to QuickSight. Another favorite of the exam is it will ask you how to access QuickSight using a VPC. Essentially, you need to create a VPC endpoint for QuickSight. A quick Google if you don't know what that is, but you pretty much should after 2.5 years of using AWS. configure some security groups they'll actually let in the same way we did during the EMR tutorial, and then enable VPC access in QuickSight. So inside QuickSight, there's actually a setting inside QuickSight that you click or turn on VPC access. So there's 3 things you have to do: create the endpoint, let the security groups be open to QuickSight, and then enable VPC access for QuickSight. Again, exam favorite, learn the 3 steps, be able to pick them out when it comes up in the exam itself, the certification itself. Amazon DynamoDB, oh, it's a favorite. It does come up a lot. So let's do a bit of an intro. Again, you're probably aware at this stage if you're thinking about a certification of what DynamoDB is, but we'll do a brief intro. So it's a fully managed serverless NoSQL database. It can handle large volumes of data and high request rates. It can also manage data in a key value and document format. Again, pretty high level. At this stage of your AWS career, you should be aware of what DynamoDB is. What's interesting, and things to always bear in mind, because some people forget these as they go along, is that you have a partition key in DynamoDB. This is your unique key or part of your primary key, and this is what the data is partitioned on. Usually something like product ID, customer ID, something that has high cardinality. You can also add a sort key, which lets you store multiple items with a partition key. This is optional. If your partition key is not unique, you can add in a sort key. So in this example, you can see we have product ID and then we have type. And then attributes are just basic information. So attributes is everything else that we store in the table. Really should hammer this home then. Partition key is your unique identifier for an item. Sort keys can be added if the partition key is not unique. Partition key should have a high cardinality, and then we have the attributes on the end. The exam will also expect you to know about DynamoDB indexes. So there are 2 types of DynamoDB index. The first is the global secondary index, and the second is the local secondary index, or GSI and LSI for short. They're both mechanisms to create alternative query patterns for your data. So that's important. The reason they exist is to let you have different query patterns for your data. And we'll see this in the live demo that you can follow along with shortly after this bit of theory. Global secondary indexes allow you to create an index with a partition key and an optional sort key. They can be different from those used in the table's primary key. So the primary key can be different on global secondary indexes, and that's important because you may want to create different query patterns. And actually, for all intents and purposes, and actually physically as well, when you create a global secondary index, it's just another DynamoDB table. It sits in behind the scenes. You don't manage it or call it anything. It's just called a global secondary index. Local secondary indexes are different because this allows you to create an index with the same partition key as the base table, but a different sort key. LSIs are local because the index is scoped to the items that share the same partition key. So again, local secondary indexes are local because the index is scoped to the items partition key. Okay, so the exam will expect you to be able to choose between a GSI and an LSI. The highest level that I can kind of give you is wrote here, where if you need a different partition key for your query patterns, then you have to have a GSI. You also can scale the throughput independently from the base table with a GSI. You cannot do that with an LSI. And if you require indexing across the entire table without the constraints of a shared partition key, i.e. you can't use the same partition key for any sort of index. LSI is interesting because it does give you consistent reads because it is the base table, or it doesn't have a separate table. But just remember that you're constrained to the same partition key. So if you have to use a different partition key, then you're always going GSI. If you can use the same partition key, then think LSI, local secondary index. You will, for the exam, be required to know read and write capacity units of DynamoDB. So these are used to measure the throughput capacity required to read and write operations on your tables. These units help manage performance and cost of a database operations by allowing you to specify and pay for the level of throughput you require. So read capacity units are how we read data, or how we measure the throughput capacity for reads, and write capacity is how we measure for write capacity units. Here is an example of read capacity unit. So a read capacity unit represents 1 strongly consistent read per second, or 2 eventually consistent reads per second for an item up to 4 kilobits in size. So 2 eventually or 1 consistently. So if we look at the example that I've put here, a strong consistent read of an item of 4 kilobit or less consumes 1 read capacity unit. Therefore, reading an item of 3 kilobytes using a strongly consistent read consumes 1 RCU. So let's read that again. Reading an item of size 3 kilobytes using strongly consistent reads consumes 1 RCU. And an eventually consistent read from an item of 4K or less consumes 0.5 or half an RCU. So reading an item of 2 kilobits using eventually consistent reads concedes 0.5 read capacity units. Larger items, for larger items, each read capacity unit can handle up to 4 kilobytes. If the item is larger, then it consumes additional RCUs. So if you had one item of 6 kilobytes and you wanted a strongly consistent read, then you would need 2 RCUs for that. Write capacity units is always the easier one for me to remember because it's 1 write capacity unit per item for 1 kilobyte. So if you had 1 kilobyte or less, then this would consume 1 write capacity unit. Writing of size 500 bytes would also consume 1 read capacity unit. Writing larger items, each write capacity unit can handle an item up to 1 kilobyte. If the item is larger, it consumes examples. So if you had 3 kilobytes, then it's 3 divided by 1 equals 3, and you would have 3 WCUs. The exam may expect you to calculate RCUs and WCUs, so make sure you learn these bits and how to do the calculation. So 1 write per second for an item up to 1 kilobyte, and a write capacity unit is 1 strongly consistent read for an item up to 4 kilobytes in size, and that is 1 strongly consistent read or 2 eventually consistent reads. Things you also need to know for the exam, because you may be asked some cost optimization questions, is that there's the provision mode is where you, as a user, specify the RCUs and the WCUs based on the expected load. This is cost effective. It's not official and it's not wrote anywhere, but if you do the calculations, provision mode is about 6 times cheaper than on-demand mode. The thing with on-demand mode is that it just automatically adjusts the capacity to accommodate your workloads as they scale up or down. It's a set and forget, but you will pay more for the privilege. Again, good to know for the exam. If you're on-demand mode, you know exactly what your throughput's going to be, then you could switch to provision mode. Then using the calculations for WCUs and write capacity units, you can actually work out what provision or what amount of throughput you need. Again, for the exam, be aware of PartiQL, DynamoDB. This is one of the newer features in a service that's quite old now, but it allows you to write, select, and insert, update, delete data in DynamoDB through PartiQL. That's a SQL-like query access across the data stores of structured, semi-structured, and nested data. You used to only be able to kind of find things on the partition key, sort key, and then filter. But with this, you now have some SQL available to your analysts or yourself as a data engineer to write. Handy to know if you need it. DynamoDB Accelerator, or what everyone actually calls it is DAX, is good to know because it will allow you for in-memory caching. This is mainly for read performance. So if you have a question, again on the exam, that talks about read performance from DynamoDB being slow, there's not a lot of writes to the table, then you could go for DAX, because DAX will speed up the performance when it comes to reading data. So again, in terms of the exam, be aware that DAX is a cache, an in-memory caching service for DynamoDB. It will improve the read performance, and if you have something that has low writes but high reads, this could be the solution on the certification that you need to pick out. DynamoDB Streams, see this a lot in production. This is a feature of Amazon DynamoDB that captures a time-ordered sequence of item-level changes such as inserts, updates, and deletes in a DynamoDB table. So when an item is changed in a DynamoDB table, it's popped off onto a stream known as DynamoDB Streams, which is managed. It persists there and then can be consumed by other applications downstream. Likes of Lambda would be one that I see quite a lot being used, or EC2s, or even passed on to a Kafka stream afterwards, a self-managed Kafka stream or an MSK stream, and then something is done with the event, becoming ever more popular in architecture. Speaking of which, if we look at this one, this is taken from AWS blog, where data is being populated in DynamoDB using streams. This is actually pushed onto a DynamoDB stream, then on the Kinesis data stream, because Kinesis has integration natively with Redshift. That is then ingested into Redshift, and then dashboards are actually used off the top through QuickSight. So if you look at this end-to-end data engineering pipeline, this is the type of thing that might come up in the exam as architecture. They might ask you, well, we have this going into a Amazon DynamoDB database. How do we get it into Redshift? And you could think about, well, we could place the items onto a DynamoDB stream. These could be consumed by an Amazon Kinesis stream. Amazon Kinesis stream has the ability for ingestion into Redshift. We'll put it into Redshift. Then we'll actually use a store procedure in Redshift to store this data as we want it for analytics. And we'll put QuickSight over the top of it for dashboarding. Again, just to reiterate, this is the type of thing that you need to be thinking of going into the certification. Another example, I have saw this a lot working with customers, and I've put links down to the bottom that you can go have a look at. When items become too large for a DynamoDB table, it is no longer effective to store that large object in DynamoDB. It can affect the read and write request speed of DynamoDB, the cost of the table, and even if your item is too large, it won't be stored in DynamoDB. Instead, there is a function or a pattern known as the S3 pattern that you can store the large object. So let's say we have a photograph. We store the photograph in S3. We store the pointer to the object in S3, i.e. the S3 URL in DynamoDB. Then we have an API when we want to actually get that object, i.e. in this case an image. You can use the read function to go to DynamoDB, get the S3 location, and then use the S3 location to send it back to the client itself. Real world example of this is my website, www.johnnychivers.com, where all the pictures are actually stored in S3. The location of the picture is stored in DynamoDB, and when the web page loads and the picture itself hasn't been cached, it goes to DynamoDB, gets the S3 address, knows where the picture sits in S3, and loads it into the cache. Again, really common architecture pattern. You should be aware of it. I know I'm saying pictures here, but this could be highly large blob objects or things that you need for data analytics. Works the same in principle. Okay, once back on the AWS console, we want to navigate to DynamoDB. So just type in DynamoDB and click onto it. Then you have two ways to create a table. I'm just going to get rid of this drop-down box. You can go get started on the right-hand side, or where it's traditionally been forever is on the left-hand side and tables. To create a table, you hit the big Create Table button and you give it a name. So in this case, that's called the table Customers. We then need to specify the partition key. So the partition key should be unique or as unique as possible throughout your DynamoDB table. So in this case, let's call this customer_ID. Let's look at customized settings just so you can see what we have options here. You can see that we're going to go for DynamoDB standard. There is a DynamoDB IA version, IA. That's just tables that are infrequently accessed, so they're slightly cheaper in terms of cost. But for this, we're going to keep DynamoDB standard. There's a capacity calculator if you're not quite sure what you need in terms of capacity, so this helps you work it out. I'm going to go for the provision mode. You do have the on-demand mode, which DynamoDB then looks after the scaling and the amount of read capacity units and write capacity units that you need in the background. This is more expensive. Depending on the region, it can be anywhere, in my experience, between 4 and 6.5 times more expensive than using provision mode. You do have auto scaling in provision mode, where after a response pattern that is acknowledged in CloudWatch, your DynamoDB table will scale out to a maximum capacity unit. So once 70% would be reached in this case, i.e. 7, it would scale out further. This can mitigate when you have peak loads in traffic. Just be careful with it because it does have cooling off and warming up periods. But for the purposes of this, we're going to turn it off and we're just going to have 2 capacity units. And here we're going to turn it off and we're just going to have 2 capacity units. We're not going to touch any of this yet. And if we scroll down, you can see that at the moment, this would cost me $1.32 a month. Because this is serverless, we don't have anything else to provision in terms of servers. We can scroll down to the bottom and hit Create Table. This will take a couple of seconds to create. You just hit this little refresh icon up at the top and it will go active and green when it's ready to be used. Okay, that's us creating the customers table itself. Let's insert some data into the customers table so we can have a look. So click into the customers table, then go explore items, and then what we can do is create an item. Our customer ID is our partition key, so let's call this 1. Then we want to add a new value, so let's call this just full name. That'll do. Full name. Do you know what? We'll put underscores. Full name, and we'll call this person John Doe. And then we want to add a new, and we'll call this country. And we'll say John Doe is in Ireland, like me. And then we'll create this item. Let's add another one. So the customer ID this time. Let's see what will happen when we put in customer ID 2. So let's do that. Then we want to do the same thing again. We want to go full underscore name. And then we'll call this person Jane Doe. And then we want to add a new attribute, add a new string, and we'll call this country. And we'll say that Jane Doe is based in France. Let's create this item. Now, what will happen if we use another customer ID here? So let's try. If we use the same customer ID again, and we'll call this 1. We want to add a new attribute, and we'll call this string. We'll call this full underscore name. We'll call this person then my name, Johnny Chivers, since we all know my name from my YouTube channel. And we'll add a new attribute, and we'll call this string. And again, we'll say country this time, and we know that Johnny Chivers is based in Ireland as well. Then we'll create the item. Oh, look at that. Look what we've just done. So you can't create a new item with the same primary key. Okay, what else then can we do? Well, we can just give it a new primary key. So let's do that for now and give it the primary key of 3. Now, you can update an item that has the same primary key. So if I click into this, there would be nothing stopping me updating the current item. And this can be done on the console of our API. It actually overwrites the entire attributes of the item, but you don't see that in behind the scenes. So for this purpose, let's say we got John Doe's name wrong, and John Doe was actually called Jack Doe. And then we save and close. So you can see there that we overwrote the existing item. We couldn't add a new item with it, but we could update the existing item. Let's go back out and create a table with a sort key so we can take a little look at what goes on in the sort key. So if we go back to DynamoDB, and we'll just go create table here, and we'll call this one customers underscore sort key. So we'll just put an SK at the end. Our partition key will still be a customer underscore ID. And then our sort key will be timestamps. So we'll just call it TS. We'll do the same again, custom settings, standard. We'll go auto scaling off, and we'll go to provisioned off. We'll go for 2 again, off. We'll not do anything with indexes just yet, and we will create the table. Okay, so this will take a little second. Doesn't matter, I've called it customer rather than customers this time. There's no issues there. That will be created. Just remember this refresh icon is your best friend sometimes. Click onto it, and let's explore items. Then let's create an item. So this time, let's do this. So we'll go 1 again. Then we need to give a timestamp. So I'm using the epoch converter. So just type in epoch converter. That'll do nicely. Let's get something from yesterday. So 7/31. And epoch timestamp is a Unix timestamp. If you're not familiar with it, it's how Unix does date times. And this will become important later for DynamoDB, but it's just something I use all the time to keep things coherent. Then let's add a new value here. Again, we'll call this full name. So let's create full name, and let's create John Doe. And E, and create item. Okay, do you remember last time we weren't allowed to update this item or create a new item? Sorry, rather, we were allowed to update the item. We couldn't create a new item. But this time, if I give this a different timestamp, so if I give this today's timestamp, and let's just say we're creating John Doe twice for some reason in our database, or we want to update something about John Doe. So actually, we got his name wrong, but we want to keep the old version as well of the record. Let's go for that. So we're keeping the old version. Then we can go full name, and we can call him Jack Doe and create the item. This time the item will be created because the timestamp is different, and this is our sort key. So we can have items with the same partition key, different sort keys, and these 2 attributes here form the primary key. So because the primary key is different, then we can actually look for these items. Now let's get a wee bit interesting as well and look at the query feature. So again, let's see how you query this table. So we could just type in 1 because we want all the customer IDs enter 1, so we've got 2, that's fine. But this time we can also then enter the sort key. So let's say we only want the sort key that is equal to the first value that we entered. Well, we'll run that, and then you can scroll down and you can see that we get John Doe. You can also say things like does not equal or less than or equal to, begins with, less than or equal to. So let's have a little look that if we do less than, we'll get nothing back because nothing is less than that time filter. And if we do greater than, we'll get the one record back, but that's the most recent record because it's greater than that sort key. Okay, so that's sort keys. That's how we query the data on the UI. Let's have a look at how we actually create local and secondary indexes. So again, let's go back out to DynamoDB. Let's create a table. Let's call this table customers local secondary index LSI. Okay, so this time again, we're going to go customers and ID. We'll keep timestamp as our sort key. We'll go custom settings, DynamoDB, provision mode, all the same again. Set this to 2, turn this off, set this to 2. Then you need to create a secondary local index. So we can do that here. So let's create a secondary local index. This is our other key. So we'll create one on country because we just want to sort things by key country. We'll do it in all the attributes so we can get everything back. And we'll scroll down and we will create that table. It's going to take a little second to create, and you can see that it's creating, and we have customer ID. Okay, so let's go then explore table items, and let's add or create an item. When I go into create items, then we have the 2 there, and we want to add a new attribute, and we want to add a second new attribute. So the next one will be country, which is our secondary local index, and the one at the end will be full name. So let's say this person is in Ireland. Let's say that their customer ID is 1. Let's just grab a timestamp from here. Let's put it here, and then full name can be John Doe. Again, it doesn't really matter. Let's create that item. This time, let's query that item. So you can see then that we have options here to enter the 2 that we have on all attributes or specific attributes. Let's just do all attributes. And then if we do partition 1 and we run, you can see that we get the country. Okay, so let's query the table again. So let's put in 1 and let's just cheat here and put in the TSI. So, or sorry, the TS from the table, and you can see we get that run 1 row back. But this time, because we have an index, we can hit index here, and instead of just entering the 1 for the customer ID, we can actually enter the country as well to filter. So in this case, I could enter UK and we'll get nothing back because there's no one from the UK, or we could enter Ireland and we'll get something back. So you can select your secondary index from the table against your local index, and again that's just on your partition key, but we're still forced to use the partition key as the customer ID because this is a local secondary index. Let's say then we go view index and we go indexes and we say, well, do you know what, we also want to create a global secondary index on this table because we'd like to search by country. So this time it'll ask us what our local or global index should be. So let's say it's country this time. And we'll have to give it a sort key because country isn't very unique. Now, the reason you would do this is because you might have a query that wants to return all the customers from a country and you're constantly running that query. So that's a good example of where you'd want to do something like this. To do this as well, you kind of want you do want a unique sort key. So in our case, we can just do customer ID. And this means then we can return people from countries and customers. We're just going to copy all the base settings and create the index. Okay, and then once it's started to create, it will take maybe 5 or 10 minutes. It actually spins up another DynamoDB table in the background and copies your data, so they're kind of 2 separate tables. I'll just wait here until it's ready. Okay, and then after about 5 minutes, the index is now ready. This is the global secondary index. So let's explore table items and let's create another item. So this time we'll give it a value of 2. Let's just get something out of the epoch converter that's completely different to what we have. I just typed in midday. Put it in. Then we need a country because this is going to be our partition key for our global secondary index. So we're going to go country and we'll call this person, we'll get this person into France. Then we will add another value and this person's full name like we've had before. And that person's full name can be Jean Bouquet. Okay, create the item. And you can see then we have 2 here. So again, we're just on the table as we had it before. This runs as you would expect. You can then enter attribute names or you can go query. Customer ID 1 We'll leave the sort key blank for now and it'll return that one row. If we put in 2, we'll get the other row, and then again you can query on that timestamp as well because it's the sort key. To get the global secondary index, then it's in indexes, and this time it is this one, country customer ID index, called this way, and you can see automatically our new partition key is country. So don't forget, with global secondary indexes, it's a totally different table. So let's leave it blank, and if we leave it blank, it will not run because your partition key cannot be empty. So let's put in France and run that, and we should get the row back, which we don't because it is case sensitive. So put in a capital F, unlike me, and you'll get the country back. And then because of bad data quality, I have Ireland as a lowercase at the start, but if I run that, I'll get Ireland back. I also have customer ID, so if I put 1 in, I'll get it back. But if I put 2 in, I'll get nothing back. So that's a global secondary index where you're basically creating a whole new table under the hood, and then you can query that global secondary index on a different partition key. Again, you can add a sort key or not add a sort key. I did. That's pretty much DynamoDB in a nutshell and what you kind of know to get started, but please continue to practice these skills outside of this tutorial. Amazon Lambda, so interesting one for the exam as well. Again, if you have 2.5 years experience with AWS or any other certification, you should be well aware of Lambda. It's a serverless computing service that allows developers to run code without provisioning or managing services servers rather. With AWS Lambda, you can execute code in response to events. I am actually going to focus on Amazon Lambda for data engineering since that's the purpose of the certification. There's no point me spending time talking about Lambda in general. So thinking about what you can use Lambda for in data engineering, you've got real-time data ingestion for the likes of a Kinesis stream. It could be a consumer. You've batch processing where data might land in S3 and you use a Lambda function to do something with that data. Data transformation, well, it speaks for itself. You could have an S3 file land in a CSV file land in S3. A Lambda comes across and actually does something with the file. Trigger-based processing, database replication, log processing, and you can even use Lambda to orchestrate other data engineering tasks. Benefits of using AWS Lambda for data engineering, bear these in mind through the exam for the questions. Scalability, cost efficiency, because when you pay for what you use. Reduced operational overhead because you're not managing the servers themselves, or the service for that matter, but it's fully managed. Integration with other elements of the AWS ecosystem, for example, Kinesis triggers or Kinesis actual consumers, and event driven, well, they happen with events. You can actually use them to trigger on events. Containers is becoming ever more popular in general in cloud computing. You can't kind of turn around and read an article a day without it. No difference for data engineering. So just a little bit of a brief introduction to what is a container. I will not spend a lot of time on this. Again, we'll just get back to what containers and data engineering can do together. A lightweight, standalone and executable package that includes everything you need to run a piece of software: code, runtime, system tools, libraries and setting. Or in our case, if we think it in terms of data engineering, this is an image. It would have the code that we need to carry out our data engineering task. Containers in AWS. So there's 3 core services for containers that you probably need to know about for this exam. The first is Amazon Elastic Container Service. The next one is Fargate, and then we have Amazon Elastic Kubernetes Service. All 3 of these very, very popular with AWS customers and ones that I've worked with, both past and present. Let's think about then containers on AWS and data engineering, which is kind of why we're here. So why would you use a container for data engineering? Well, portability, because you have everything you need to run the code, including the runtime itself, then you can port it anywhere you want inside AWS. Scalability, well, you can scale containers to run in parallel. Isolation, well, a container runs by itself, so if it gets corrupted or falls over, it doesn't affect things around it. And then efficiency, based on the fact that you can use all 3 of these. Looking at this is how Talaflow actually saved 60% by moving their data pipeline to Fargate. Again, this is the type of patterns you need to think about going into the exam. We'll kind of look at here, but basically data comes in through Flink, stored in S3. This is an event publishing system. Comes down, and eventually you can see here the Fargate is being used to pick up data, prep things in the storage, and then save it out into an RDS database. So you can see here when events off the Kafka stream happen, Fargate picks them up, and then using Fargate with an image stored in ECS, you actually process and store them into RDS itself, and they save 60% by moving to this. So it's a good example where you're just getting Fargate to do the processing, the data cleansing, the data transformation, and then storing it into RDS. And that's a full pipeline. As you can see, EMR running Flink into S3 into a event-based system, including SQS and Kafka. Then you can see that they're actually using Fargate based on a trigger system to read that data, cleanse that data, transform that data, and put it into the RDS instance. Amazon S3, again, if you have been working with AWS for 2.5 years or done any other certification, there is no way you don't know what Amazon S3 is. But just in case you have been completely oblivious to Amazon S3 this entire time, Amazon S3 stands for Simple Storage Service. It's been around for over a decade now. It's a scalable, high-speed, web-based cloud storage service. It is designed for storing and retrieving any amount of data at any time from anywhere on the web. You've got the 99.99 or 99% availability, and of course those 11 nines of durability. What we're actually interested in this case is S3 and data engineering. So data ingestion and storage, we're talking about data lakes really here. Data processing and transformation, store processed data. Data warehousing and analytics, well, data lakes again. Machine learning and data science, well, storing the data in S3, then using SageMaker or other data science programs to look at that data. This is all very, very common all the time. I see it all the time with customers, know it inside out. Data backup and archiving, sure, yep, back up lots of data, back it up from Redshift, back S3 up from S3, back it up from DynamoDB. There are a lot of automated tooling to help you do that. And then event-driven data processing. So S3, you can use an event where if data lands in an S3 bucket, you can actually do something with that data as the next step. Again, common things that you should know. S3 is really the core of data in AWS. S3 and data lakes, well, you can't turn a corner either these days without having some sort of data lake. So data lake is a centralized repository that allows you to store all your structured and unstructured data at any scale. We covered data lakes in a bit more depth during the fundamental section at the start of the video. If you haven't watched that, go back and watch it now. If you're familiar with data lakes, then fantastic. If you're kind of the middle of data lakes, also good. We'll do a little bit more. With a data lake, you can run and store your data as is without having to first structure the data, and run different types of analytics, from dashboards, visualizations, to big data processing, real-time analytics, and machine learning to guide better decisions. S3 stores the data. You can use other AWS services as integration points over the top. Oh, what do you know? We have an example. Of course we have an example. So again, from the AWS blog, and I see these types of architecture patterns with customers all the time. There's a lot going on. But realistically, what you have to know is that you've got S3 buckets down the bottom where they've actually went for the medallion pattern, which is kind of common. It used to be called bronze, silver, gold. Some people call it raw, decoded, enriched. It's the same thing. 3 stages. Data comes in through a Kinesis stream. This is IoT data from vehicles, I should say. So this is an example of IoT data from vehicles. Comes in through Kinesis. Using Lambda, it's then transformed on the fire hose, then wrote into S3. Again, then on the decode stage, so this is the raw data just being processed into S3. This little key thing means that it's encrypted. Goes to the decode stage where the data needs to be decoded, where the decode data is then stored in S3. Then again, this pushes on out through the transform stage and gets stored in DynamoDB for customers to look at only. Meanwhile, down here, there's a batch process running on EMR, which takes the decoded data and enriches it with other data so that internal users can use Athena that we've already covered, SageMaker for data science, which we'll take a little look at later. But again, this is the kind of architecture pattern. Data stored in S3, EMR to process, Kinesis is moving the data through the stages, DynamoDB is being used to store that data that needs to be wrote and accessed very quickly, needs to be written and accessed very quickly, and then our analytics is done down here on this enriched data, which is being processed by EMR. Athena is then used to look at the data, and we also have SageMaker here as well. Take a wee minute to look at this architecture. It could be something that comes in handy when doing the certification. S3 LifeCycle Policy can come up on the certification. Again, you should be familiar with this. This is a policy that you set in the S3 bucket that lets you manage the lifecycle of objects stored in S3. So you can write a lifecycle policy to say, hey, move this object into S3 one zone after 30 days of it not being touched because we want to save money, and then after another 10 days delete this item or move it to AWS Glacier, and therefore we're paying less for storage. You can also use it for GDPR protection, where you can say, well, actually I need to delete this data after 30 days. I'm going to write an S3 policy that says if the data has been in this bucket for 30 days, then delete it please automatically. Again, good to know for data engineering, so you don't have to write extra code running somewhere to do these deletes, and may come up on the exam, so that's why I have included it here. Amazon Lakeformation. There are already a couple of videos on the channel on Lakeformation. For those that aren't familiar, Lakeformation simplifies the process of setting up a secure data lake. It automates the steps involved in setting up a data lake, including data ingestion, storage, cataloging, transformation, and most importantly, security. You probably should know some stuff for the exam that kind of looks like this. AWS Lakeformation. So let's just kind of start here because this makes the most sense. This is where a customer is running a multi-lake. So you can see here they have 3 different data lakes. They have a shop floor, a logistic, and a foundry. You can see that the data is going into S3 here and here for the lake. They've registered it in the Glue Data Catalog, and they are using AWS Lakeformation to provide the access layer or access controls to the data lake. They then have a central data governance account here where they're using AWS Data Zone in a pub sub manner in order to actually let people get to the data based on access controls. So AWS Lakeformation being used to set up the data lake, control access IAM policies to that data lake. Data zones being used then for users to access the data or ask for access to enter the data, and then users or owners of that data grant access to people who request it. This is again a very common pattern. Takeaways for the exam: AWS Lakeformation lets you set up a secure data lake. It helps you with IAM, and then data zone can be used with Lakeformation in order to let people find the data, catalog the data, make it discoverable, and then request access. More on AWS databases. So you will need to know more databases than possibly you'll ever use in your lifetime, but we'll just cover them quickly, and then we'll talk about where they come into play in terms of data engineering. So Amazon RDS stands for Relational Database Service. It's a managed database service from AWS that simplifies the process of operating and scaling relational databases in the cloud. You should know that there are different types of RDS engines. I am sure you have encountered these through your data engineering career. We have Amazon Aurora, which is compatible with MySQL and Postgres. We have MySQL RDS. We have Postgres RDS. We have MariaDB RDS. We have Oracle RDS, and we have Microsoft SQL Server. Other databases you might need to know about is AWS TimeStream. So TimeStream is a fully managed, scalable, and serverless time series database. It's designed specifically for storing and analyzing time series data. Kind of the important bit. So if you have a question in the exam that's talking about time series data, you should be thinking Amazon TimeStream. Common for use cases include monitoring and observability, Internet of Things applications, industrial telemetry, and real-time analytics. So in the exam again, if you see time series data, think TimeStream. Amazon Neptune, you should also be aware of, is a fully managed graph database service. It's designed for applications that require high connectivity to data or high connected data sets that can efficiently store and navigate relationships between data. Again, for Neptune, if it comes up in the exam, think about relationships. So if someone's trying to store relationships in a database, think Amazon Neptune. Now for the more important bit, AWS databases and data engineering. What about all these databases? Because if you go too deep into the databases, you're in a DBA world, as in a database administrator world, when really the exam is data engineering. So we need to be thinking about these databases in terms of data engineering, not necessarily in terms of database administration. So what's great for this is the blogs on AWS, and you can see again, this is an example where we have AWS in the cloud up here. We have business applications here. Data is being produced and stored in RDS. You can see here we have Amazon Aurora MySQL, Amazon RDS for MySQL, and we have Amazon Aurora Postgres. Using zero ETL integrations, a feature that you will need to know about for the exam, that they have zero ETL into Redshift. This data is being transformed and moved into Redshift or loaded into Redshift, ready for analytics, and then you can see here that they're running QuickSight dashboards over the top. So transactional data from business applications stored in Amazon Aurora. Zero ETL integrations between Aurora and Redshift. We covered that in the Redshift section. Redshift is then being used for the business analytics dashboards from Amazon QuickSight, and you can see quite quickly how you start to piece together the data engineering infrastructure and tasks that you require. Another example which is good to know about is the green-blue deployment for data engineering. Again, blurring the lines slightly, but you can see here that you can have a green and blue deployment. Blue is your old deployment. Here they're using logical replication to replicate the global databases across. Once everything is good to go, then they switch off the blue database and everything moves to the green database. So again, this is using Postgres here, Aurora Postgres, and they're doing replication into the green. Once all the data has been moved, they turn the blue off, and this is mainly for the likes of upgrades to the cluster. Again, another good example that I see all the time come up when I'm working with customers is that you can have Amazon DynamoDB, data goes on the streams. You can use a Lambda function as a trigger on the stream, and it stores that data into Amazon Aurora. And then once the data is in Amazon Aurora, you can do something else with it. Maybe zero ETL into Redshift, then use QuickSight into Redshift. But this is a very good example. Again, I've left the link down the bottom for you to go have a look if you want. AWS Application Discovery Service. Again, this kind of sits in the realms of databases, but not really, but seems to go time and time again together. AWS Application Discovery Service is a tool provided by Amazon Web Services. Let's organizations plan migrate projects by gathering information about on-premise data centers. It automatically collects detailed information about on-premise servers, applications, dependencies, and resource utilization. It's a blurring between where a data engineer would sit and a migration specialist, but if you were asked as a data engineer, how do I discover applications sitting in a data center I want to move to AWS, including the data, you should be thinking Application Discovery Service. Features, agent or agent list. There's one where you can install an agent. There's one where you don't have to. Application dependency mapping, important to discover those data stores, and integration with AWS Migration Hub. AWS Database Migration Service is something you definitely should know about. Again, there are videos on the channel on this. DMS, as it's known, is a managed service that facilitates the migration of databases to AWS. It supports the migration of data between different database engines, making it the ideal tool for both homogeneous and heterogeneous migration. So homogeneous would be where you're migrating from one database engine to another database engine that are the same, i.e. homo. If they are different database engines, like I am going from Postgres to MySQL, that is a heterogeneous migration. So if you need to migrate data from on-premise or in the cloud between two different or two same database engines, you can use DMS for that purpose. Well, it's great when you have a blog. So this is a great example from the AWS blog of how you can actually move from SQL Service database into DMS, and this is on-premise to Amazon RDS for SQL Server database target. So here you can see that they did a backup and restore of the database from on-premise to the SQL service. They then set up a DMS task that replicated the changes to the data into SQL Server. Then once it had caught up and everything was in SQL Server in AWS, you can shut off this instance. Common pattern for migration, common pattern for migration between databases and between different databases as well. In this case, it's SQL Server, Microsoft SQL Server, from on-premise to the cloud. AWS Snow Family, something you need to know about. Not overly commonly used, but can come up. So the AWS Snow Family. AWS Snow Family is a collection of physical devices designed to transport large amounts of data to and from AWS. These devices are particularly useful in scenarios where transferring data over the internet is impractical. So these are physical devices that AWS send to you as a customer, and then you can upload data onto these devices, send them back to AWS, and they will put them into S3 for you. The Snow Cone is the smallest portable member of the Snow Family. Provides 8 terabytes of usable storage and can operate in challenging environments. So there you go. Snow Cone is the first one you need to know. Snowball Edge is a storage optimized. This variant is designed for 80 terabytes of usable capacity. It also supports an optional compute capabilities for edge applications, which is called Snowball Edge Compute Optimized. In addition to data transfer and storage, this variant includes more powerful computing resources, including GPUs for machine learning, analytics, and processing of high-resolution video data at the edge. These are very common. If you have too much data in your data center to migrate to AWS, you upload them into the Snow Family, be that Cone if it's a small data center, Edge if it's a bigger data center, or even multiple edge compute devices if you need to do something with that data. It's also very good for disaster situations or wartime situations where you need to get data out of a country. Application integration. Some of the services that we're about to hit are more recent developments in AWS than others. As a data engineer, you should know about these services because It can help you create effective data pipelines without having to code things from scratch. AWS SNS is a notification service, lets you do a variety of messaging patterns used in data engineering so that you can actually notify users of like a successful task, or if you want to do something with a failed task. SQS enables the decoupling and scaling of microservices, distributed systems, and service applications. Allows you to store and receive messages between software components. This diagram is very interesting, where we would actually be doing things with an AWS blog again. Kind of shows you how to handle error patterns for AWS Lambda. This is to stop you getting into a loop of AWS Lambda retries. You can see here that we're using AWS Fargate to request a store to store data into S3. If the Lambda fails, or if the Lambda is unsuccessful, it will go to SQS. The SQS Lambda will then try again for that while using DynamoDB to keep an update of the status. So SQS used for integration as a queuing service between components on AWS. Amazon AppFlow, more recent than the other two, is a fully managed integration service that allows you to securely transfer data between AWS services and software as a service application. So when you're thinking SaaS, when someone says, I need to ingest data from a third-party application, you should be thinking Amazon AppFlow when it comes to the exam. That is bi-directional, where data can come into AWS from SaaS or it can go out. It also integrates with AWS services themselves. So this is straight from the AppFlow AWS reference page. You can see here that it can ingest data from Salesforce, SAP, Google Analytics, and lots more. Then you bring it into AppFlow. You can do certain things with the data inside AppFlow, including masking and filtering, and then push it down to AWS services. So it helps you integrate those third-party data sources into AWS. So in the exam, for example, if it said you're working for a company and it has Google Analytics data from its website that it wants to ingest to AWS and make available in S3 to be analyzed by Athena, you should be thinking AWS AppFlow is the solution that I need to use. Amazon EventBridge is a serverless event bus service that facilitates event-driven architectures by allowing applications to redirect events from a variety of data sources. EventBridge enables seamless integration and orchestration between different services. EventBridge, the title kind of gives it away. So when you're talking about events, if you want to send it around AWS in a serverless manner, again, that's important. It is serverless. Then you should be thinking EventBridge. This is straight from how you can convert Apache Kafka events from Avro to JSON using EventBridge pipelines. So here we have Apache Kafka, managed Apache Kafka coming in to Amazon EventBridge as an event using Amazon Lambda to enrich the information, and then you send it out on a target event bus, which you can see here, and then this can be consumed downstream by other AWS services or Lambda. Again, look at this for reference when it comes to data engineering. We're using Amazon EventBridge pipes here, where we take a message in, we convert the message, and then we put it on a target event bridge bus here, and then that makes it available for consumption downstream. Typical pattern you would see using Amazon EventBridge. And then lastly, in terms of services, blurring the lines slightly between data engineering and data scientists, because the exam has this and asks us to know about it. You should be aware about Amazon SageMaker being a fully managed machine learning service that simplifies the process of building, training, and deploying machine learning capabilities. While SageMaker is primarily known for its capabilities in machine learning model development, it also offers several features and tools that are valuable for data engineering tasks. Let's take a look at those tools. So the first one you should know about for the exam is AWS or Amazon SageMaker Data Wrangler. It's a tool for the visual data preparation of data. It simplifies the process of cleaning, transforming, and analyzing data without the need for extensive coding. It helps integrate, or does integrate, with SageMaker notebook instances, enabling users to perform transformations interactively and prep data for training and analysis. This is an example of how you can redact PII data for machine learning using Data Wrangler. You can see that it's right up here in the corner. So this is the preparation stage where you use AWS Data Wrangler to look at the data from AWS Comprehend, identify the PII data and remove it. Then you have AWS pipelines where you're actually moving the data through, including deploying the model. You will not need to know about AWS SageMaker registry or deployments probably for the exam, but what you should know about is AWS Data Wrangler that lets you perform data engineering tasks in a visual manner. You should also be aware of Amazon Feature Store. This is a repository for managing features. Features are used in data science to actually create your inference. So they're kind of like a variable or a piece of data that comes in through data engineering, and then you create a feature out of it. An example of this that you would see commonly would be like if you had MF in your data set and you also had male, female, and you had boy, girl, then creating features might change everything to male and female that you see. You'd make those mappings as a data scientist, change that, and that is now a feature that you could use for predicting gender or spending based on the sex of an individual. This is an example of how you would use SageMaker Feature Store. This is where data comes in through SageMaker or through user activity log into SageMaker. You create those features and you store them in Feature Store. Again, you need to know that this is just a feature that you store feature stores in from an AWS service. And then using SageMaker endpoints, you can actually then use the data from Feature Store to create that inference in terms of your AWS. So again, for the purposes of the exam, for SageMaker, be aware of the feature store where you store features, which are pieces of data that you have translated into features. Again, that example would be changing M into male, F into female, boy into male, girl into female. And then also for the exam, be aware of AWS Data Wrangler, which is a visual tool to help you cleanse and prep data. Okay, folks, now we've went through everything in terms of theory and practical that I've listed out. Let's take a quick look at what an exam question could look like. I'll pop it on screen. Once we've read it and the answers, or the possible answers, we'll pause, and then I'll guide you through what I see as the answer. So on screen now, you'll see the question itself. It will say, you are collaborating with a highly regulated company that intends to implement a new streaming solution using Amazon Kinesis data streams. The company has a strict requirement that all data placed onto the stream must be encrypted. Additionally, they want to maintain control over key rotation to ensure data security. Which solution best meets these requirements? Next, in the exam, you'll be presented with 4 different answers or multiple choice. It may not be 4, it may be more, but in this instance, it's 4. And from that 4, you'll have to select the correct answer. So let's look at the 4 possible answers on screen now. Data is automatically encrypted when using Amazon Kinesis data streams, therefore no further action is required. B, enable encryption and rotate key option when creating a Kinesis data stream. C, use a KMS customer master key to encrypt data on an AWS Kinesis data stream. Or D, a customer should hash the data before placing it onto a Amazon Kinesis data stream. Pause the video, think about the answer, and let's discuss it together. Okay, answer coming. So the answer is C, so I'll put that on screen. Use a KMS customer master key to encrypt the data on Kinesis data streams. Now, looking at the explanation, and I'll put this on screen as well so you can read it. Server-side encryption is a feature in Kinesis data streams that automatically encrypts data before it's at rest by using an AWS KMS customer managed key, or CMK, you specify. Data is encrypted before it's written to the Kinesis data storage layer, and then it's decrypted after it's retrieved from storage. As a result, your data is encrypted at rest with the Kinesis data stream service. This allows you to meet strict regulatory requirements. So you have to know, in terms of this question about Kinesis data streams, you have to know about the KMS service, the key management service. You have to know that you're able to encrypt data before entering the stream. Now, if you didn't know that, you now do. So that's one of the areas of the exam ticked off at least. But if you want more practice with these types of questions in an exam type environment, then I have left a link at the bottom to the Udemy exam and practice tests that I have created based on my knowledge as an AWS solutions architect for over 10 years and sitting AWS certified exams myself. So hopefully you have enjoyed everything that we've done today. Don't forget about the revision guide. Don't forget about those exams as well if you're interested, or just visit my website or to buy me a coffee. I really appreciate a like and subscribe to the channel. I wish you the best of luck in this certification. Make sure you do extra reading and extra work around this as well. Not only this course, do the white papers, read through the AWS documentations, even go through the blog architecture like we did on the slides today. But until next time, guys, thanks for watching.